Hi everyone, welcome to the Simplilearn YouTube channel. This session will be about Python for beginners. Before we begin, let me inform you about the daily updates on multiple technologies on our channel. If you love hunt for technological stuff, consider getting subscribing to our YouTube channel and don't forget to hit the bell icon to never miss an update. We from Simplilearn bring you this beautifully designed, organized and upgraded Python full course for beginners for 2022. Now, let's get started with today's agenda. First, we will start with the briefing on Python programming language. Then, we will learn to install Python on Windows and write our first program in Python. After that, we will start with basic concepts, that is, variables and data types in Python, numbers in Python, Python object types and type conversion, strings in Python, and operators in Python. Now, understanding the basic concepts, we will educate ourselves with if statements in Python, followed by the Python loops, Python loop coding techniques, control statements in Python, and conditional statements in Python. With that, we will develop a good hold on the basic concepts. Now, moving on, we will start with Python lists, tuples, dictionaries, and list comprehension in Python, followed by Python functions and lambda function. Further, we will have hands-on map, filter and reduce function in Python. Moving on, we will get ourselves educated with classes in Python, inheritance in Python, iterators and generators in Python, string formatting in Python, scopes and arguments in Python, OOPS concepts in Python, and operator overloading in Python. Finally, we will be encountering some language building concepts, that is, modules in Python, packages in Python, file handling in Python, exception handling in Python, and our concluding concept that would be sorting in Python.
What is Python? Python is a high-level object-oriented programming language developed by Guido van Rossum in 1989 and was first released in 1991. Python is often called a batteries-included language due to its comprehensive standard library. A fun fact about Python is that the name Python was actually taken from the popular BBC comedy show of that time, Monty Python's Flying Circus. Now, let's look at the top features of Python. First, Python has a simple structure and a clearly defined syntax. This allows the learners to pick up the language quickly, so it is easy to learn and use. Python can run on different operating systems such as Windows, Linux and Mac, making it a portable language. It enables programmers to develop the software for several competing platforms by writing a program only once. Third, Python is freely available at the official website. Since it is open source, this means that source code is also available to the public. Now, Python uses an object-oriented approach that encapsulates code within objects. Python provides a collection of libraries for various tasks such as machine learning, web development, and data analysis. And finally, in Python, you don't need to assign the data type of the variable. When you assign some value to the variable, it automatically allocates the memory to the variable at runtime. Now with that, let's move on to the uses of Python programming. So Python programming language is used to develop desktop applications and build web applications too. It is popularly used in the field of data science, machine learning, and artificial intelligence to analyze data, build predictive models, and make business decisions. Python is also widely used in game development. Now, let's see some of the popular Python frameworks and libraries. Python can be used for web development using frameworks like Django, Flask, Pyramid, and CherryPy. Now you can build graphical user interfaces using libraries and frameworks such as tkinter or just Kinter. You can also use PyGTK, PyQt, or PyJS or Python JavaScript. Now Python is also used to perform machine learning tasks using libraries such as TensorFlow, PyTorch, Scikit-learn, Matplotlib, and SciPy. You can also perform mathematical computations using Numpy and Pandas. Now let's look at the best IDEs that you can use to write programs in Python and perform specific tasks. So we have Jupyter Notebook, which is part of the Anaconda distribution that is widely used these days. Even for our demo in this video, we'll be using Jupyter Notebook. I'll show you in a while. Then we have the Visual Code Editor from Microsoft. This is also one of the preferred IDEs by learners and companies. Then we also have the popular text editor called Sublime Text Editor. Then we also have PyCharm, followed by Python IDLE and Spider as our top IDEs. Now let's look at the top companies that are using Python in our day-to-day work. So we have Google, Quora, Facebook, even Netflix, Spotify and Instagram. Now there are other top product-based, service-based and startups that also use Python programming. Okay, now with this theory, let's move to our Jupyter Notebook where I'll show you how to write basic Python code. So I have my Anaconda distribution of Python already installed and I'm working on a Windows system. So I'll search here for Jupyter Notebook. You can see here I have my Jupyter Notebook Anaconda 3 installed. Let me just open it. Now this will open on a web browser. You see here this is my Chrome browser. Okay, so here I have some Python notebooks already created. Now for our demo, let me go ahead and create a new one. So here I'm going to click on new and then I'll select Python 3. This opens in a new tab and here I can write whatever code I want. Alright, so first let's see how you can print a simple sentence or a text in Python. Now to print something, you can just use the print function. If I write print within brackets, suppose I want to print my country, that is India. Now India is actually a string, so I need to pass in within double quotes. So this is it. If you want to print something, you can just use the print function and pass within the function whatever you want to print. And now to run this cell, I just need to click on this run button, or you can hit shift enter to run this cell. I'll just hit shift enter. You can see it here. It has printed India for me. Alright. Now let's say you want to perform some simple mathematical calculations. That also you can do it. Suppose I want to find the sum of 10 plus 50. I'll just run this cell. You see here it gives me 60. It's very simple. Similarly, if you want to find the product of, let's say, three numbers, I'll write, let's say, 40 multiplied by 2 multiplied by 5. If I run this, you get the result, that is 400, which is correct. Okay. Now to store our values, we can take the help of a variable. Suppose if I write x equal to 7, this means that my value 7 is stored in the variable that is x. You might be aware that in other programming languages also we have variables and data types, which I am going to tell you now. So here I have assigned my value 7 to the variable x. Now let me go ahead and print what is there in x. If I run this cell, there you go. It gives me 7, which means x holds the value of 7. Now if you want to check the data type of x, you can use the type function in Python. So if I write type of x and if I print it, it will also result in the type of data that x is holding. You can see here the first print statement prints the value of x, that is 7, and the second print statement gives me the type or the data type of x, which says it is of class integer or int. Cool. Now let me show you how you can use the input function to take user inputs. Suppose I have a variable x where I want to store some numbers. I'm going to use the int function, and inside the int function I'll give my input function. So when I run it, it will ask the user to input a number. I'll write enter number X. Okay. Similarly, I'll just copy this, come to the next line. I want to create another variable called y, which will have another number. I'll write enter number for y, and then I'm going to print the addition. So I'll write addition of x and y is, give a colon, and then I'll pass in the operation within brackets, that is x plus y. Okay, so essentially what I'm doing here is I am assigning the value of my first number to x, then I'm assigning the value of my second number to y, and then I'm finding the sum of x and y. Let me show you the result. If I hit shift enter, it is asking for the user input because I had defined my input function. So it is asking enter number x. Let me give my number as, let's say, 30. I'll hit enter. Again it is asking for my y input. Let's say I'll give 60, and then I'll hit enter. There you go. It has returned me the addition of 30 and 60, that is 90. You can see the message as well, addition of x and y is 90. Cool. Now let me show you how to add two strings, and we'll compare the results when you add two strings and two numbers. So basically, when you add two strings, it is going to merge both the strings or concatenate both the strings. The way to do is, I'll just copy let me copy all the 3 lines of code from the top. I'll paste it here. Now I'm going to remove the integer function that I had used. The integer function was actually used to typecast the input to integer. But now I am going to take the values in terms of text or string. Now let's see the difference. If I run this, let's say I'll enter my number as 10, and then my second number would be, let's say, 20. If I add 10 and 20, it is going to merge both the numbers and return me 1020. So when you add two strings, it is going to return you the merged value of both the strings. Alright, now let's go ahead and explore some of the popular data types in Python. Now I'm giving a hashtag and typing data types. This means anything followed by the hash represents a comment. So in other programming languages also we have comments. Similarly in Python, if you want to write a comment, you can give a hash and pass in the comment. So first, let's say I have a variable a which has a value of 7, or let's say 10. Now if you were to find the type of value that a variable is holding, you can use the type function. If I run this, it gives me integer because 10 is an integer. Let's say I want to find the type of value -7 is. Now if I run this, again -7 is an integer. Let's say I want to know what 3.5 is actually. If I run this, it gives me float because 3.5 has a floating point or a decimal point. Similarly, let's see another example. I'll write -2.4566. If I run this, again this is also a float value. Similarly, now let's write a complex number which has a real part and an imaginary part. Let's say I write 7 plus 10j. If I run this, there you go. This is a complex number, hence it has returned the value as complex. Now if I just write 10j, let's see what it represents. Again, it's a complex value. Now let's pass in a Boolean value. Suppose I write true. Now true and false are Boolean values, so ideally our Python should return Boolean only. There you go. You can see it has returned us Boolean. Now let's move ahead and explore some of the popular objects in Python. So we'll start with list. List is one of the popular objects in Python. Now to declare a list, I'll create a variable called, let's say, L1. I'll give an equal to, and within square brackets I'll pass in my list. List can hold data of multiple data types. I'll show you now. So John here is a string. I'll give something like 102 could be the employee ID of John. I'll give USA, let's say the country to which John belongs to, and I'll give a floating point value, let's say 180.5, assuming it's centimeters, and this is John's height, suppose. If I run this, you see I have created my list, and if you want to print it, I'll just write L1. There you go. So here I have my list L1 printed. Now suppose you want to check the type of L1. You can use the type function again and pass in the variable that is L1. There you go. It tells that L1 has the values in the form of a list. Similarly, you can create list of the same data type, let's say only of numbers. Okay. Now if I just print L2, you can see L2 has only numbers. Similarly, you can check the type of L2. If I run this, it is also a list. Okay. Now another popular object in Python is called a tuple or tuple. Now the only difference between a list and a tuple is that lists are mutable, which means once you declare a list you can change the values, while tuples or tuples are immutable, which means that once you declare a tuple you cannot change the values. Now another difference is that list is written within square brackets, but when you assign a tuple it is within normal braces or round brackets as you say. So I'll create a tuple called tup, and within brackets I'll give the values. Let's say I want to give the values of vehicles or cars. So brands of different car we have in this tuple, let's say BMW, then we have Audi, next we have Mercedes, let's say Jaguar. Okay. Now you can use the print statement to print the tuple, and let's say I also want to print the type, so I'll use the type function and pass in my variable that is tup. If I run this, you can see the first print statement prints the values present in the tuple tup, and then we have the type. You can see it is of type or class tuple. Now next we have our third object, which is called a dictionary. I'm giving comment here for readability. Okay. Now dictionary consists of key value pairs, and are again mutable objects just like lists, which means you can change the values of the dictionary once they are assigned. And dictionaries are written within curly braces. Let's say I want to create an employee dictionary. So I'll give my variable name as employee and then start with my curly braces. First, I'll give the key, say the name, and then we have the name of the person in terms of value, that is John. Next, we have his age. Let's say age is 29. Now one thing to remember here is the keys should be passed within double quotes, and if the value is a string you can pass within quotes, but if the value is an integer or a floating point number you don't have to pass within quotes. Let's say I want to have the salary of John as well. Again, salary is in terms of number, so you don't have to pass it within quotes. Let's say the third information or the fourth information I have about John is the company in which he works. Let's say John works at Oracle. So I have my dictionary defined. Now I'll write print my dictionary employee, and then I also want to check the type. Okay, let's print. There you go. So the first print statement prints the dictionary employee, and then we have the data type of my dictionary employee, that is DICT, which means dictionary or dict. The fourth Python object we are going to discuss is called a set. Now even a set is created using curly braces like how we have used in the dictionary, but the difference is sets do not contain key value pairs, but they can only contain unique values. Now let me show you what I mean. Let's say I want to create a set that has only unique values of months. So within curly braces I'll pass in my month names. Let's say Jan, then I have Feb, then I have MAR for March, let's say APR for April. So this is a set, and if I want to print I can just pass in the variable name, that is month. Let's run it. Okay, you can see it here, it has printed my set which is not in an order. Okay, now you can also check the type of the variable, that is month. If I run it, you can see it here, it is of type or class set. Now the difference I want to show here is, as I mentioned, set can only contain unique values. Suppose I have another value of month, let's say February, FEB. If I run this, I'll remove this. If I run it, you can see here still my set has only unique values, so it does not consider any duplicate values. Alright, now moving ahead, we'll explore how to extract certain values from the Python objects. We'll be using different techniques, be it indexing or slicing. Okay, so if I go to the top, I had created a list called L1. Let me print L1 again. Okay, so these are the values that I have in my list L1. Now let's say I want to print the first element in my list L1. The way to do is I'll use my print statement. I'll give my variable name, that is L1, and within square brackets I'll give the index, let's say 1. If I run it, it gives me the value 102. The reason being In Python, the index values start from 0. So the first value is at index 0, then the second value is at index 1, the third value is at index 2, and the fourth value is at index 3. So if we are to find what is there at index 3, I just need to replace 1 with 3. If I run this, you see it here, it gives me 180.5, which we had assumed to be the height of John in centimeters. Now you can also do this without even using the print statement. That is the beauty of Python. If I write L1 and within square brackets, let's say I write 2. If I run this, it gives me USA, because USA is the value that is present at index 0. So very important thing to remember while indexing or slicing is that the index values start from 0 and not 1. So if you are to find the value where John is present, you need to use 0 instead of 1. If I run this, it will return me John. Okay. Now you can also use negative indexing. Let's say I write L1 minus 1. You can take a guess what this will return. If I run this, it returns me 180.5. When you use negative indexing, it will start from the last position. So minus 1 is actually this index. Let's say I'll write minus 3 and see the result. It gives me 102, which is fair enough. If you start from the back, this is minus 1, USA is at minus 2, and at minus 3 we have 102. Alright. Now also you can use slicing. Let's say I'll write L1 within square brackets. I'll give, let's say, from 1 to 3. So I want all the values present from the first index, which is this, till the third index, but excluding the third index. If I run this, it gives me 102, which is at the first index, and then USA, which is at the second index. Now in Python, the last index is exclusive, it is not included. So in case you wanted to print 180.5 as well, you have to change this from 3 to 4. Now if I run this, you get 180.5 as well. Okay. Now moving ahead, there are some basic functions that you can use with Python objects. For example, if you want to add any new value to your list L1, you can use the append function. Suppose I write L1 dot append. Let's say I want to add the vehicle or the car that John has. Let's say I'll write append Range Rover. If I run this and let's print L1 again, you can see it here, we have appended or added a new value to our list L1. Cool. Now you can also use the reverse function in Python if you want to print the list in reverse order. So let's say I want to print the elements present in L1 in reverse order. I just need to write my variable, that is L1, followed by dot and the reverse function. It's very simple. If I run this and I will print L1 now, it prints my list in reverse order. Here it was from John all the way till Range Rover. Once I reverse it, it starts from Range Rover and all the way to John. Cool. Similarly, you can also extract specific values from tuples and dictionaries. Let me show you. I'll just go to the top and okay, so we had created a tuple called TUP. Let me print that tuple again. So these are the values of the different brand of cars we have in the tuple. Let's say you want to find the car that is present in the second index. So you can just write 2 within square brackets. So I have my tuple name followed by the square brackets, and then I have my index. If I run this, you get Mercedes, and again in Python tuples the index values start at 0 and not 1. So BMW is at index 0, Audi is at index 1, Mercedes is at index 2, you see it here, and then Jaguar we have at index 3. Again, you can use slicing by using colon, and you can also use negative indexing. Let's say I'll change the value from 2 to, let's say, -3. See the result. You see here we have Audi because this is -1, Mercedes is at -2, and Audi is at -3. Okay, now you can extract the values in the dictionary by using the keys in the dictionary. Let me go to the top and see the dictionary that we had created. It is employee. Let me print it. Now in Jupyter Notebook you can also use the tab to autocomplete a variable name or a function name. Is one of the features that Jupyter Notebook provides. So here we have the employee dictionary, and let's say you want to print the value of salary. The way to do is I'll write print employee dot, I can use the get function, and within the get function I'll pass in my key for salary. If I run this, you see here it gives me 2,50,000, which is the salary of John. Similarly, if you want to, let's say, update any value in the dictionary, you can use the update function. Suppose I want to update the company of John from Oracle to, let's say, Google. The way to do is I'll write my dictionary name, that is employee, followed by the update function, and then within curly braces I'll pass in my key, that is company, give a colon, and change it to, let's say, Google. Now I can just print my employee dictionary. There you go. So from company Oracle we have changed it to Google now. So these are some of the very crucial features or important features that are available in Python, which helps you do a lot of calculations and data manipulations. Alright, next let's see how to use an if-else condition or an if-else statement in Python. Like in any other programming languages, be it C, C++ or Java, you have if-else statements. In Python also we have if-else statements. So basically you check some condition and return a value. Suppose I have a variable called a which has a value of, let's say, 400. And then I have a variable called b which has a value of 250. Okay. Now I'll use a if condition. I'll write if b is greater than a, then print b is greater. Now you will also have an else statement. I'll write elif, which means else if a is equal to b colon, then print a and b are equal. Finally I'll write my else statement, else print a is greater. So what I am doing here is I have assigned two variables a and b to value 400 and 250 respectively. Then I am writing an if-else condition. So I'm checking a condition if b is greater than a, which means I'm comparing if 250 is greater than 400. In case it is true, then print b is greater. Else if both the values, if they are same, then print a and b are equal. Otherwise, print a is greater. Let's run it and see the result. This is fair enough. It prints me a is greater because b is not greater than a. So 250 is definitely not greater than 400. So this condition fails. Even the elif condition fails. Only the final condition else is true, that is a is greater than b. So this is a simple example of using the if-else condition or the if-else statement in Python. Now moving ahead, let's see how to use a while loop in Python. Now using the while loop, you can execute a set of statements as long as a condition is true. Let me show you a very simple example. I'll write I equal to 0. So I have assigned value of 0 to I. Then I'll write while I is less than 8, then I'm going to add I. So I'll write I equal to I plus 1. I'll use another condition if I equal to 4, give a colon, and then I'm going to use a statement called continue. I'll print I. So using the continue statement, you can stop the current iteration and continue with the next iteration. Let's print the result and see. Okay, so here we are checking if I is less than 8. So first value is 0, 0 is less than 8. Then I am incrementing the value of I to 1. So I becomes 1 now. So from 0 it becomes 1. Then I am printing I. This condition continues until we have the value of I equal to 4. So if the value of I is equal to 4, I am skipping the current iteration. So if you notice the result, after 3 we have 5. So we have skipped printing 4 and gone to the next value of I, which is 5. So the loop runs till this condition fails. So when I is not less than 8, the loop terminates. Alright. Finally, in our demo, let's see how a for loop works. So a for loop is used for iterating over a sequence that is either a list, a tuple, a dictionary, a set, or a string. So let me go ahead and create my tuple tup equal to, let's say I have the same brand of cars. We have BMW, then I have Audi, let's say I have Mercedes, I have Jaguar, and then I have BMW again. Alright, I'm going to print the values present in the tuple one by one. So for that I'm going to use a for loop. So I'll write for a variable x in my tuple. I'll say print x. So what it will do is this randomly assigned variable x will iterate through all the elements in the tuple and print them one by one. Let's hit shift enter to run it. There you go. You can see here I have all the different car brands printed one by one. Cool. So this brings us to the end of our demo session on Introduction to Python. Let me go to the top and tell you what we did. So first I told you how to print any set of statements or any string, text, numbers. In Python, you just use the print statement or the print function. You can also perform very simple mathematical calculations using Python. Then you can also check the data type of the variable using the type function. Then we saw how to use the input function. Here we inputted an integer and then we found the sum of both the integers x and y. The value was 90. In the next example, we removed the integer function by considering our values as strings, and then we saw the difference in the results. So when you use strings, the addition operation will concatenate or merge both the strings or the numbers. Then we saw the different data types. We saw about integer data types, about floating data types, Boolean data types. If I scroll down, we saw the important Python objects like lists. Then we had tuple. Then we saw how to write a dictionary, how to create a set. Then we saw the difference between list and tuples, and even how set can take only unique values. Then we used some indexing operations to extract specific values from lists, tuples, dictionaries. We also learned some of the important functions. These are all inbuilt functions that Python gives us to perform manipulations and operations in Python. So you used append, then we saw how to use reverse. Now let me just go ahead and show you another function, an inbuilt function in Python. I'll just insert a cell below this. Suppose you want to find the length of your list, you can use the length function or len function that is inbuilt in Python. I'll just pass in len followed by my list, that is L1. If I run this, it gives me the result 5, because you can see it here. My list has 5 elements in it. You can count it, so the length becomes 5. Similarly, you can also check the length of the tuple. Let me insert a cell here as well. Suppose I write len of my tuple, that is tup. If I run it again, it says 5. Now this was the earlier tuple that we had created. Later we actually created another tuple. Let me show you. Okay, so this was the tuple. It has taken this new tuple which has 5 values in it, so the length becomes 5. Let me go to the top. Okay, and after that we learned how to use if else, followed by how to write a while loop, and then finally we saw how to use a for loop in Python.
In this session, we will learn how to install Python and install Numpy, SciPy, Matplotlib and Pandas libraries. Then we will install the Anaconda distribution in our system. So let's start. As you all know, Python is an interpreted language. So you need to install a Python interpreter. So for that, we'll go to the browser and search for python.org. Now we will move to the downloads page and choose the latest version of Python to download, and the latest version is Python 3.9.5. We'll click on the download. Once the installer has downloaded, open it. Now you can see the installation window for Python. You have to double check both the boxes, add Python 3.9 to path and click on install now. As the installation completes, you can see a screen that says the setup was successful. Now click on close. Now to check whether the Python has been installed successfully on the system or not, we will run a command on the command prompt. Let's open the command prompt, click on start and write cmd. Now to check whether the Python is installed or not, we will run the command python ---- version. Python space ---- version and press enter. So here we can see that Python 3.9.5 version is installed in the system. So yeah, Python is working in the system. Now we'll run some commands for Python. So for that, first we will type py and press enter. And now we will write the basic command, that is print bracket hello world semicolon and press enter. As you can see, hello world is printed here. So yeah, Python is started working in our system. Now we will install libraries of Python. We will be using pip to install Numpy, SciPy, Matplotlib and Pandas library. And before installing the libraries, make sure the latest version of pip is installed in your system. So to check that, we will run a command in command prompt. We will open the command prompt and write a command pip space minus minus version and press enter. As you can see, the pip version is 21.1.1 and it's being downloaded with the Python 3.9. So it's the latest version we have downloaded. So now we have to keep one thing in mind before installing SciPy, Matplotlib and Pandas library. First, we need to install Numpy library. So for that, we will run a command pip space install Numpy and press enter. Depending on your internet speed, it will get installed. As you can see, the Numpy library has been installed and there's a warning that our pip version is 21.1.1 and we should upgrade it to 21.1.2. That is the latest version available. So we'll upgrade the pip version. For that, we will write a command python space -m space pip space install space minus upgrade space pip enter. Okay, so we made a mistake here in the command. So the mistake is we have written only one minus sign before the upgrade. We have to write two minus signs before the upgrade. So we'll write the command again, python space -m space pip space install space minus minus upgrade space pip and then press enter. And now depending on your internet speed, the pip version, the latest pip version will be installed on your system. As you can see, they have uninstalled the pip version 21.1 and they have installed the latest version, that is 21.1.2. We have installed the first library, that is Numpy, and that's the basic requirement for the installation of SciPy library. So now we will install the SciPy library. So for that we will write the command pip install SciPy, pip space install space SciPy and press enter. And depending on your internet speed, it will be downloaded. Now you can see that the SciPy library has been installed successfully, and here you can see that the requirement already satisfied Numpy. So we have firstly downloaded the Numpy library so that we can easily run the SciPy library. Now we will download and install Pandas library. For that we will write the command pip space install Pandas and press enter. And this will also install depending on your internet speed. We can see that the Pandas library has been successfully installed. Now we are left with Matplotlib library. So now we will install that. For that we will write the command pip space install Matplotlib and press enter. As we can see, the Matplotlib library has been successfully installed. Now we have installed all the four libraries. So if you want to check whether the library is installed on your system or not, you can write a command to check that. First you have to write python and press enter. First we will check for Numpy library, and for that we will create a array. For that we will write the command import Numpy as np and press enter. If you don't get any error, it means that the library has been installed successfully. So now we will create an array a equal to np dot array 1, 2, 4, 5, 7, 9, d type equal to, we'll set it for float. Press enter, and we want to print this array. Write print array created a and press enter. You can see the output array created 1, 2, 4 and 5, 7, 9. So the Numpy library is working fine. So we will check for other libraries. For that we will write import space matplotlib and press enter. If you don't get any error, it means that the library has been installed successfully. So for the rest also we can write the same commands, import pandas and press enter. We do not get any error, so the library has been installed successfully and we are left with scipy. So we'll write import space scipy and press enter. So here also we didn't get any error, so the library has also been installed successfully. Now we will see what Anaconda is. Anaconda is a free and open source distribution of Python and R language. Here we have Conda, which is a package manager system similar to pip in Python. So now we will see how to download Anaconda and then we will explore its features. To download Anaconda, first we will open the browser and search for the keyword Anaconda. We have to visit the official website, that is www.anaconda.com. And now we will click on the product section and choose the individual edition, as it is open source edition and it is free of cost. Now we will scroll down. Here is the toolkit for the individual edition and we'll click on the download. On clicking the download, we are directed to the bottom of the web page, and here we can see the different versions available for Windows, that is 32-bit and 64-bit. We will download the 64-bit and it is of size 477 MB, so it will take ample amount of time to download. We will download it. As the download completes, click on the application file. Now click on next. The license agreement will appear. Now click on I agree. Then you have to select the installation type. If you want to install for a single user, click on just me. Else select for all users and click on next. I am installing for me, so I will click next. Then it will ask for installation location. After selecting location, click on the next. For me the location is fine, so I will click next. Then advanced installation options will appear. If you have already installed Python on your system, as we have installed already, so we do not have to click on this section. We will only click on this section and press install. It will take time to install. After the installation is complete, click on next. Then click on next and uncheck both these options and click on finish. As you can see, the installation has been completed. Now we'll go to start and type Anaconda. We can see that Anaconda prompt and Anaconda navigator are visible. First we will open Anaconda navigator. It's initializing and adding features. Here you can see some pre-installed applications and tools that are already installed in the Anaconda, and if you want to install any other tool you can. Like you can install RStudio, Python Professional, Orange 3, GlueWiz in the Anaconda, and you already have Spider, Qt Console, PowerShell Prompt, Jupyter Notebook, Jupyter Lab, IBM Watson Studio Cloud, Datalore, cmd.exe prompt. So now we will open Anaconda prompt. Now we'll see which version of Conda is installed in the system. For that we'll write a command conda space info and press enter. Here we can see that the Conda version is 4.10.1. Now we will launch Jupyter Notebook. For that we will write the command Jupyter Notebook and press enter. You can see that the Jupyter Notebook has initiated. Now create a folder where you want to store the projects and rename accordingly. So to create folder, we'll create the folder in OneDrive. I will create the folder on desktop. New folder. We will take the untitled folder and rename it. I'll rename it as Python 1. Now minimize the window and open the desktop. You can see that the Python 1 directory is created, and now we will click on the Python 1 folder and create a Python 3 notebook. As we have created a Python 3 file in the Jupyter Notebook, now we can run the Python commands on it. So we will run some commands, and first we will run a basic command that would be print India, and we will run this command. India is printed here. Now we will run some operators, like we will print 7 into 8 and the run, so it's 56. And we'll also run an exponential operator, print 2 exponent 4 and run. So you can see 16, the result comes out. So now to save this file, first we'll rename it demo1, rename, and we'll save it, save and checkpoint. Now you can check in the directory you have created, Python 1, that it is being saved as demo1. In this session, we will learn to write a program in Python IDLE, then we will see a program to add two numbers, and afterwards, we will run a program in Jupyter Notebook. As you all know, Python is an interpreted language, so we require a Python interpreter to work upon. While installing Python in our system, we also get Python IDLE automatically installed. But before writing a program in Python IDLE, we will write a program on command prompt. So for that, first we will open command prompt. We will click on start and write cmd and click enter. Now the command prompt appears. First we will check the Python version, pip space -- version, and press enter. you will see the Python version 3.9. Now we will start writing the Python program. For that, first we have to write the command py and press enter. Now we can start writing a program. We will write a basic program on division. For that, we will assign a value 5 to a variable a and value 10 to the variable b, and we will divide b by a and we will print the value of c. Press enter. As you can see, we have got an output 2.0. Now we have run a program on command prompt successfully. Now we will write a program in Python ideally. So to write a program in Python ideally, we will see some steps. First we have to open the Python IDE, then click on File menu and choose the new file, and after writing the program we have to save the program with .py extension, and then we can click on the Run menu and then we will see a Run module and we have to click on that. Now we'll see it practically. For that we'll click on Start and search for IDE, and now we'll click on Python IDE. Now we will follow the steps as we have seen now. We will click on File menu and choose New File. A new window will appear. Here we will type the program to get two numbers inserted by user and add them. But before writing this program, let's understand this program. So Python program on adding two numbers. First we have to get an int value inserted in variable a. For that we will write the command a equal to int round brackets input round bracket started. For the message we have to put it in inverted commas and the first number colon round bracket close and another round bracket close. Now we will insert an int value in variable b. For that we will write the command b equal to int round bracket started input round bracket started. For the message we will put the message in inverted commas and the second number colon, and then we will close this message by round bracket and another round bracket closing. Then we will assign a variable c and add the operation a plus b for that. Now we'll print a message that would be addition of two numbers equal to, that would be in inverted commas, comma c, as c variable will store the result of a plus b. All the statements in the program will get executed line by line. Now we will execute this program on Python IDE. So for that we will write a program here that would be a equal to int round bracket start input round bracket inverted commas enter first number inverted commas close round bracket close b equal to int input round bracket started inverted commas for message enter second number inverted commas round bracket close. Now we will assign the operation a plus b in variable c. For that we will write c equal to a plus b, and now we will print c. Before executing this program, we will save this program, file, save as, we will save it as demo1, and we will write the extension py and press save. As the program is saved, now we will run this program by click on this Run menu and then click on Run module. You can see the program has been executed. Now we will write the first number, that would be 10, press enter, and second number we will write 6 and press enter. We will get 16 as an output. So we have executed the program on Python IDE. Now we will see some best Python IDEs in the market. For that The best Python IDEs in the market are Jupyter Notebook, Visual Studio Code, Sublime Text, PyCharm, Python IDLE, and Spider Notebook. Among all these IDEs, we have worked with Python IDLE. Now we will write a program in Jupyter Notebook. For that, you have to install Jupyter Notebook. I have installed Anaconda distribution and it has Python IDE already installed. If you want to know how to install Anaconda distribution, go and check the video in Python playlist. So let's open Jupyter Notebook. For that, first we will click on Start and write Jupyter Notebook and click on the Jupyter Notebook Anaconda 3 and we'll wait to get it started in a browser. Now we'll select the location where we want to store the program. We will select the location in OneDrive, Desktop, and I've created a Python 1 folder there. So here we'll create a new Python 3 notebook and name it as First Python Program. And now here we can start writing a program. Here we will write a program to multiply three numbers. So for that we will get all the three integers inserted by the users in three variables and then we will operate the operation multiplication. So for that we will write the command a equal to int round bracket started input round bracket, and here we will print the message enter first number colon and then inverted commas close and the round bracket close. Now we will enter another integer in variable b. For that we will write the command a equal to int round bracket input round bracket started inverted commas enter second number colon and then we will close the inverted commas and the round brackets, and now we will get the third integer inputted by the user in variable c. For that we will write the command c equal to int round brackets input round brackets inverted commas enter third number colon inverted commas close and round bracket close. Now we will assign the operation of multiplication in variable d. That would be by the command d equal to a into b into c. Now we'll print the variable d, and for that we will also print the message multiplication of three numbers and close the inverted commas, and then we will insert a comma and then write the variable d, as d contains the output of a into b into c. Now we'll click on the run command and now we'll enter a first number, that would be 5, and press enter, then the second number 4, then the third number 6, and then press enter, and then we will get the output of multiplication of three numbers as 120. Now we have successfully run the program on Jupyter Notebook.
So in this video, we will learn what is a variable in Python. Then we'll understand what are object references. We'll also see the different rules for Python variables. And finally, we'll understand variables in detail with hands-on demonstration on the Jupyter Notebook. So variables in Python hold an object of a particular data type. Python variables are containers for storing data values. We do not need to declare variables before using them or declare the data type like we do in other programming languages such as Java or C++. Python is not statically typed. A variable is created the moment we assign a value to it. A variable is a name given to a memory location. So here we can see we have a variable called car and it has a value called BMW. Now this value is of type string since it is written within double quotes. Now, variables can have values of multiple data types. Python also allows you to assign values to multiple variables in one line. So here you can see I have assigned X, Y, Z to Audi, BMW and Mercedes in one single line. Alright. Now let's look at object references in Python. A Python variable is a symbolic name that is a reference or pointer to an object. Once an object is assigned to a variable, you can refer to the object by that name. So here we are assigning an integer value of 50 to the variable a. So assignment creates an integer object with a value of 50 and assigns the variable a to point to that object, as you can see here. So a is the variable and it is pointing to the object that has 50 value. Now let's see another example. So in this case we have assigned a variable a which has a value of 50, and then we have created another variable called b that has the value stored in a. Now Python does not create another object in this case. It creates a new symbolic name or reference called b which points to the same object that a points to. So here you can see both a and b are pointing to the same object, that is 50. Okay, now in this example Python creates a new integer object with a value of 100 and b becomes a reference to it. We will explore all of these in our demo. Now there are some rules for Python variables. Let me just read and we will explore all these rules in our demo session. So first, a variable name must start with a letter or the underscore character. A variable name cannot start with a number. A variable name can contain only alphanumeric characters or underscores. So you can see from A to Z, 0 to 9 or just underscore. Variable names are case sensitive. So here you can see I have written date in 3 different types and these are read as different variables and not the same variable. And then there are several techniques to write multi-word variables. You have the Camel Case, you have the Pascal Case and we have the Snake Case. Don't worry about it, we'll explore these in the demo. Now let me take you to my Jupyter Notebook where we will understand variables in detail. Okay, so I am on my Jupyter Notebook and I have my title as variables in Python. So let's start with my first variable. Let's say I have a variable called a and I'm assigning 50 to it. Now you must be aware 50 is of type integer. So this a variable is now holding an integer value. Now if you want, you can just print a. If I hit shift enter, it will give me the value of 50. Now to check the data type of a, you can use the type function. Now we have covered data types in detail in our previous video. If you want, you can have a look at it. So I will write type of a. If I hit shift enter, it gives me the integer type. Okay. Now let me show you another function called id. If I write id of a, let's run it, it gives me a number. This is a long number. Now the id function in Python returns a unique id for the specified object. So here object is a. So all objects in Python have its own unique id. The id is assigned to the object when it is created. Now what if I assign 100 to a this time, and let's see the id of a. If I run it, you can see here the values are different than the previous one. So every time the id function will return a unique id for the specified object. Alright. Now we learnt in our theory section that you can assign multiple variables in a single line. Now let me show you how to do it. Suppose I'll write x, comma, y, comma, z. So these are the 3 variables and I want to assign 3 values to them. So let's say x will have 50. In y, I want to store, let's say, 168.6, and my z will have a string or a text value, let's say Simplilearn. Alright, let's run it. Okay, now you can print them one by one. You can see here X has 50, Y has 168.6 and Z has Simplilearn of type text. You can check the data types if you want. Let's say I want to check the data type of Y. It gives me a float because 68.6 is a float. You can check the data type of Z. It is of type string. Okay, now you can also perform the same operation of assigning multiple variables in a single line in another way. Let me show you how to do it. Suppose I want to assign the same value to 3 different variables. Let's say I want to assign the value of 10 to X, Y and Z. So I'll write X equal to, Y equal to, Z equal to, I'll write 10. If I run it and let me print them one by one, you can see here X is 10, Y is 10 and Z is also 10. Now there is another way to do it, that is I'll pass in my variables X, Y, Z and then I can write 10, 10, 10. This will return the same result. Okay. Now let's look at the rules for writing variable names. So these rules we had discussed in the PPT section. Now we'll explore them one by one. So the first rule is a variable name must start with a letter or the underscore character. So let me just give a comment first. Rules for variable naming. So the first rule says a variable name must start with a letter or the underscore character. So if I write, let's say some random variable name ABC equal to 100, this is valid. You can print it. ABC, it gives me 100. Now you can also write the variable name as A followed by any number. It should be integer number. If I write 102 equal to, let's say this time I'll give a string, let's say India, and let me print it. It works perfectly fine. Now we also said the name must start with an underscore. I can start with an underscore and then write, let's say 123 is equal to 70.5. Now let me print it. Now this works as well. So you can start your variable name with an underscore followed by a letter or numbers. Let me show you another example. This time I follow the underscore with letters. Let's say dog. I'll just give any random dog name. Let's say I have a dog called Puppy, and let's say I'll print it. This also works. Okay. Now you can have multiple underscores in your name as well. Suppose I'll write underscore name underscore age. This is my variable name. I'll write, let's say Stuart 36 and let me print it. I'll write underscore name underscore age. This is also a valid variable name. So you can have multiple underscores in your variable name. Now the next rule is a variable name cannot start with a number. So if I write, let's say for name equal to Gilly, and if I try to print it, it will throw an error. So you cannot have a variable name starting with a number. Alright. Now let me just scroll down. The next rule is a variable name can only contain alphanumeric characters and underscores. So if I write @ then let's say age equal to 40. If I run this, it throws me an error because @ is not recognized and it is not a valid variable name. Similarly, let's say I'll write name $age equal to, let's say, 40. Again, this is not recognized. You cannot use it in your variable name. The next rule is variable names are case sensitive. So suppose I have a variable called car which is all in lowercase and my car has a value, let's say BMW. Now if I were to print car, it gives me BMW. Now suppose I have another variable which starts with a capital letter C followed by lowercase ar. If I were to assign car to, let's say, Tata, and I print it, it returns me Tata and not BMW. So you should keep in mind that variable names are case sensitive. Now similarly, I can also have a variable in all uppercase. Let's say my car is of Toyota brand. I made a spelling mistake. Okay, now if I print car, it gives me Toyota. So these are the different types of using case sensitive variables. Now another important thing to note is in Python, reserved words cannot be used as a variable name. So let me open a new tab and here you will search for reserve keywords in Python. Let me open this link or any other link for your reference. You see here, these are all your keywords in Python and these cannot be used as variable names. Let's try using a few of them. Let's say I'll use break. Let's assign a value to variable break equal to, let's say, 60. If I run it, it gives me an error, invalid syntax, break you can't use. Similarly, let's use another keyword. Let's say I'll use for this time. We have a keyword called for, you can see it here. Suppose I write for equal to, I have, let's say, Virat. If I run this, it throws me an error again. Let's try one more keyword. Do we have try as a keyword? Yes, we have. You can see here try is a keyword. If I write try equal to any random value I'll pick, this time I am giving a floating number, let's say 140.5. If I run it, again it throws me a error. But you can use an underscore and then you can give that keyword, let's say try. I'll assign the same value and let's say we'll print it. This will work fine since the variable name is no more a keyword because we have an underscore in the beginning. Okay, now let me show you some basic operations that you can perform on Python variables. Let's say we have a equal to 100 and let's say b equal to 200. You can assign an operation to another variable called result. Let's say I want the operation to be an addition operation, and let's go ahead and print result. You can see it has given us 300 because in result we are storing the addition of a and b. So 100 plus 200 is 300. Now similarly, you can perform many operations, like let's say this time we'll perform a subtraction operation. So this time I'm storing a minus b in result, and let's go ahead and print result. You can see here 100 minus 200 is minus 100. Then you can also have, let's say, result equal to a by b, and let's print it. Fair enough, we have 0.5 because 100 divided by 200 is 0.5. Similarly, you can also have integer division. Suppose I write 100 divided by, say, 40, and I'll print the result. You see here it has given us 2.5. But what if I want to perform an integer division? So I'll add one more forward slash here and let's run it. It gives me only 2, so it has truncated the 0.5. Okay, now moving ahead, let's say I have a variable called country and I have India in it. So country is my variable name and it is pointing to the object that has India as the value. I can print the variable. You see here I have India, and now if you want you can perform some extraction operation. Suppose if I write country within square brackets, if I write 3, it gives me the character that is present at the third index. So I is present at the 0th index, N is at the first index, D is at the second index, and I is at the third index. Let's say I want everything that is present until the third index. It gives me I and D. So this 3 is exclusive. It will only return us the values present at the 0th index, the first index, and the second index. Okay. Now let me show you another interesting example. Suppose I have a list that is called cars and I have a list of car names. Let's say I have BMW, then I have Ferrari, and let's say I have Toyota. I'll run it and I'll print my list that is cars. You can see here there are 3 car names. And now what if I want to put each of these car names in different variables? So I can write x comma y comma z and I'll write equal to cars. If I run this, now what it will do is it will assign each of these values to x, y and z respectively. Now if you want to print x, you can see here x has BMW, then y has Ferrari, and z has Toyota. So this is another way to assign values to variables from a list. Okay. Now you can also use variables in the print function or the print statement. Suppose I write x equal to, let's say it has Simplilearn. Now I can print a message, let's say welcome to, I'll give a space, close the quotations, give a plus sign, and I'll give the variable name. If I run it, you can see here the message is printed welcome to and the x which has the value of Simplilearn. So welcome to Simplilearn. Okay. Now another thing to note in Python is that you cannot add an integer and a string. Suppose I have x as the variable and it has a value, let's say 20, and then I have y which has the string Simplilearn. Now string can be put in double quotes or in single quotes. You can use whichever way you want. Suppose I print x plus y. Let's see the result. It gives us an error. So you cannot print or add an integer and a string. So you need to convert one of these values. Now there are several techniques to write multi-words variables. You can use the Camel Case to write multi-word variables. So here each word except the first starts with a capital letter. So I'll just give a comment here and write Camel Case, and the way to write is, apart from the first word, all the words start with the capital letter. Suppose I write my department equal to marketing. So here the first word my, the M starts with a small letter, while the second word department, the D starts in a capital letter. So this is an example of a camel case. If I want to print it, I can write my department and run it. It gives me marketing. Let's see another example. I have, let's say, car brand. So you see here, car brand are two words, but the first word starts with a small letter while the second word has an uppercase B. Let's say my car brand is Hyundai. Now you can print it. There you go. Alright. Moving ahead, we also have Pascal case where each word starts with a capital letter. Suppose I have a variable called my name is, let's say, Nathan. Here you can see my and name are two different words and both the words start with a capital letter. So this is an example of Pascal case. If I run it, let me just print it first. Okay, you see here I have my name. Similarly, let's say we have another Pascal case multi-word variable which is age now, where age has a caps and now has n caps. So this is also an example of a Pascal case variable. Let's say my age now equal to 30. I'll print age now. It returns me 30. Now one thing to note here is if I write, let's say, age now, if I do this, it gives me an error because your variable names are case sensitive. So we haven't created any variable which has small a and small n in age now. Okay. Now the third way to write a multi-word variable is called as snake case. So if you want, I can give a comment saying snake case. So here each word is separated by an underscore character. So let's say I have a multi-word variable which is city underscore address, and let's say the city is New York. Now if I print it, you have New York. So this is an example of a snake case where each word has a underscore in between. You can have multiple underscore between each word. Suppose I write my current age equal to 35, let's say. So I have my current age. If I run it, okay, there is some mistake here. I have missed an R. You see here it says 35. So this is also an example of a snake case where each word is separated by an underscore. So here we have two underscores. Alright, now let me go to the top and let me brief you what we did. So first we saw an integer value variable. We saw how you can check the data type of the variable using the type function. Then we explored about the id function. We saw how you can pass in variables or multiple variables in a single line. Then we saw how you can assign the same value to 3 variables in one line. Now this is another method to do the same operation. Now then we looked at the different rules for naming variables. Your variables can start only with a letter or an underscore, and that letter can be followed up with numbers as well, and you can have similarly numbers after underscore. You can also have characters after underscore. You can have multiple underscores, but your variable name cannot start with a number, and it cannot have special characters like @ or dollar symbol. These will throw an error. Now you can see your variable names are case sensitive. So here we defined car in 3 different ways, and all the 3 gave us different results. Another important thing we saw was you cannot use keywords, Python keywords, as variable names. We saw break for and try. Now we perform some basic mathematical operations. We also saw how you can perform some extraction operation using string values in Python. Then we saw another way to assign the values of a list to different variables. We saw how you can use the variable name in a print statement. Then we saw how you cannot add an integer with a string. We explored the Camel case. Then we saw how you can write multi-word variable using Pascal case, and finally we looked at snake case. So in Python, every value has a certain data type. The variables in Python hold an object of a particular data type. Since everything is an object in Python, data types are actually classes and variables are instances of these classes. Now there are various data types in Python. First we have the numeric types, which are essentially numbers. So under numeric types we have integers, floating point numbers and complex numbers. Then we have text type data, which are in the form of strings. The third type of data that is available in Python are called as sequence types, which consists of lists, tuples and range. We have already seen about lists and tuples in our previous video. And in Python we also have dictionary objects as mapping data types. In the previous video you saw how to map key value pairs using dictionaries. Next we have set data type. Now sets are unordered collection of unique items. Python also supports Boolean data types, and finally we have binary types of data, which include bytes, byte array and memory view. Now let's head over to the Jupyter Notebook, where we will learn about these data types in detail. So here I am on my Jupyter Notebook and I have titled my notebook as data types in Python. REC is for recording. So let's first start with numeric data types. I'll give a comment using a hashtag. I'll write numeric data type. Okay. Let me define a variable called num, in which I'll store a value of 7. Now let me go ahead and print the data type of my variable num. So for that I'm using my function as type. If I run this using shift plus enter, you can see here it tells me that num variable is holding a value of type integer. Now you can also use a print statement. I can write something like print num comma, I can give a message as is of type. I'll give another comma and then I'll use my function type of num. Let's see the output. You can see it here. It first gets the value that is stored in the variable num, so 7 is of type, and then it prints the class is of type class integer. Alright, I've just increased my size of the notebook. Next, let's declare the same variable num, and this time we'll store the value as, let's say, 10.8. Now you can see here there's a point, which means this is a decimal or a floating value. If you can check the type of num, it gives us num is holding a value of type float. Now let's say I'll take a negative number, let's say minus 10.8, and we'll see the type of num. Again, minus 10.8 is also of type float. Now let's say I'll declare a complex variable, let's say 8 plus 6j. Now this is a complex number which is again of type numeric data type. If I want to check the data type of num, it gives me complex, because 8 plus 6j is of complex data type. Okay, now if you want to extract the real and the imaginary parts of a complex number, you can do it something like this. You need to pass in the variable name followed by a dot, and the attribute name is real to extract the real part of the complex number. If I run this, you can see here it has returned the real part of the complex number, which is 8. Now if you want to print the imaginary part, you can use num.imeg, which is for imaginary. If I run this, there you go. It gives us the imaginary part, which is 6. Okay. Now in Python, you can also perform conversion of data types. So you can convert between different data types by using type conversion functions such as int, float, str, etc. So let me define a variable called num, which has a value 7.8. Now what I'm going to do is I'm going to create a variable called b, which is going to store the integer part of num, which means initially I had defined num as 7.8, which is a floating point number. I want to convert this num to integer type now, and let me go ahead and print my b, and I also print the type of num, and I'll then print the type b. Let's run this and see the result. Okay, so if you see here clearly, when I see print b, it has returned me 7, which is of type integer. So it has truncated the decimal part present in 7.8. Again, if I print type of num, so num is holding 7.8, it is of type float. Now after converting the float value into integer, it has given me int. Okay. Similarly, let's say we have another number minus 90.5, and if I were to check the type, I would write print type of num. Then let's convert this to integer. So I'll write print int of num. Let's see the results. Okay, so initially minus 90.5 is of type float. After we converted our num to integer, it gives us minus 90, so it has truncated the decimal point part. Alright. Now let's say I'll create another variable, let's say c equal to, let's say I'll write float of b. Now if you remember, our b holds a value of 7. If I were to convert b to float again, I can use the float type conversion function, and let's go ahead and print c. If I run this, you can see here previously b was holding an integer of 7. Now it has converted that integer into a float value, so it is 7.0 now. Okay. Now moving ahead, let's see about Boolean data types. So if I have a variable, let's say r equal to, let's say it has a value called true, which is a type of Boolean value, and let me go ahead and print the type of r. It gives me Boolean. Now let's say I'll write num greater than c. Let's go to the top. If you see here, num is holding a value of minus 90.5 and my c is holding a value of 7.0. I'm checking if num is greater than c. If I run this, it gives me false because minus 90.5 is less than 7.0 and not greater than 7.0. Suppose I create a variable Boolean or bool, and I'll store that value num greater than c, and let's print the type of Boolean. I'll use type of my variable, that is bool. Let's run it. You can see it here. It tells us that this particular operation is now holding a data type of Boolean. If you are getting confused, we can change the variable here. Let's say I'll write b underscore bool, and similarly I'll write here b underscore bool. Let's run it. You get the same thing. Alright, now moving ahead, let's explore how string data types work in Python. I'll give a comment as string data types. Let me scroll down. Okay, so string data types or string values in Python are passed within quotations. Suppose I have a string called str1 and it has a value, let's say Python programming. So this is a text value. I have another string, let's say str2, which has a value, let's say Simplilearn. Now let's run this. Okay, now if I were to check the type of str1, it should give me string. So str here is a string. Now you can also perform extraction operations from the string. Suppose you want to extract the value that is present in my first string, that is str1, at index number 5. Let's run it. Okay, there is some error here. Okay, so this should be str1 and not strl. Let's run it again. It returns us n. Now let's count what is present at the 5th index. So from our previous introduction to Python video, you might be aware that in Python the index number starts with 0. So if you count, p is at index 0, y is at index 1, t is at index 2, h is at index 3, o is at index 4, and then n is at index 5. So hence str1 of 5 returns n. Similarly, if you can check for other string, that is string 2, let's say I want to see the value that is present at -4. Let's run it. It gives us e. Now if you use a negative indexing operation, it will start counting from the backward position. So here n is at -1, r is at -2, then you have a at -3, and e is present at -4. So hence str2 of -4 returns e. Cool. Now you can also perform slicing operation. Suppose I write str1. I want everything that is present between the 0th index to the 5th index. I'll run it. It gives me pytho. So if you check in string 1, it will start counting from the 0th index and go up to the 4th index and exclude the 5th index. So in my string 1, if I start counting from the 0th index, so it is 0, 1, 2, 3 and 4. So it will print from p till o, and that's the result. Okay, now you can also use some inbuilt functions with string. Suppose I write str2 dot find. So I want to find the index where my m is in Simplilearn. So I'll write m within quotations and print it. It returns me 2. If you check again, so s is at 0th index, 1 is at the 1st index, and m is present at the 2nd index. Okay. Now moving ahead, let's explore a few sequence data types. So we'll start with list data type. Okay. Now first of all, let me go ahead and declare a variable called split1 equal to, and this will have some text. Let's say this is orange. Then I'm going to create another variable called L1 equal to, I'm going to split my variable or my string, that is split1, using the split function, and I'm going to split using the comma. So you can see here my string has comma. I'm going to separate each of these words with a comma, and let's print L1. If I run this, you can see it here. Initially my split1 was of type string, and now we have converted split1 to a list. You can see this is a list, and it is present inside square brackets. To verify, you can use the type function. So I'll write type of split1. It should return string. You can see it here, str. And now if I write type of L1, it gives me a list. Okay. Now let's see a few more examples. I'll create another list called list1, and let's see it has some values. The alphabet A, we have the number 1, which is in terms of string again because I have passed in quotes. Let's say I have India. Let's make it consistent with single quotations, and let me print what is inside list1. If I run it, I get my list. Now you can check the data type. If I write type of list1, it gives me, it is of type list. Now you can also perform certain operations on list. Suppose you want to add a few elements to your original list. For that, I'm going to create another variable called list2, and let's say list2 has some values, let's say b, comma 2. Now if I write list1 plus equal to list2, and let me go ahead and print list1. Let's see the result. There you go. So our initial list had 3 elements, A, 1 and India, and now we have merged or concatenated 2 more elements, B and 2, and hence this becomes our final list. Okay. Now moving ahead, let's see one more sequence data type, that is tuple or tuple. Now list and tuples we have already covered in our previous video on Introduction to Python. If you need to brush up what list and tuples are, you can check the previous video. So I'm going to create a tuple, that is tup1, and I'm going to store some values. Tuple you can create using braces. I have some value, let's say A, B, C, D, and let's say E, or let's just restrict it to D. Now you can check the type of tup1. You can see here tup1 is of type tuple. Now I'll create another tuple, let's say tup2, and it has some values, let's say E, F, and let's say G. Now if I write tup1 plus equal to tup2, and if I print my tup1, I get the result of a merged tuple which has values of both tup1 and tup2. You can see here our original tuple had A, B, C, D, and then we merged the second tuple, and it has given us E, F, G as well, and hence this becomes the final tuple. You can also perform some basic operations on tuple. Let's say I'll write tup1 multiplied by 2. You can see the result here. It has printed my original tuple twice. Okay. Now moving ahead, let's see our mapping data type, that is dictionary. Again, dictionary is also covered in our previous introduction to Python video. You can also have a look at that video. Now the way to declare a dictionary is I'll create a variable dict1, and dictionaries are written using curly braces and have key value pairs. So I'll write my first key as 1, and let's say this dictionary is about animals, and I have, let's say, lion as my first animal in the dictionary. Then I'll create my second key. Let's say the second animal I have is tiger, and let's say my third element is a dog. Let me run it and print my dictionary. You can see this. We have the dictionary printed. Now if you want to check the type, you can write type of dict1. It returns us dict, which means dictionary. You can also print the length of dict1, and it gives us 3, which means our dictionary has 3 elements. Okay. Now moving ahead, we'll explore our set data type. Now as we understood that sets are unordered collections of values, and these values are always unique. So I'll write set1, let me give a space, equal to, again sets are written within curly braces. I'll create a set. Let's say it has some duplicate entries as well, and I'll print my set1. It returns only the unique values, so it has dropped this 5 which was duplicated. You can check the type of set1. It gives us it is of type, or the object is of type set. Now suppose I have another set called set2, which has values, let's say a, comma b, and let's say we have some numbers 3 and 4. I'll tell you the operation that I'm going to do. I'm actually going to do an OR operation. So I'm going to print set1 or set2. So this is an OR operator in Python. Let's print the results. You can see here it has printed all the values that are present inside set1 or set2. So in set1 we have 1, 2, 3, 4 and 5, and in set2 we have a and b. So it has dropped 3 and 4 because these are not unique, and 3 and 4 are also present in set1. Suppose I were to perform an AND operation. I'll write set1 ampersand set2. If I run this, you can see here it has only printed the unique values that are present in both set1 and set2. So 3 and 4 are the unique values, and hence it has printed 3 and 4. Let's say I'll write set1 minus set2. Let's see the results. It gives us only those values that are present in set1 and are not present in set2, which is this. Let's see the result if I write set2 minus set1. So this will return the unique values that are present in set2 and are not present in set1. So A and B are the unique values that are present in set 2. Hence it has printed as A, B. Okay. Now another data type we had discussed was range. So range is basically a function. If I write x equal to range 4 and I'll print x, it gives us from 0 till 4, because in Python the first index starts from 0 and goes till 4, so the range is from 0 to 4. Now you can also print the type of x. It returns us a range. Now we'll see some binary data types. Binary data types are not very often used in Python, but it is better if you know. Binary data types can be written as x equal to b. Let's say I have a string. I'll write within double quotations hello world, and let me go ahead and print my variable x. You see here we have hello world, and now let's print the type of x. You see here this is a binary type which is bytes. I'll show you another operation. Let's say you want to extract a specific value from a particular index from this binary data. So again you can use the indexing operation. Suppose I write print. I want to extract the value present at the 4th index. It gives me 111. Now this is very interesting. Let's deep dive into this. Let's check what is present at the 4th index of my string. So H is present at the 0th index, E is at the 1st index, L is at the 2nd index, the second L is at the 3rd index, and we have O at the 4th index. So when we are trying to print the index position, it is actually returning us the ASCII value of small o. Now here I have a doc open which is from IBM documentation. If you see the ASCII value of small o or lowercase o, you will find that the ASCII value is 111, and hence it has returned us 111. Let's try for another index number. Let's say I want to find the value which is present at index number -2, and if I run it, it gives me 108. So -2 means it will start from the last index. So -1 is D and -2 is L. Let's see what is the ASCII value of L. If you see it here, the ASCII value of L is 108, and hence it has returned us 108. So this is how the binary data types work in Python. Now let's convert some sequence objects to other type of objects. Let's say I have a string called S which has something like Messi is from Argentina. Now you can check the type of S. Fair enough, it tells us that Messi is from Argentina is of type string. Now what I'm going to do is I'll use my list function and pass in my variable that is S, so that it converts S to a list. And let me go ahead and print my L. You can see here my string S has now been converted into a list, and this is the result. See here, these are all list elements present inside square brackets. Now if you want, you can check the type of L. It should return us list, and you can see it here. Now suppose I have another list, let's say L1, which has some numbers, let's say 1, 15, 3, 6, 0, 8, 4 and 3. Let's say we also have 1. Okay, so this is a list. You can check type of L1. Fair enough, it tells us that this is a list. Now I want to convert this list L1 to a set. Now as we know that set only contains unordered unique elements. So if I write S equal to, I'll use the set function and then I'll pass in my list variable, that is L1, and let's print S. It only returns me the unique values present in the list. So it has dropped the duplicate elements such as 3 and 1. Now you can check the type of S, it gives us set. Okay, so that brings us to the end of this demo session on data types in Python. Let me go to the top and I'll brief you what we did in this demo. So first we looked at the different numeric data types. So we saw integer data type, then we saw floating data type. We also had complex data types. We saw how to extract a real part and imaginary part from a complex number. Then we used some type conversion functions to convert the numeric data types from one data type to another. So here we converted a floating type data to an integer type data. Similarly, we saw how to use Boolean data types. Then we saw about string data types. We also performed some basic operations of using indexing method to extract different values. We also saw how you can use slicing to extract a range of values from your string. We used the find function to find the index of a particular character in the string. Then we learned the important sequence data types like list. Then we had tuples. And then we learned about mapping data types such as dictionary. We also looked at set data type. Now later on we explored about range data type and we looked at binary data types. We saw how binary data type returns ASCII value of a certain character. Finally, we converted strings to list, and then we saw how to convert list to sets.
First, we will learn different number data types in Python. Then we will learn type conversion between number data types, and after that we will understand how to represent binary, hexadecimal and octal numbers in Python, and then we will understand different number functions in Python. A programming language needs to have support for numbers to carry out calculations. In Python, the numbers are categorized into different data types. Types are implemented in Python as classes. There are three numeric types in Python: int for integers, float for decimal numbers, and complex for complex numbers. Let's explore these data types in Jupyter Notebook. I have opened my Jupyter Notebook and now let's see different data types in Jupyter Notebook. For example, first we'll assign a number to a variable. Num variable equal to 7, and now we will check the type of this num variable. For that we'll write the command type round brackets num round bracket close, and then we'll run this command. We will get int as the data type. Now we will assign a decimal number to the num variable, that would be num equal to 7.7, and now we will check the type of the num variable. And run this command. What we get is the float as the data type for the num variable. Now we will assign a complex number to the num variable. And we will check the type for this num variable and run the command. We will get the complex data type as the result. Now, if you want to get the real part of this complex number, you just have to write the command num.real and just execute the command. You will get 6.0 as the real part of this complex number. Here you can see you just code the number in float data type. The complex number in Python are stored in float data types, whether it's the real part or it's the imaginary part. Now we'll see the imaginary part. num.imag, and now you will run this command, you will get 7.0. Here also you can see that the imaginary part is also stored as float in Python for complex numbers. Now we will perform different arithmetic operations with these data types. First we will mention arithmetic operations. Now we will assign numbers to the variables and perform different arithmetic operations. For that we will assign 17 as a number to the variable num1 equal to 17, and the second variable num2 we will assign the number 25. And now we will perform different arithmetic operations. First we will start with addition. So we'll write the simple command that would be print num1 plus num2 and just run that command. You can see the result as 42. It's as simple as that in Python. You just have to write print and in round brackets just write the operation you wanna execute. Now we will see the subtraction part. We'll write print num2 minus num1 and execute this command, and we'll get the result as 8. Now we will see multiplication. Print num1 into num2 and execute this command, and we'll get the result as 425. Now we will divide. Print num2 divided by num1 and execute this command, and we'll get 1.47. Here you can see, as we have assigned int values to the num1 and num2 variable, we got the result for addition, subtraction and multiplication as int data type only. But for division we got it as float. This is because Python always gives the output for division in decimal numbers only, just to have minimum accuracy loss. So if you want to just get the output of the division as an int value, you just have to perform this print num2 and 2 slash signs and then num1 and then execute the command. You will get 1 as the output. So to just get int as the output of the division, you can use 2 slashes. Next command we'll see is to raise a number to another number. So to just get 2 to the power of 4, we'll write the command print 2 asterisk symbols and 4, and just execute this command. You will get the output as 16. We got 2 to the power of 4 by just using 2 asterisk symbols. Now to get the remainder of the division, we just have to use the modulus symbol. So for that, print 4 modulus 2 and just execute the command. You will get 0 as the remainder. You can perform the same operations on float numbers and complex numbers. Now we'll see an arithmetic operation on complex number. So we will assign a complex number to a variable, that would be g equal to 1 plus 5j, and another variable we will assign the value 2 plus 3j, and we will assign the operation I equal to g slash h, that is division, and print the output, and we'll execute the command. We will get the following result for the division of two complex numbers. Now we will see type conversions in Python. For that we will move. There are mainly two types of conversions between numbers in Python. First is using arithmetic operations, that is implicit type conversion, and second is using built-in functions, that is explicit type conversion. Let's understand the concept of conversion with the help of Jupyter Notebook. So here, we will write first convergence. First, we will assign a number to a variable, that would be a equal to 196, and we have seen in the previous examples that its type is int. Now if we put this number into double quotes, and now we will check its type, that would be type a, and run the command, we will get it as string. So in Python, when we just put a number in double quotes, it will see it as a string. And to get this number as an int, we just have to use explicit type conversion. For that, we will write b equal to int a, and now we will check its type b, and run the command. We will get int as the data type for the b variable. The a variable is still the string data type, and b variable has now turned as int data type. And now to turn a as a float data type, we can write c equal to float a, and check its type c, and run the command, and here we can see that it has turned into the float data type. So a is still the string data type, but c has been converted the a variable into the float data type. We can also convert the a string data type into complex data type. Just we have to write t equal to complex, and in brackets we have to write a, and we can check its type, and we can print the t complex number, and we have just execute the command, and we can see that the complex number is 196 plus 0j. And we can also check its type by just writing print type d, and we will run the command, and we can see that the class is complex for the variable d. We can define the complex data type by different methods. One of the method is, we just have to write print complex, and in round brackets we just have to assign both real and the imaginary numbers, that would be 3, 6, and just execute the command, and here we got a complex number, that is 3 plus 6j. Now we have seen the explicit type convergence. Now we will see some implicit type convergence, that is using arithmetic operations. For that we will assign a float number, that would be 2.6, to a variable a equal to 2.6 and b equal to 6, and we will assign an arithmetic operation, that would be c equal to a plus b, and print the output and execute the command. By using just arithmetic operations, we have seen that the addition of a float number and the integer number turns out to be a float number. So now we have seen the implicit type conversion example. Now we will see the representation of binary, hexadecimal and octal numbers in Python. All the integer numbers can be represented as binary, hexadecimal and octal. To represent it as binary in Python, we have to prefix it by using 0 small b or 0 capital B. And for octal, we can prefix it by using 0 small o or 0 capital O. And for hexadecimal, we can use 0 x or 0 capital X. Let's see this representation in Jupyter Notebook. First we will write representation of binary, hexadecimal and octal numbers. Now we will first see binary to decimal conversion. For that we will first write 0 B 1 1 0 1 1 0 0 0, and then we'll just run it and see 216 as the decimal conversion of this binary number. Now we'll see the same for the octal. For that we'll write 0 small o 12 and just run this command, and we can see that it has turned 10 in the decimal number system. For hexadecimal we will write 0 small x and 12 and just run the command, and we can see 18 as the decimal conversion of the hexadecimal number system. We can also use 0 capital X 12 and just run the command. We'll see 18 the same output as of 0 small x 12. Let's see some operations with fractions. For that first we will comment fractions. Now we will import the fraction module. For that we'll write from fractions import fraction as f, and first we will execute the addition operation for fractions. For that we will write print f 1, 3 just for the fraction. Numerator would be 1 and the denominator would be 3. Now we'll write the operation addition, and f the second fraction, that would be, okay, we will write the same only 1, 3, and on execution of the command we will get 2 by 3 as the output. We can also perform different operations. Okay, we will just see the reciprocal of the fraction. For that we will write print 1 upon f 5, 6 and just run the command. Here we can see the reciprocal function that would turn out to be 6 by 5. Now we will explore different number functions. First one that we would explore would be absolute. Absolute function would turn any negative number into the positive number. For that we will just assign a number that would be x equal to minus 9.8, and we will just apply the absolute function abs on the variable x and just run the command. Here we can see that it has turned x equal to minus 9.8 to 9.8. Now we will see some different functions. For that we will import the math module, import math, and we have different values stored in the math module. For example, pi, we will print the pi value, print math.pi and run the command. Here we can see the value of the pi 3.1415926535897993. We also have exponential value in math module. For that we will write the command print math.e and execute the command. Here we will get the value 2.718281828459045 for the value of e in the math module. Now we will also see exponential to the power 10. For that we will write the command print math.exp round brackets 10 and execute the command. We will get the value 22026.465. We can also perform log operations. For that we will write the command print, and we will get the log of 1000 to the base of 10. For that we will write math dot log to the base 10, the value would be 1000, and we will execute the command and we will get 3.0. We can also get the factorial by the math module. We'll write print math dot factorial of 6, and we'll execute the command and we got the factorial of 6, that is 720. Now if we want the square root of a number, we'll write the command print math dot sqrt, and in round brackets we will write the number for which we need the square root. We will write 25 and execute the command and we will get 5.0. This square root number gives the float number as its output. And we can also find out the maximum numbers from a bunch of numbers. For that we have to write the command max round brackets and the bunch of numbers from which you want the maximum value, like 1, 33, 55, 7, 99, and just execute the command. You will get the maximum number, that would be 99. And if you want the minimum number, you can write the command min, and in round brackets just write the bunch of numbers 1, 3, 66, 88, 7, and just execute the command. You will get the minimum number, that would be 1. Now we will see the ceiling function. For that we will write the command print math dot ceil, and in round brackets we'll write the number for which we want to use the ceiling function minus 43.5, and execute the command. You will get minus 43. So what the ceiling function does is it would give the highest value or the greatest value for the number we have entered in the ceiling function. Now we'll see the floor function. For that we'll write the command print bracket math dot floor, and we'll write the number for which we want to use the floor function minus 43.5, and execute the command. We'll get minus 44. So the floor function will give the output value just below the lowest value of the value entered by us in the floor function. Now we'll see the power function. For that we'll write the command print math.pow, and in round brackets we'll write the number 2 and the power which we want, that would be 6, and just execute the command. Here we can see that 2 to the power 6, we have got the output value as 64. Now we'll see some trigonometric functions. First we'll see cos of x. Like Python number method cos returns the cosine of x radians. For that we'll write the command print math dot cos of 0, and just run the command. It will give 1 as the output. So this method returns a numeric value between -1 and 1, like which represents the cosine of the angle. We will see another example for cos. For that we'll write print math dot cos, and in brackets we'll write the angle math dot pi, and we'll execute the command and we'll get the output as -1. Now we'll see tan trigonometric function. So the Python method tan, it returns the tangent of x radians. For that we'll write the command print math.tan of angle 0, and we will execute the command. We will get 0 as output. This method returns a numeric value between -1 and 1, which represents the tangent of the perimeter x. We will also see another example for tan. We will write print math.tan math.pi by 4 and execute the command. It gives us 0.99999 that turns out to be 1. Now we will explore some random number functions. For that, we will write the command import random and import the random module. Now we'll see the first function, that would be randrange. For that, we'll write the command print random dot range, and in circular brackets we'll write the range from which we want the random number. That would be 10, 20, and execute the command. Here we got 12 as the random number. Now we will define a list, that would be x equal to square brackets 1, 2, 3, 4, and 5. Now we'll see another function, that would be choice, and it would give any random number from string, list, or tuple. So for that we'll write the command print random dot choice, and in circular brackets we will write, or we will pass any list, string, or tuple. Here we will pass this list x and execute this command. We will get the random number 3.
So we are going to talk about object types in Python. Then we'll see the different type conversion functions that are available in Python. Then we see the different types of type conversion. Alright. Now let's look at the different types of objects in Python. So we have lists, you have tuples, numbers, strings, dictionaries, sets, you even have file objects. Then you can see we also have other core types such as Boolean and none. Then we have program unit types like functions, modules, and classes. Now we will touch upon most of them in the demo section of this tutorial. Then we also have implemented related types. Alright. Now let's see how you can convert one data type to another using type conversion. So Python provides two types of data conversion techniques. One is called the implicit type conversion and the other is called the explicit type conversion. Now in implicit data type conversion, Python can automatically convert one data type to another data type. This process does not need any user involvement. While in external conversions, users convert the data type of an object to required data type by using predefined functions that are listed here. So you can see here we have the different functions. So if you want to convert a specific value to an integer, you can use the int function. We have the float function. Now we have something called as ORD. So the ORD function accepts a string of unit length as an argument and returns the Unicode equivalence of the passed argument. Now we also have hex and oct. So the hex function is used to convert an integer number to its corresponding hexadecimal value. Similarly, the OCT function will convert the corresponding, or let's say will convert an integer number to its corresponding octadecimal value. We have tuple, list, set, dictionary. Str is for string. You can convert a number into a complex number by providing its real and imaginary part. Now we also have the chr or the character function. Now this is how the basic general syntax looks like. You have the required data type followed by the expression. Okay. So let's head over to our Jupyter Notebook and learn the different types of objects as well as look at the type conversions in Python. Okay, so here I am on my Jupyter Notebook. Let's first look at number objects. So I'm giving a comment as number objects. Alright, let's say I have a variable called num which is equal to, let's say, 2. Now it's very simple that 2 is an integer. So if you want to check the type, you can just use the type function and it gives us int, which means integer. So here 2 is of a type called number object. Let's say you want to pass a floating value, that's a 2.0. See the results. 2.0 is of type float, and again 2.0 or 2.0 is a number object. Now you can perform various operations on number objects. Suppose you want to add a few numbers. So let's say 321 plus 365, and I'll say add. It gives us the addition of these two numbers, which is 686. Now let's say you want to perform a multiplication operation. Let's say 62 multiplied by 2.5. If I hit shift enter, it gives me the multiplication or the product of these two numbers, that is 55.0. Now Python by default will convert the result to a floating point number if there is one integer and this one float. If you want to return the exponent of a number, let's say I want to know 2 raised to the power 4. So I'm using double asterisk to represent the exponent operator. If I hit shift enter, it gives us 16. So it's basically 2 multiplied 4 times. Now you can also import specific libraries. So let's say I want to import the math library and I want to print the value of pi. So here I have written import math, and then using the module math I am trying to find the value of pi. Let's run it. You see here it says 3.141, so on and so forth. Now you can also import the random module. Let's say I'll write import random, and then let's say I want to print a random number. You can use the random function. Let's run it. You see here this is a random value that Python has generated. If I run it again, this value changes. Let's run it again. Again this value changes. Okay. Now we'll shift our focus to understanding string objects in Python. So I'll give a comment string objects. Let's say I have a string A is equal to, and let's say the string has India. Okay. Now if you want, you can print A. It says India. Now suppose I want to extract the value that is present at the 0th index of the string. So the way to do is I'll pass in my variable name, that is A, and within square brackets I'll give the index value, that is 0. Now one thing to remember, in Python the index value starts with 0 and not 1. So if I do A of 0, it gives me I because I is present at the 0th index. Now let's say I want the last value in this string India, so I need to return A. For that I can use negative indexing by using -1. If I do -1, it gives me A, which is the element present at the last index. Now let's say I'll write A1 and colon. Let's run it. You see the result here, it says NDIA, which means Python has returned everything starting from the first index till the last index. So here colon means you need to return everything that comes after the first index. Now let's say I'll write print A and I'll add, let's say XYZ. Let's run it. You see here this XYZ has been concatenated with the value that was present inside A, that is India. So the result is India followed by XYZ. Okay. Now if I write A multiplied by 7, it will print India 7 times without a space. You can see it here. Cool. Now let's say you want to replace certain values in the string. You can use the replace function. So if I write a dot replace, let's say I want to replace IA that is present in India with, let's say, XYZ. Let's run it. You see here IND is fine. After that we have IA, and that IA has been replaced by XYZ. Now let's move on and understand list objects in Python. So I'll write list objects. Okay, so let's go ahead and declare a list L1 within square brackets. Let's say we have values like 101, let's say America, and then let's say we have another floating value, let's say 2.05. This is my list. If you want to print the list, you can use L1 to print it. You see here this is my list L1. Now if you want to find the length of L1, you can use the len function. If I run it, you get 3, which means there are 3 elements in the list: 101, America, and 2.05. Now if you want to extract certain values from the list, for that you can use the indexing method. Let's say I'll write L1 of 1. That gives me America because at index position 1 we have America. So 101 is at the 0th index, America is at the 1st index, and 2.05 is at the 2nd index. Next, let's say I write L1 and then I give colon -1. Let's print it. So that gives me 101 and America. So what it does is this colon -1 will exclude the last index and print the other 2 elements in the list. Okay. Now if you want to append some elements to the list, you can use the append method. So I write L1.append. Within brackets I'll give my value, let's say USA. Now let's go ahead and print L1. If I run it, you can see the difference. Earlier my list had 3 elements, 101, America, and 2.05. Now we have added the 4th element, that is USA. Cool. Now you can also use the pop function in Python. Let's say what it does. So if I write L1.pop and I'll give, let's say, 3. If I run it, it returns me USA because USA is present at the 3rd index of my list. If I write pop 1, it gives me America because America is present at the 1st index. Alright. Now you can also reverse the elements in a list. If I write L1 dot reverse function, if I run this and then I'll print L1, you see the result here. We have 2.05 and 101, which is printed in reverse order. The reason being we have already popped America and USA out and we are only left with 101 and 205, and if you reverse the current list, it will be printed as follows. So 2.05 comes at the beginning and then we have 101. Let me just rerun my list again to show you the difference. I have run my L1. Let's run this append query, and now let's use the reverse function. There you go. So now our original list has been reversed. So you have USA at the beginning and 101 towards the end. Okay. Now moving ahead, let's see the next type of object in Python, that is dictionaries. Okay. let's say I'll create a dictionary called dict1, and you might be aware that dictionaries are created using the curly braces. So I'll have my key value pairs. Let's say my key is 1 and the value it holds is, let's say, the names of animals, tiger, comma, we'll have the second key, and that second key will have the value, let's say, lion, and let's say we have another element with the third key, and let's say we have mouse. Okay, now let's print our dictionary. So this is how my dictionary looks like. Now you can display the keys by using the keys function. So this will return all the keys present in the dictionary. You see here 1, 2 and 3 are my keys. Similarly, you can display the values in the dictionary. You need to change these keys to values. If I run it, you see here tiger, lion and mouse are the 3 values. Now suppose you want to add another element to your dictionary. For that you can write dict1 and give the fourth key equal to the value, let's say, cat. Now let's run dict1 and see the difference. There you go. So here we have added another element to the dictionary, which is cat. Now moving ahead, let's explore tuple objects. Okay, so we'll create a tuple called t1 equal to, we'll have the values 1, 2, 3, 4, and let's say you want to print the length of tuple t1. It gives you 4 because we have 4 elements in the tuple t1. Now let's say I'll declare one more tuple called t2, and this time we'll have 2 more elements in the tuple. So I'll write t1 plus followed by the 2 elements that I want, let's say 7, 9, and I'll print t2. If I run it, you can see here we have added 7 and 9 to our original tuple that had 1, 2, 3, 4. Now you can also use the indexing method or the slicing technique to extract values from the tuple. Let's say I write t2 of 3, it will return the third element that is present in tuple t2. So if you see here, my third index has the element 4, hence it has returned 4. Cool. Now moving ahead, let's see how file objects work in Python. Alright, now using Python you can create files. Let's say I want to create a text file in Python using the Jupyter Notebook. For that I can write f1 equal to, I'll use a function called open, and inside this open function I want to create a text file, and first I'll write something into that file. Let me show you. So this is a folder that I have. The folder name is called object types and it is present in my desktop. So I'll use this location, and here you can see now this folder contains no files as of now, but we are going to create a text file using Python. Let's see how to do it. So here I'll paste my location that I've just copied. Now one thing to note is you need to convert everything to forward slash, or you can use double backslash also. I'll give another forward slash, and let's say I want to create a file in the name of data.txt. So it is going to be a text file. Make sure everything is inside single quotation, and I want to open the file in write mode. So I'll write w here. Let's run it and see the difference. Now if we check our folder, you see here earlier there was no data file. Now we have created a text file in the name of data. You see here there are no information or data inside this text file. Next we are going to add some data to this text file. Let's go back to our Jupyter Notebook. Okay, so we'll write some data to that file. So I'll write f1 dot. After that I'll use the write function, and within single quotations I'll write, let's say, hello Simplilearn, and then I'll give \n to go to the next line. I'll write again f1 dot write, and I'll pass in another message, let's say welcome to Python programming, and we'll give another / followed by n, and then finally we'll close the file. So I'll write f1 dot close function. Let's run this and we'll see the difference now. If I open this, there you go. We have some data in this text file, that is hello Simplilearn, welcome to Python programming. So this is how file objects work in Python. Alright, now moving ahead, we'll see how sets work in Python. Suppose I create a set called S, and I'll use the set function, and I'll pass in India. So this is a string, and I want to convert this string to a set. Let's say I have another set called S1, and here I have a list of values, let's say U, S, and let's say A. Now if I write S comma S1, so what set does is it will return only the unique values that are present inside each set. So here if you see India, all the elements are unique except I, because I is repeated twice, so it will return I only once in the result. But USA has all the elements present only once, so set will return all the elements. Now what if I'll write, let's say, S ampersand S1. So this will give me only the common element that is present in both the sets. So if you see here in India and in U, S and A, only A is repeating in both the sets, so it gives me A. Suppose I write S, this is the OR operator, and I'll write S1. If I run it, it gives me all the elements that are present inside set S and S1, excluding the repeating elements. So here I is repeating, so it has printed only once. Similarly, you can write S minus S1, so you get only those elements that are present inside set S and are not present in set S1. Now in set S, A is present as well as A is present in set S1, so it has excluded A from the result. Okay. Now we'll see some operations. Let's say I'll write A equal to 7 and B equal to, let's say, 2.0. I'll add A and B and store the result in my variable R, which stands for result. Let's see the output. If I write print R, it gives me 9.0, and if I check type of R, it gives me, there's a spelling mistake, I'll write type of R, it gives me float. So here Python is performing implicit type conversion. So if you add an integer with a floating point number, the result will be a floating point number and not an integer. Now if you say A equal to 7 and let's say B equal to same 2.0, and this time I am explicitly defining my result to be an integer, so I'm using an integer function. So if I write A plus B and if I print R, you see the result, it has given me an integer which is 9. Now to verify, you can also use type of R it gives me integer, but earlier it returned us float. So this is how implicit and explicit conversion work in Python. Now this example was for numbers. Similarly, you can also perform for strings and for lists, tuples and sets. Now moving ahead, one thing I wanted to tell you was you cannot add a string and an integer. Suppose I'll give a comment, string and integer addition. Suppose I have a variable called a which has a value of 7, so 7 is an integer here. Then I have a variable called b which has a value 2, but this time I'll assign this 2 within quotes, so this becomes of type string. Now if you want, you can check that as well. If I write type of 2, rather type of b, it will give us str, which means string. Now let's say I'll write r, which stands for result, equal to a plus b. Now if I print r, it will give us an error because you cannot add a string with an integer. So it says unsupported operand. The way to fix this is you need to convert this string into an integer explicitly. So this time we'll say equal to 7, b equal to 2, so it is a string. Now I'll write r equal to a plus, I'm going to use the integer function or the int function to convert my b to an integer, and then I'll print r again. Let's do this. There you go. So here we have converted my string value to a numeric value of 2, and this time it works fine. So 7 plus 2 is 9. Okay. Now let's see how you can convert a float value or a floating number into an integer number. Let's say I have a variable called a which has a value, let's say 77.9, and I'm going to create another variable called int underscore a, and I'll pass this to my integer function. So it has int of a. Now let's print int underscore a. So you have 77. So my integer function has truncated the decimal point value that had 0.9. If you want to check the type, you can use the type function. I'll write type of int underscore a. So it gives us integer. Now you can also convert an integer to a floating point value. So if I have a variable called a that has a value of, let's say, 50, and if I write float underscore a equal to, I'll use the float function to convert the variable a to a floating point value, and let's print float underscore a. So it gives us 50.0 instead of 50. You can also check the type of float a. It gives you float. Okay. Now you can also convert an integer to a complex number. Let's say I'll take the same value equal to 50. I'll write comp underscore a, which stands for complex a. I'll use the complex function and pass in my variable, that is a. Now let's print comp underscore a. So it gives us 50.0j. So 50 is the real part and 0j is the imaginary part. You can also convert an integer to a string. I'll take the same value, let's say 50. I'll write str underscore a equal to str of a. So I'm using the string function to convert my integer to a string. Let's print str underscore a. It should be an underscore and not an hyphen. Let's run it. There you go. You have 50 within single quotes. can also check the type of A. str_a, it gives you string. Cool. Now we learn how to convert a string to a tuple. So let's say I have a string that has India as its value. If I write ts equal to, I'll use the tuple function and pass in my variable that is s, and then we'll print ts. You can see here Python has converted my string s, which had India, into a tuple of individual elements, and my tuple is present inside brackets. Cool. Now similarly you can convert a string to a list. I'll use the same string s equal to India, and then let's say I want to convert it to a list. I'll use L1 equal to followed by the list function, and inside the list function I'll pass in my variable that is s, and let's print L1 and see the difference. You see here my string has now been converted into a list. You can also check the data type of L1 or the object type of L1. It returns you list. Similarly, you can also check the type of ts. It gives you tuple because we converted that string to a tuple. Now let's explore how you can convert a tuple to a list. Let's say you have a tuple called T and it has a list of names. Let's say John, we have Mary, then we have, let's say, Mark. Now to convert into a list, we'll use the list function again. Let's say L2 equal to list of T, and let's print L2. So this is a list because it is present inside square brackets. You can check the type of T. So T is a tuple, you see here. If I change this to L2, it gives you list. Cool. Now moving to the next section where we'll see how to convert integer to binary. Suppose I have a variable called a equal to 10, and then I have b equal to bin of a. Let's say we have another variable which is c, and here I want to convert my integer into a hexadecimal value or a octadecimal value. For that you can write d equal to, use the OCT function for octadecimal value. Okay, now we are going to print them one by one. So I'll write print of b, print of c, and then we'll print what is there inside d. We'll run it and you can see the results here. So binary of 10 you see here, hexadecimal of 10 you see the value here. This is an hexadecimal value. Then we have the octadecimal value of a. Okay. Now moving to the final section of this demo. Now you can convert a number to its corresponding ASCII character. Let me show you how to do it. Suppose I have n1 equal to 76. Now if I write chr of n1 and run it, it gives me L. Now let's see our ASCII table. So this is my ASCII table, and for 76 you can see here the character is L. So this chr of n1 will return the corresponding ASCII character for that particular number. So here 76 belongs to L. Let's say we have another number n2 equal to, let's say, 100. Now if I write chr of n2 and run it, it gives me lowercase d. We'll see the table again, and if you see for 100 we have lowercase d. Now here you have a list of characters. These are special characters. You have uppercase characters, you have @, you have numbers. Each of them have their own ASCII values. Cool. Now you can convert string character into Unicode values. Now let me tell you what Unicode value is. So computers on a basic level deal with numbers. So letters that appear on computers are stored by computers as a list of numbers. So the Unicode standard provides a unique number for every character and supports multiple languages and all special characters. So let's say I have a string S which has the value of capital A or uppercase A. If I write R, which stands for result, equal to ORD, so this is the function which converts a string to a Unicode value. I'll write ORD of S and will print R. If I run it, it gives me 65. So 65 is the Unicode value of A. You can also have digits. Let's say I have 7. I'll run it. So 55 is the Unicode value of the string 7. Let's try for any other letter. Let's say V and run it. You have 86. Okay. So we'll understand what is a string in Python and how to create strings in Python. Then we look at the different string methods and how to perform string indexing, and all these we'll see with the help of hands-on demonstrations on the Jupyter Notebook. So let's understand what is a string. So a string in Python is an object that represents a sequence of characters. In Python, we have str as the data type of string. Now you can create strings using single quotes or double quotes. So here is an example where we have used a single quote to write a string. So our string is Hello India, which is inside a single quote. Below, if you see, we have the same string written within double quotes. So these are the two methods in which you can create strings in Python. Now you can also use triple quotes, which are generally for multi-line strings or doc strings. So here is an example. We have a string called str3, and the content it has is human psychology is an interesting subject. Now if you print the string, it will be printed in 2 lines and not in a single line. Now we'll be exploring much more in detail in our demo session, so please wait for a while. Next, we have string indexing. So if you want to extract a few characters from your string, you can use the indexing method. So in Python, a string starts with the index number 0. So here we have a string which is healthy, and the first element is present at the 0th index. So at the bottom you see the forward index, on the top you have the reverse index or the negative indexes. So in Python, as I said, the first index is at the 0th position, so H is at 0, E is at the first index, A is at the second index, so on and so forth. Now similarly, if you look at negative indexing, it starts with -1 in reverse order. So we have -1 for Y, -2 for H, -3 for T, and so on and so forth. Now let's head over to our Jupyter Notebook where we'll learn about strings in Python in detail. Okay, so I'm on my Jupyter Notebook. First, I'll create a new notebook. I'll click on New and then select Python 3. Okay, so here let me rename my notebook as Strings in Python Demo. I'll click on Rename. Okay. Now let's start with our first example. I'll create a variable called str1 that will have a string. You can see here I am using single quotes now. I'll write Hi Sam. So here str1 is holding a string called Hi Sam, and let's go ahead and print the string str1. I'll hit Shift Enter to run it. You see here I have my string printed Hi Sam. Now if you want to check the data type that str1 holds, you can use the type function, and inside the type function I'll pass in my variable str1. If I run it, you see here it gives us str, which means it is of type string. Now let's create another string str2 using double quotes this time. So I'll write, let's say, hello, Angela. I can give exclamation mark. Okay, now let's just print the second string. You see here, this is my second string, which is hello Angela. If you want, you can also use the print function here and run it. You get hello Angela. Now let's write a multi-line string using triple quotes. So I'll write str3 equal to, I'll use triple quotes, and then I'll say hi everyone. Go to the next line. I'll write today we will learn about. I'll go to the next line and I'll write strings in Python. Then I'll again give triple quotes to close my string, and let's just print this str3. If I run it, you can see it here. I have now written a multi-line string. Hi everyone, today we will learn about strings in Python. Let me just add a S. There you go. Okay. Now coming to the next topic, we'll learn about indexing. Alright. Let me declare a string str1 which has value as Simplilearn. Now to use indexing and extract certain items in a string or values in a string, you can use square brackets, and inside the square brackets you can give the index position. For example, if I write str1 and in the square bracket I'll give, let's say, I want to find the element or the value present at the 0th index. Let's run it. It gives me S, because as we learnt in the slides, the first index in a string starts with the 0th number. So I have S in my 0th index, so hence it has printed S. Let's explore a few more. If I write str1 of, let's say, I want to know what is present at the 3rd index. If I run it, it gives me P. You can check now. So S is at the 0th index, I is at the 1st index, M is at the 2nd index, and P is at the 3rd index. Let's say I'll write str1 of, let's say, 12. We can see the difference now. It gives us an error. It says string index out of range. The reason being, Simplilearn does not have any value at the 12th index. So it's printing an error saying string index out of range. Now let's change this to 6 and see what we have. At the 6th index we have L. If you count here, S is at the 0th index, I is at the 1st index, M is at the 2nd index, P is at the 3rd index. The first L is at the 4th index, again I is at the 5th index, and then we have the second L at the 6th index. So we have L printed here. Now let's see how to use the slicing operator using colon. I'll write slicing operator. Okay. I'll use the same string str1. Let me print it once again. We have Simplilearn. Suppose I write str1 within brackets. I'll use the slicing technique now. I want everything starting from the 0th index. I get Simplilearn. So here I am printing everything that starts with the 0th index. Next, let's see what we have if I print my string str1 and write 1:6. I'll run it. It gives me IMPLI. So if you notice here, I want to extract whatever is present from the 1st index till the 6th index, but excluding the 6th index. So in Python, the indexing method or the slicing method will exclude the last index. So here, if you see, I is at the 1st index, M is at the 2nd index, P is at the 3rd index, L is at the 4th index, and then we have I at the 5th index, and we have excluded the 6th index, that is the second L. So hence it has written as IMPLI. Now similarly, let's say we'll see another example. I'll write str1. This time I'll use colon 6. If I run it, you get simply. So it has printed everything starting from the 0th index till the 6th index, but excluding the 6th index. So you have all these values from 0th index till the 5th index. Okay. Now you can also reverse a string. For that you can use negative slicing using 2 colons. If I write print str1 and within square brackets I'll give colon colon -1. Let's run and see the result. There you go. If you see this, it has printed my original string, which is Simplilearn, in reverse order now. So this is a very simple method. If someone asks you to reverse a string or print something in reverse order, you can use the negative slicing method. Now let's explore a few more examples. If I write str1 and within brackets I'll give -1 and run it, it returns me n, because in my original string, if I go on the top, I have n at the last index, which is here -1. Similarly, let's see what we have at -3. We have a here. If I go to the top, you see here n is at -1, r is at -2, and a is at -3, and hence it has given us a. Now let's say I'll write str1. I want to print -2 colon, and let's see the result. It has given us r and n. So here we are printing only the last 2 elements in the string, hence we have used -2. Okay. Now Python does not allow you to reassign values in a declared string. Let me show you what I mean. I'll give a comment here. Reassign strings. Suppose I have the same string str1, which is Simplilearn. Say I write str and I want to replace the value present at the 3rd index with, let's say, O. And if I were to print str1 now, Python will throw an error saying str object does not support item assignment. So it is immutable, like tuples, where you cannot reassign any values. You can also delete a string. Say I have another string called str2, which has a value of, let's say, Python programming. You can use the del keyword and write str2, and now let's print str2. You will see that it says name str2 is not defined because we have already deleted str2 in the above step. Okay. Now let's go ahead and see some of the important string operations. Okay. Say I have str1 which has Python. Now one thing to note, I am using either single quote or double quote. You can use whatever you want. Let's say I have another string which has programming. So these are my 2 strings. Let's perform a few operations on these strings. Say I write str1 multiplied by 3 and I'll run it. You can see here it has printed Python thrice because I have said str1 multiplied by 3. So in str1 we have Python, and multiplying 3 returns Python 3 times. Now let's say I'll write str1 plus str1. It has merged Python twice, so I have Python and Python repeated. Let's say I write str1 plus str2. We'll see the result. It gives us Python programming. So basically, if you use the plus operator with 2 strings, Python will perform a concatenation operation, which means it will merge both the strings. Now if you want to find if a specific character is present in a string or not, you can use the in operator for this. Let's say I'll print whether W is present in str1. If I run it, it gives us false because in str1 we have Python, and if you see here we don't have the letter W in Python, and hence it has given us false. Now let me copy this. I'll paste it here. Let's try whether O is there in string1 or not. It gives us true because we have an O here. You can see here we have an O. Similarly, let's say I want to find whether LA is there in string 2 or not. If I run it, it gives us false because in string 2 we have programming and we don't have any LA present in programming. Let's say we'll see whether RO is present in string 2 or not. This time it returns us true because if you see here we have RO in programming, and hence it has given us true. Now you can also print a raw string using the R alphabet. So the way to write is I'll write R, give a single quote. Let's say I'll give a location C drive 2// and let's say I'll write Python 3.7 and run it. It gives me a raw string. Now let's see some formatting methods. I'll write a comment saying format methods. Okay. I'll write a print statement. I'll give double quotes, and here let's see the first example where I'm using curly braces. I'll write and I'll give another curly braces. You'll get to know what I'm doing once I finish this. Let's say I have a message, both are best friends. Then I'm going to use my format method, and inside this I'll pass in my two values for these braces. So these curly braces will be replaced by the words that I pass in, or the values that I pass in within the format method. So here I'll write, let's say James, and my second person would be Brad. Now let me run it. You see here what Python does is it replaces the curly braces with the names that I have passed within the format method. So it takes the first argument for the first curly brace and the second argument for the second curly brace. So my statement becomes James and Brad both are best friends. Now let me just copy this. I'll show you another example. This time I'll give 1 and 0 inside the curly braces. Now if I run this, there you go. So here James is at the 0th index. So this is basically a list where James is at the 0th index and Brad is at the first index. So if I write 1 and 0, it will take Brad here, and then for 0 it will take James. So now my message becomes Brad and James both are best friends. Now let's try out another example. I'll paste it here. I'll use two variables, let's say A and B, and inside my format method I'll write A equal to James and I'll assign B as Brad. Let's run it. There you go. We have our message printed. James and Brad both are best friends. So here A refers to James and B refers to Brad. Cool. Let's explore another example. I have a variable called name and that has a value Angela, and then I have another variable, let's say salary of $100,000. I'll use a print statement. I'll print a message. Her name is, I'll use %s for string, give a \n for next line, and I'll write her salary is, then I'll write %d, this is for numbers, and then I'll give another percentage, and let's say I'll write my two variables, name and salary. Let's see what we have in the result. I need to close my double quotes here. I'll exclude it from here. Let's run it. There you go. So I have my message here. Her name is Angela. Her salary is $100,000. I'll just delete the space here. We'll run it again. Okay. Now this %s refers to the name, and we have declared her name is Angela. So my first statement or the message becomes her name is Angela, and the next message is her salary is %d. So %d here refers to the salary where we have 100,000. So the next message is her salary is 100,000. So these are the very basic and important print methods or formats that you can use while working with strings. Now we'll explore a few functions that are readily available in Python to operate with strings. I'll take my same string str1 as Simplilearn, and then I'll create another variable called str2. I'll write str1 dot, I'm going to use the capitalize method. Okay, let me make one correction. I'm going to write everything in lowercase so that we can see the difference, how we can capitalize the string. So I'll write my print statement, print old value. This is going to my message. I'll give a colon followed by my double quotes, and I'll pass in my variable str1. Okay, now I'll copy this. In the next line we have a new value as str2. Let's run it and see the difference. There you go. So here my old value has Simplilearn in all lowercase, but when I used the capitalize method, so Python has converted my first letter in Simplilearn to uppercase or capital case. Cool. Now let me copy this. I'm going to use the same example for the next three methods. Let me show you how the case fold method works. This time I'm going to pass my input string in all uppercase. I'll write Simplilearn in uppercase, and instead of capitalize I'll write case fold. Let's run it and see the difference. There you go. Initially we had Simplilearn in uppercase, and now we have converted into case fold, so all the letters are in lowercase. Now moving ahead, you can also use the upper method to convert a string into uppercase. Let's say I have a string where few of the letters are in uppercase and few of the letters are in lowercase. This time I'm going to convert everything into uppercase, so I'll use the upper function instead of case fold. Let's run and see the result. There you go. So this time Python has converted my original string into uppercase. And likewise you can also use the lowercase instead of upper. If I write lower, you see here everything has been converted to lowercase. Cool. Okay, now I'll show you how the title method works. So in title method, all the words, basically the first letter of all the words will be in uppercase. So suppose I have a string which is Simplilearn company. So I'll write, let's say this is my string, and I'll convert my str1 to title case. Let me run it. So this is the difference you can see. The first letter of the first word is uppercase. Again, the first letter of the second word is also in uppercase. So this is how the title case works. Now you can also count the occurrences of a particular element in a string. Suppose I have string 1 that has Python programming. In str2, I'll write str1 dot and use the count function to count how many times, let's say n, the letter n is present. Then I'll print saying occurrences, give a colon here, and then I'll pass in my variable, that is str2. So this will count the number of times n is present in my original string. So if you see here, in Python programming we have n present twice. Similarly, let's check for G. The letter G is also present twice. Let's see for Y. Now Y is present only once, which you can see here. Okay. Next, let's see how the replace function works in Python. I'm giving a comment as replace. So let's say I have a string str1 which has Hamburg is located in France. So Hamburg is a city which is actually located in Germany and not in France. So using the replace method, we are going to replace France with Germany. So what I'll do is I'll create another string str2 equal to, I'll write str1 dot, and then I'll use the replace function, and I'll say replace my string France with country Germany, and then we'll print str2 and see the result. There you go. So we have changed Hamburg is located in France to Hamburg is located in Germany. Now coming to the final method that we are going to explore in this Python strings demo, which is using the split function. Okay, so you can split the values or each word in a string as separate words and store it in the form of a list. So I write str1, I'll just copy this, I'll paste it here, and I'll change France to Germany because Hamburg is actually present in Germany and not in France. And then I'll create another variable called str2. I'll write str1 dot and then use the split function. Now let me print both the strings. First I'll print str1 and then I'll print str2. If I run it, you see my original string was Hamburg is located in Germany, and then using the split function we have segregated or divided each of the words present in the original string into separate words, and this time it is present in the form of a list. Let's see what operators are in Python. Now operators are generally used to perform operations on values and variables in Python. These are standard symbols used for logical and arithmetic operations. The value that the operator operates on is called the operand. So here on your screens you can see the different types of operators available in Python. First we have arithmetic operators. So arithmetic operators are used to perform mathematical operations. It returns either true or false according to the condition. So these are the comparison operators. You have less than, less than equal to, greater than equal to, we have not equal to, and we have equal to equal to. Third, we have assignment operators. So assignment operators are used in Python to assign values to variables. So these are the assignment operators. You have equal to, you have plus equal to. So for example, you have a variable called x, and if you say x plus equal to 7, this means it is x equal to x plus 7. Similarly, if you say x minus equal to 7, this means x equal to x minus 7. And similarly, you can see the other assignment operators here. Next up, we have the logical operators. So logical operators are used in the expression evaluation to make a decision. If both the expressions are true, then the condition will be true for an AND operator. For an OR operator, if one of the expressions is true, then the OR condition will be true. Now for NOT, if an expression A is true, then NOT A will be false. We also have bitwise operators. So bitwise operators act on operands as if they were strings of binary digits. It acts on bits and performs bit by bit operation. So hence it is called bitwise operator. So here each value is evaluated as zeros and ones. Then we have identity operators. So identity operators are used to check if two values are located on the same part of the memory. Two variables that are equal does not imply that they are identical. We'll understand each of these operators in the demo session on the Jupyter Notebook. And finally, we have membership operators. So membership operators are used to test whether a value or variable is in a sequence. So you have is and is not as identity operators. In membership operators, we have in and not in. Now let's head over to our Jupyter Notebook and we'll see and explore all these operators one by one. So I am on my Jupyter Notebook, operators in Python. So let's first start with arithmetic operators. I'll just give a comment here saying arithmetic operators. Okay. First up, we'll see the addition operator. For that, let me assign two variables. So I have assigned a variable x to a value 10, and let's say we have the second variable y equal to 4. Now if I say print x plus y, it will perform an arithmetic operation, that is addition, and will sum the result of x and y and gives me 14, because 10 plus 4 is 14. Now let's say I'll write print x minus y, that gives me 6 because 10 minus 4 is 6. Similarly, you can have multiplication as well. So I'll write x asterisk y, that gives me 40 because 10 multiplied by 4 is 40. Similarly, let's say x divided by y. It gives me 2.5, which is basically the quotient of these two operands. Alright. Now if you were to find the remainder, you can use the modulus operator. So I'll write x modulo y. It gives me 2. So you divide 10 by 4, the remainder is 2. Now you can use the double asterisk operator, which is basically known as power. So the left operand is raised to the power of right. I'll write print x, give 2 asterisks, and then say y. It gives me 10,000. So what basically Python does is it will raise 10 to the power of 4. So 10 is multiplied 4 times and the result is 10,000. You can also try out another example. Let's say 2 raised to the power of 4. This gives me 16. If I say 2 raised to the power of 3, that is 2 cube, and the result is 8. You can also perform floor division. So floor division results into whole number adjusted to the left in the number line. So if I write print x, and floor division is given by 2 /, then I'll write y, that gives me 2. So it returns a whole number. A generic division gives me 2.5, that has the floating point value, but a floor division will give me a whole number adjusted to the left on the number line. Alright, so these are some of the basic arithmetic operators that are very popular in Python. Next, we'll move on to assignment operators. I'll give a comment as assignment operators. Okay. Let's assign a value x equal to 7. So here we are assigning the value of 7 to x, and your equal to is an example of assignment operator. Now if I print x, it will give me 7. Now let's say I'll again write x equal to 7, and in the next line I'll write x plus equal to 3, and will print x. So what Python does is it adds 3 to my original value that x holds, that is 7. So here x plus equal to 3 means x equal to x plus 3. So x equal to x plus 3 can be written as x plus equal to 3. Similarly, you can also write x minus equal to something. Say x equal to 7, and then I write x minus equal to 3. Then we'll print x. This gives me 4 because we are subtracting the original value of x by 3. So here x minus equal to 3 means x equal to x minus 3. Okay. Similarly, let's say I'll write x asterisk equal to 3. If I run it and print the value of x, it gives me 12 because our previous x value was 4, and now we have multiplied x by 3. So x value now becomes 12. Let's say I'll write x divided by 3, and I'll print x. It gives me 4.0. This is a floating point number. So we are dividing 12 by 3, and the result is 4.0. Cool. If you want, you can also perform an exponent operation or a power operation. So let's say I have x equal to 7, and then I write x double asterisk equal to say 2, and then we'll print x. Okay, there is an error here. Let's debug the error. I have put a space here. Let's delete that space. You have to keep this in mind. Now let's run it. There you go. So 7 raised to the power of 2, which is basically 7 square, is 49. You can change the values and run other examples. Let's say 10 raised to the power of 3. We have 1000 as the result. Okay. Now moving ahead. Now we'll understand about comparison operators. So I'll give a comment as comparison operators. Okay. Let's say I have x equal to 7, and then I have y equal to 3. If I print x equal to y, it will give me false. The reason being, the value that x holds is not equal to the value present in y. These are two different values that x and y hold. So x is not equal to y, and if we print x equal to y, it will give us false. Now I'll just copy this code. I'll print it here, and instead of equal to, I'll give not equal to. So not equal to is represented by an exclamation mark followed by an equal to. If I write x not equal to y, this gives us true because x and y are two different values and they are not equal. I'll print my code again, and this time let's say I'll write x greater than y. It gives us true because 7 is greater than 3. If I write x less than y and hit shift enter, that gives me false because 7 is not less than 3. I'll print the code again. This time we'll see if x is greater than equal to 3. If I run it, it is true because 7 is greater than equal to 3. And now let's check for less than equal to. This is false because 7 is not less than equal to 3. Okay, so these are some of the basic comparison operators that are available in Python. Now moving ahead, we'll see how logical operators work in Python. Okay. First, we'll look at the AND operator in Python. Suppose I have a value of 7 stored in x and then I have a value of 12 stored in y. If I write print x greater than 2 and y less than 10, let's run it and see the result. It gives us false. Now AND logical operators will return true if both the conditions are true, and it will return false even if one of the condition is false. So here x is greater than 2, which means 7 is greater than 2 is true, but y less than 10, which is 12 less than 10, is false, and hence our entire expression becomes false. Next, let's say I have x equal to 5 and then I'll print x greater than 3 or x less than 10. If I run this, it returns us true. The reason being x greater than 3 is true, which means 5 is greater than 3, that is true, but 5 is not less than 10. But since one of the conditions is true, so the OR operation in Python returns us true. Now let's see another example. I'll write x equal to 5 and y equal to 10. I'll print x greater than 10 or y less than 20. If I run this, it returns true. So let's see our expression. X greater than 10, that is 5 greater than 10, is false, but y less than 20, so 10 is less than 20 is true. So our OR operation will give us true since one of the condition is true. Now moving to the next logical operator, we have NOT. I'll give an comment here as OR, and now we'll see NOT. Let's say I have x equal to 5 and then I'll print x greater than 3 and x less than 10. This should ideally give us true. The reason being x is greater than 3 and x is less than 10. Let's run and verify. Okay, so this is true. Now let me copy this and I'll paste it in the next cell. Now I'll replace my above print statement with a NOT operator, and we'll close our print function with another bracket. Now let's run it. So this will give us false because my expression evaluates to true, but not true is false. Okay, now moving ahead, let's discuss identity operators in Python. Alright, so we'll start by assigning a value of, let's say, 505 to x, and then in y I'll have 500 plus 5, so which is also 505. So x and y hold the same value of 505. Now I'll print x comma y. So you can see here both the values are same, 505 for x and y. Now I'll use the logical operator, that is double equal to or equal to. I'll write x equal to y. This will give us true because x and y hold the same value of 505. But let's check with the identity operator. So I'll write x is y. If I run this, it gives me false. The reason being, x and y both refer to objects whose value is 505. They are equal, but they are not referencing to the same object. Now this you can verify using the id function in Python. If I write id of x, this will give me the memory location that x has. You can see this is the memory location of x. Now if I write id of y, there you go. So this is a separate memory location in which y is holding the value of 505, and hence x is y is different, and hence it is false. Now suppose I write x equal to 100 and I have y equal to 200. If I write x is not y, this gives us true. The reason being, x and y both are holding different values, so x is not y is true. Let's see another example. This time we'll define two lists. So I have a list called A that has value, let's say 5, 6, 3, 7, 1, let's say 9. And then I'll have another list that will also have the same elements. I'll copy this and I'll paste it here. Okay, if I write C equal to A, and then we'll print A is C. If I run this, it gives us true because we are assigning the variable A to C, and hence the memory locations are the same for both, and hence A is C gives us true. What if I write A is B? Now this gives us false. So here A and B are both less. They are equal but not identical. It is because the interpreter in Python allocates them separately in memory although they are equal. Okay, now let's talk about membership operators in Python. I'll give a comment as membership operators. Okay, let's say I have a list A that has the above values 5, 6, 3, 7, 1 and 9. I'll copy this and I'll paste it here. Okay, I have another list B that has different types of elements. We have 4, next element is Python, then we have 2, 7, let's say Simplilearn, and then I have 9. I'll run this first. So I have my two lists A and B. I have printed them. Let's explore how the membership operator works. So we saw in the slides, in and not in are two membership operators. If I write 5 in A and run it, it returns me true because you see here 5 is present in A, and hence 5 in A will return true. What if I write 55 in A? This gives us false because you see here in the list A we don't have an item 55 in A. So it gives us false. What if I write 4 in B? This gives me true. You see here in B we have the element 4, so 4 in B is true. One thing I wanted to show you is what if I write Python in B? You see here it gives us false. Though we have Python in our list B, but the Python I'm trying to check is not present in B. The reason being here Python is written in lowercase, but what I am checking, Python P is in uppercase, so it is case sensitive, and hence this gives me false. Let's say I'll declare a dictionary y equal to, and within curly braces I'll give my key A and I'll assign the value of India. Let's say I have another key B and that has a value, let's say USA. Now if I check A in Y, it gives me true because your key A is present in Y. Now what if I check India in Y? Now this gives me false. So here the membership operator won't work on the values, it only works on keys in a dictionary. Now let me go ahead and change the keys to numbers. I'll give 1 that has India and the second key I'll have 2. Now if I change A to 1, it will work fine, it gives me India, but if I write USA in Y, it gives me false. As I said, the membership operator won't work on the values, it only works on the keys in a dictionary. Cool. Now coming to the final section of our demo, we'll explore about bitwise operator. Okay. So Python bitwise AND operator returns 1 if both the bits are 1, otherwise it will return 0. So first let's see 7 ampersand 2. If I run it, it gives me the value of 2. So what Python does is it will first convert the numbers 7 and 2 to their binary equivalents, that is in the form of zeros and ones, and then it will perform the bitwise AND operation. So 7 ampersand 2, the value is 2. If I write 3 ampersand 5, the value is 1. Again, it will first convert 3 and 5 to binary equivalents in the form of zeros and ones, and then it will perform the AND operation, the bitwise AND operation. Now the Python bitwise OR operator returns 1 if any of the bits is 1. If both the bits are 0, it will return 0. So if I write 10 or 5, it gives me 15. So first it will convert 10 and 5 to binary equivalents, and then it will perform the bitwise OR operation. Let's see another example. I'll write 4 or 8. I'll run it. So the bitwise OR operation gives us 12 as the result. In programming languages, conditions play a very crucial role. They help us develop programs that can satisfy all the business conditions and perform well. So conditional statements are useful when we have to decide that a certain condition or certain part of a code should run only if the condition is true. So the if statement is an example of conditional statements. The program will first evaluate the test condition and will only execute the code block if the test conditional expression is true. So here you can see the syntax of if statement. First we have the if keyword, and inside parenthesis we are going to pass the condition, and if this condition evaluates to true, then we go inside the body of the if statement, which is this part of the syntax. Now, while developing a code for a business problem, you might have to use multiple conditions. So the elif statement is used when we have to check multiple conditions. So here you can see if the first test expression evaluates to false, then you have the elif condition, and if the elif condition evaluates to true, then we go inside the body of the elif statement, which is this part of the statement or the syntax that I'm highlighting. Next, so sometimes you want to evaluate a condition and take one path if it is true, but specify an alternative path if it is not. So this is done with an else clause. So the else code block will run if the expression is false. So here you can see if the condition for the elif statement returns false, then we have the body of the else statement. And finally, after all the if, elif and else statements have been executed, we'll execute if there are any other statements which are present outside the if condition. Now moving ahead, we will use if, else and elif statements to write a program that will solve a business problem. So based on the location and total amount of the items, we are going to find the shipping cost. The locations are a few states in the United States. In the if statement project, we will ask the user to enter the amount of the package or the item, and we'll also ask the user to input the state name. So for the different states, we'll define the conditions using the total amount of the items and print the shipping cost. So let me take you to my Jupyter Notebook where we'll do this project. Okay, so I am on my Jupyter Notebook. Let me just rename this notebook. I'll say if statement and project. Alright, so let me go ahead and give a comment. I'll say package delivery cost based on the location and total amount. Alright, first and foremost, I'll go ahead and create a variable called total. Now this will be a user input, so I'm using the input function, and here I'll pass the message as enter the amount for the item. Alright, next I'll assign another variable called state. This is also going to be a user input, so I'm using the input function, and I'll say enter the state name in USA. So these are the two inputs we are asking from the user, that is to pass the amount for the item and the state in the USA. Alright, now we'll start with our first if statement. I'll write if state equal to, let's say my first state name is Texas. I'll give a colon. Make sure the syntax you are writing is correct. Now I'm going to use another if statement, so this becomes a nested if statement. Now I'll write if total, which is my item amount, so I'm checking if total amount is less than or equal to 150, then I'm going to print shipping cost in Texas is, let's say, $30. Alright, now I'll pass my next condition using elif statement. Since I'm using multiple conditions, so hence I'm going to use the elif statement. This time I'll write if total is greater than 150 and if my total amount is less than or equal to $250, then I'll say print. I made a spelling mistake, this should be shipping. I'll say print shipping cost in Texas is, let's say, $20. So usually if your amount of the item is high, then the shipping cost is low. So here you can see if the total amount for the package or the item is less than $150, then your shipping cost is $30. But if it is between $150 and $250, your shipping cost is less, which is $20. Then I'll say else print shipping cost in Texas is $5. So what basically this means is, if your total is less than or equal to $150, then the shipping cost would be $30. If your total amount lies between $150 to $250, your shipping cost is $20. And if the cost of the item or the package is more than $250, the cost is $5. So this is for Texas state. Now moving ahead, I'll write elif. This time we'll check the condition for state, let's say Florida. I'll use a colon here and say if my total is less than equal to $150, then we'll print shipping cost in Florida is, let's say, $45. I'll use the elif statement again. I'll say elif total, if it is more than $150 and if it is less than or equal to $250, I'll write print shipping cost in Florida is, let's say, $35. Next, I'll write my else statement. I'll say print shipping cost in Florida is, let's say, $10 if the cost of the item is more than $250. Now one thing to note here is the shipping cost is different for the different states in the US. Alright. Now we'll move on to our next state. Let me give a space here. I'll say elif state equal to, let's say we'll take Virginia now. I'll say if total is less than or equal to $150, will print shipping cost in Virginia is, let's say, $23. Alright, I'll just scroll down. Next, I'll write my elif statement. I'll say elif total is greater than $150 and total is less than equal to $250, then we'll print. I just copy this message, paste it here, and we'll say shipping cost in Virginia is $15. Next, we'll write our else statement, else print. I'll paste the message again. I'll say shipping cost in Virginia is $5 in case the cost for the items is more than $250. Now moving to our final state, I'll write another elif statement. I'll say elif state equal to let's say New Jersey, if total is less than equal to $150, then we'll print, just paste the message here. I'll say shipping cost in New Jersey is, let's say, $40. Now I'll say elif total, if it is greater than $150 and if total is less than equal to $250, we'll print, just put this within double quotes, and I'll say shipping cost in New Jersey is, let's say, $10. I'll say else print my shipping cost is free in case the total amount for the items is more than $250. Alright, finally we'll have our else statement where I'm going to print invalid state name in case the user enters any other state apart from New Jersey, Virginia, Florida, and Texas. Alright, so we have our small project ready. Let me just run through it. So first we are declaring two variables, total and state, and we are taking this as user input. So the user is going to input the amount for the item or the amount for the package, and then the user will input the state. So we have the 4 states defined here, and we are checking the shipping cost for these 4 states based on the amount for the items. Alright, now let me go ahead and run it. So here you can see we have our first user input, enter the amount for the item. Let's see, I have my amount as $125, and the next input is enter the state name in USA. I'll say, let's say, Florida. If I run this, it gives me the shipping cost in Florida is $45. Let's go to the top and see what we have. Now our total was $125, which is less than $150, and hence it has printed shipping cost in Florida is $45. Let's run this again. This time I'll say, let's say my item costs $255 in the state, let's say New Jersey. Let's run it. You see here it gives us the message shipping cost is free. Now the reason being, if you see this part of the code, for state New Jersey, if the total amount for the items is more than $250, the shipping cost is free. Now let's try for another state. This time we'll see for Virginia. Let's say my amount is $190 and my state is Virginia. If I run it, it gives me the shipping cost in Virginia is $15. Let's check our code. So here I have entered my item amount to be $190, so it lies between $150 and $250, and hence it has printed the message that shipping cost in Virginia is $15. Now let me enter another state name that we have not defined in our code. Let's say I have my item amount as $290 and the state name I'll give is, let's say, Colorado. If I run it, it gives us the message as invalid state, which is present in the last part of our code. So since we haven't defined any shipping cost for Colorado, it has given us the message that the state I am trying to search for is invalid. You can check for another state or any other country name, anything that is not part of our project. Let's say I'll enter my amount as $100, and this time I'll enter my state name as, let's say, Ohio, and we'll run it. It again gives us invalid state. Let's try out one last time. I have my package amount as $350 and let's say my state is Alaska. Again it says invalid state name because we haven't defined any condition for Alaska state. So this was a very simple project that we did using our if statement. We saw how to write nested if, and we saw how to use the elif and the else statement. We will start by learning the basics of loops and look at for loops in Python. Then we will understand about while loops in Python with its syntax and coding examples. Finally, we will see how to write nested loops in Python with hands-on demonstrations on the Jupyter Notebook. So let's get started. So what is a for loop in Python? A for loop in Python is used to iterate over the items or elements present in a sequence. The items present in a sequence can be in the form of a list, tuple, dictionary, or even a string. A for loop in Python uses the range function to iterate over a specific number of times. Now let's have a look at the syntax of a for loop. So here on the left you can see the syntax of the for loop. So we have the for keyword followed by the iterator variable. Then we have the in keyword followed by the sequence. It can be a list, you can use the range function, it can be a dictionary, a tuple, anything. And after that you have your colon followed by the statements that you want to execute in the for loop. And below you have the rest of the code. And here on the right you can see this is the flow chart of a for loop. So you have for each item in sequence, then we check the condition. If you have reached the last item, if that is true, you exit out of the loop, but if it is false, you keep on running or executing the statements that are present inside the for loop. This will continue until and unless you have reached the last item in your sequence. Okay, now let's head over to our Jupyter Notebook where we'll see for loop in detail and we'll explore a lot of code examples. Okay, so here I am on my Jupyter Notebook. Let's start by writing a simple for loop. Suppose I have a variable, say s, and it has a value which is a string, let's say Simplilearn. Okay, now the way to write a for loop is I'll say for I, which is my iterator variable. It can be any valid variable name in Python, in my variable that is s. So here s becomes my sequence. I'll say print I. So what this for loop is going to do is it will iterate over all the characters that are present in my string and print them one by one. Let me run it by hitting Shift Enter. You see here using this for loop, we have iterated over all the letters that were present in my string, that is Simplilearn, and we have printed them one by one. Okay. Now the print function in Python provides a parameter called end. So by default, the value of the parameter is \n, that is the new line character. Now you can end a print statement with any character or string using this parameter, which is end. Let me show you what I meant. So I'll again have my same string Simplilearn. I'll say for I in my variable or my sequence s, I'll say print I, comma, then I'll use my end parameter equal to, and my end parameter will have a value of asterisk. Now let me run this. You can see here, this is sort of a pattern that we have printed. So between each letter in my string Simplilearn, we have an asterisk. Okay. Moving ahead, let's see how to use for loop in a list. Alright, I'll declare a list called programming, and this list will contain a few programming languages. Let's say we have Java, and then the next item we have in the list is Python. Next we have Ruby, and then we'll have HTML. Okay, so I'm going to print all the individual items that are present in my list using the for loop. So I'll use the same syntax. I'll write for. This time I'll use my iterator variable name as iter, which means iterator. For iterator or iter in my sequence, which is programming, I'll say print iter. Let's run it. You see here we have printed all the items in my list one by one: Java, Python, Ruby, and HTML. Alright, now let's see an example how you can find the average of a list of numbers using for loop. So I'll give a comment saying find the average of a list of numbers. Okay, so here first of all we'll declare a list of numbers with variable list underscore num equal to, it will have a few numbers, let's say 20, 25, 10, 50, and 40. Let's make it 45. Now to find the average of a list of numbers, first I'll declare a variable called sum that will have a value of 0. So we have initialized the sum variable to 0. Then I'll start my for loop for I in my sequence, that is list underscore num, which is this variable. I'll give a colon. I'll write sum equal to sum plus I. So here just give a space to make it more readable. So I'm adding all the numbers in my list, and we are storing the result in the variable sum. Then we'll say print sum equal to, I'll pass in my variable that is sum. Then I'll say print average equal to, now our average will be my variable sum divided by the length of my list that has all the numbers. Let's run this. You see here, so our total sum of all the numbers present inside the list is 150, and the average of all these numbers is 30. So 150 divided by 5 is 30. Alright. Now let's see how you can use a for loop using a tuple. So let's declare a variable called num. This is going to be a tuple of numbers, and we have 30, 45, 60, 50, and let's say 70 as the numbers inside the tuple. I'll say sum equal to 0. Then we'll have our for loop for I in my sequence, that is num. I'll say sum equal to sum plus I. So here we are just adding the values that are present inside the tuple. I'll say print sum. So here you can see we have printed all the values present inside the tuple one below the other. Now if I shift my print statement to here, you can see here this is my sum of all the numbers that are present inside the tuple. So make sure you have the current indentation. Now let's see how you can use the range function in Python. Okay, so you can use the range function to iterate over a range of values or numbers using a for loop. The way to do is I'll say for I in my function range, I'll give my first index at 1 and my second index at, or my end index at 10. So this will go from 1 till 9 and exclude the 10th index. I'll say print I. You see here for I equal to range 1 to 10, we have printed all the numbers starting from 1 till 9. So the last index, that is 10, is exclusive in the range function. Now in the range function you can also give a third parameter that stands for step, so that you can skip a few steps and print the next value. Let me show you what I mean. Say I write for I in range 0, which is my starting index, 10, which is my end index, and I'll have a step size of 2. Give a colon. I'll say print display values with a step size of 2. Give a comma here and my variable, that is I. Let's print it. There you go. So we have printed the values with a gap of 2. So it starts from 0, then we are jumping 2 steps, and then we are printing 2, then again 2 steps, we have 4, 6 and 8. So we are skipping one value and printing the next value in my sequence ranging from 0 to 10. Alright, now let's write a program to print a table of a given number. So I'll give a comment as program to print table of a given number. Alright, so I'll pass my variable n, which is going to be a user input. So I'm using the int function, and inside the int function I'll use the input function to take the user input. I'll give my message as enter the number. I'll say for I in range from 1 till 11, I'll say multiply, which is mul here, n asterisk I. So basically what I'm doing here is I'll take a user input of the number. Let's say we want to print the table of 5. So from 1 till 10 we'll have the product of the numbers. Let me print it. I'll say print n comma within double quotes I'll give my asterisk. comma I, comma within double quotes I'll say equal to, and then we'll have our variable mul. Let's run this, enter the number, I'll give 5 and hit enter. There you go. So here we have the multiplication table of my number 5. So you say 5 into 1, which is 5, 5 into 2 is 10, then we have 5 into 7 35, 5 into 9 is 45, then our last index which ends at 10, so we have 5 into 10, that is 50. Alright, so this is how you can create a simple multiplication table using for loop in Python. Now we can also use the range function with a sequence of items. The len function can be combined with the range function to iterate through a sequence using indexing. I'll show you an example here. Let's say we have a list called list2, and here we have a list of programming languages, let's say C++. You can either use a single quote or a double quote to represent the text values in a list. The next programming language I have is Java. Then let's say I have Python, and we have R. Okay, so I can write for I in range. Here I can use the length function, and I'll say list2, give a colon, then we'll print hello, and I'll say list2 of I. So what it does is my iterator will iterate over the list of programming languages I have here, and it will keep on iterating till the length of the list, and then I'm printing my message as hello, and it will take each item from the list using the index number. If I run it, you can see here it says hello C++, hello Java, hello Python, and hello R. Cool. Now let's see how you can use nested for loops in Python. I'll say nested for loop as my comment. Let's say I have a list of company names. My first company I have in my list is Google. Let's say Apple, PwC, and then we have Uber. So here I'll write for I in companies, I'll say print, we will display each letter of, I'll say plus I. Now I'll use my second for loop saying for letter in I will print the letter. Let's run it and see our result. There you go. So here we have used two for loops, so that becomes a nested for loop. We have my outer for loop, and then we have our inner for loop. So in the outer for loop we are just printing the name of the company. So here we say we will display each letter of plus I, which stands for my company name Google. So you can see below we have displayed each letter of Google using the inner for loop. Similarly, we have for Apple, you can see APPLE, we have PwC, and then we have Uber. So this is how you can use multiple for loops in Python. Now let's see how you can use a for loop with else clause. So I'll give a comment for loop with else clause. So I'll write for I in range 0, 10, I'll give a step size of 3. I'll say print I, and after this Python gives you the flexibility to use an else clause after the for loop. So I'll write else print the loop has completed execution. So this is my message that we are going to print after we have printed all the elements that are present inside this range function. Let's run it. You can see here we have printed the value starting from 0 with a step size of 3. So we have 0, 3, 6 until 9, and then after that we have our else block printed, which has the message the loop has completed execution. Cool. Now let me show you two more important features that you can use while writing a for loop. One is called the break statement, the other one is called the continue statement. So in Python you can break the for loop and end it before it has actually run all the elements in the iterable using the break statement. So let me show you a simple example. If I write for, just give a space here, I in range, let's say from 1 to 10, I'll use an if condition saying if I equal to 6, then break and come out of the loop. Next we'll print I. So here what we are doing essentially is we are iterating over all the values from 1 to 10, and whenever the I value becomes 6, we come out of the loop and print all the values we have iterated so far. Let me run it and we'll see the result. There you go. So here our I value started from 1. We printed 1, 2, 3, 4, 5, and then our I value reached 6. Then we use the break statement to come out of the loop. Alright. Now you can also skip the execution of further statements in the for loop during that iteration using the continue statement in Python. So when a continue statement is executed, the for loop continues with the execution of the next element in the iterable. It does not complete all the statements in the for loop body. So again I'll give a comment, say continue. Okay, so I'll write for I in range, again from 1 to 10, give a colon. I'll say if my I value is equal to 6, then I'll say continue. Then we'll print I. Let me run it and we'll see the result. Okay, so if you notice this output, so we have printed values from 1 to 5, and when my I value became 6, we skipped printing 6 and we moved on to the next element in the iterable, which was 7. Then we printed 8 and 9. So this is how you can use the break and continue statements in Python. Alright. Now we'll see a program to display the total goals a player has scored. So here we are going to iterate over a dictionary. So I'll give a comment, program to display the total goals a player has scored. Alright. So first of all, I'll declare a variable saying player name, and let's say we have the player name as Carmelo. Alright. I'll declare a dictionary called goals, and within curly braces I'll have my first player name addition. Let's say addition has scored 14 goals. Then we have, let's say, Burnett. So Burnett is my key here, and then we'll have value in terms of goals, let's say 3, and then we have our third player, let's say Carmelo, and Carmelo has scored, let's say, 7 goals. Now I'm going to write my for loop. So I'll write for, my iterable name here is player, in my sequence name is goals, so I'll say goals I'm going to check if my player is equal to player name. I'll say print the goals scored by the player. So I'll pass my dictionary name and within square brackets I'll say player. Let's use the break statement and then I'll say else will print. My message would be no player with that name found. Let's run and see the result. Alright, so here what we did was initially I declared a variable called player name that had the value Carmelo, and since Carmelo was present inside my dictionary named goals, you can see here we have Carmelo who had scored 7 goals. So I iterated over my sequence goals and I checked if my iterator, that is player, is equal to the player name, which is Carmelo. Since this Carmelo is present inside my dictionary name, so we printed the goals that were scored by Carmelo, that is 7. Now let's say I change this player name to, we have, let's say, Messi. Now since Messi is not present inside my dictionary goals, if I run this, it will print no player with that name found. The reason being Messi is not present inside my dictionary called goals. Cool. Now we'll see 2 more examples. This time we are going to print the cube of numbers using for loop. Alright, so first of all I'll declare a list which will have a list of numbers, let's say 2, 5, 7, 4, 8 and let's say 6. Then I'll pass in a empty list, so I'll declare within empty square brackets. I'll say for I in my sequence name, that is num, I'm going to use my empty list cube and then followed by the append function, and inside the append function we'll have our cubes of the number. So I'll write I'll use the double asterisk operator and then I'll say 3. After that we are going to print my list name, that is cube. Let's run it. There you go. So you can see here, first we have the list of the numbers here and then we have printed the cubes of these numbers in a pattern. Let's say I bring this print statement here and I'll run it again. Now this is much more readable. You have 2 cube is 8, 5 cube is 125, 7 cube is 343, then 4 cube is 64, 8 cube is 512, 6 cube is 216. Alright, now coming to the last example in our demo section of this for loops in Python video, we'll write a program to print a pattern. I'll say pattern printing. Alright, so we are going to print a right angle triangle. For that I'm going to take my first variable called n, which is going to be a user input to enter the number of rows. So using the input function I am passing the message enter the number of rows. I'll say for I in range 0 till my user input n, give a colon. I'll use my inner for loop. This is going to be the number of columns, so I'll say for j in range 0, comma I plus 1, give a colon, and I'll print my star pattern, so I'm using asterisks, and I'll use my end parameter. I'll have my double quotations, and then we'll say print the pattern. So here what I'm doing is I'm taking the number of rows from the user and I'm iterating from 0 till n, which is my user input, and then we are assigning another for loop for the number of rows, so that ranges from 0 till I plus 1. Then I'm printing my star. Let's run it and see the output. Let's say I'll enter the number of rows as 6. If I hit enter, you can see here we have our right angle triangle printed here. So initially my I value is 0, so here my j value becomes from 0 till 1, so we have just one star printed. In the next iteration my I value becomes 1, so from 0 to 1 plus 1, that is 2, we have 2 stars printed. The next iteration my I value becomes 2, so 2 plus 1 is 3 again, so we have 3 columns here, so 3 stars printed, so on and so forth. Alright.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So what is a while loop in Python? A while loop specifies a condition or a block of code that is to be executed until the condition evaluates to false, or the loop is explicitly ended with a break statement. Moving on to the next slide. So here you can see the syntax of a while loop. So a while loop is defined using the while keyword, and then you have the expression followed by a colon. After that you have the statements inside the block. The statements are executed until the condition evaluates to false. Now on the right side you can see the flow chart to show all the steps to execute a while loop. So you can see here we have the test expression. If the test expression evaluates to true, then we execute the statements that are present inside the while block. But if the condition is false, we will exit out of the while loop. Now before I move on, I have a question for you. So here is a Python quiz question. I want you to tell me the output of the below code. So this is regarding a list. I have declared a list called alpha that has D, F and C as its elements. Then I'm saying alpha plus equal to Ka, which is again a string since it is within the single quotes. Then I'm printing the list. Now you need to tell me what is the right answer. You have 4 options here, A, B, C and D. The first option is D, F, C, Ka combined. Then we have Ka in the beginning of the list followed by DFC. The third option or the C option is DFC Ka, Ka being individual elements, and the last option, the D option, is Ka DFC. Please go ahead and solve this question and put your answers in the comment section of the video. We'll be more than happy to know from you. Alright, now let's go ahead and start with our demo. So here I am on my Jupyter Notebook. Let me rename my file. I'll say while loop in Python demo. Okay, so let me start by writing a simple while loop. I'll declare a variable called I equal to 0. Then I'll start with my while loop. I'll write my while keyword and this will run till my I is less than 10, let's say. I'll give a colon, and if I hit enter it will come to the next line. You can see the indentation here which is being maintained. I'll say I equal to I plus 1. So I am incrementing my I value Then I'll say print I, and I'll use my end parameter, and I'll say end within single quotes. I'll say hash and give a space. Then let me say print again. So here my while loop will run until my I value is less than 10. So we are continuously incrementing the I value and printing the I value. Let me run it. There you go. You can see the result here. We have printed the I values starting from 1 till 10, and after that we have come out of the loop. And you can see the hash symbol being used here because we used our end parameter as hash. So by default it is a new line character, but we have explicitly defined our end parameter as hash followed by a space. Cool. Now let's move on to our next example in this video on while loop. I'll define a variable called count and I'll assign a value 0. I'll say while my count is less than equal to 5, I'll give a colon, come to the next line, and I'll print the condition is true, and then I'll say count equal to count plus 1, and then I'll say print end of loop. Let's run and see our result. You can see here we have printed our message. The condition is true 5 times because our expression is being evaluated 5 times here. In the 6th time our count is no more less than equal to 5, so we end the loop, and here you can see the message end of loop. Cool. Now moving ahead, you can also use the break statement in a while loop. Let me show you how to do it. I'll say while true, so I am declaring my while loop to be true, and I'll say please type your name, and I'm going to take my name as input from the user, so I am specifying the input function. I'm going to check if my name is equal to let's say Gilly, then I should give a colon here. I'll break out of the loop and then will print thank you, you typed the correct name. Alright, so what I'm doing here is I'm going to run this loop till the user enters the correct name. So I have declared my name as Gilly. If you enter any other name apart from Gilly, this while loop will continue to run and execute. Let's run it. Okay, so here it says please enter your name. Let's say John. If I run it, it is again asking me please enter your name. Let's say this time I'll say Amy. You can see here it is again asking for the name, so I'll enter my name. Let's say Hopkins. Again our entered username doesn't match the name that we have provided in the code. Let's say this time I'll say Gilly. If I hit enter, you can see we have our message, thank you, you typed the correct name. Okay. Now moving on to the next example, we will see how to find the least common multiple of 4 and 7. So I'll give a comment as LCM of 4 and 7. Now you would know it is 28, but we are going to find out with the help of a Python while loop. So first I'll declare a variable x equal to 0. I'll say while my expression is true, I'm going to increment my x value to 1. I'll say x plus equal to 1. This means x equal to x plus 1. I'm going to use an if statement and say if not, and here we'll pass the condition x percentage 4 or modulo 4 or x percentage 7, then I'll say break. Finally, we'll print our message saying x, comma, and I'll say is divisible by 4 and 7. Say both 4 and 7. Okay, so what I am doing here is I am taking my expression while true, I'm incrementing the value of x each time and checking if this is true or not. Now at the first instance, when my number x is divisible by both 4 and 7, I am coming out of the loop and we are going to print this. Now let's see what's the answer. There you go. You can see here 28 is divisible by both 4 and 7, and hence the LCM of 4 and 7 is 28. So this is the least number which is divisible by 4 and 7. Alright. Now you can also use the continue statement. How you use the break statement to come out of the loop, you can also use the continue statement to continue running the loop. So I'll say I equal to 0 while I is less than 10. So this is my expression. My loop is going to run until I is less than 10. I'm going to increment the value of I. I'll say I plus equal to 1 if, let's say I set my condition if I equal to let's say 6, then I'll say continue my execution and skip the current step where I value becomes 6. Then I'll say print I. Let's run it and see the result. Okay, you can see here we have printed 1, 2, 3, 4, 5, and here you can see we have skipped the execution where I value became 6 and continued with the next iteration 7, 8, 9 and 10. So this is how you can use the continue statement and the break statement in a while loop. Alright. Now moving ahead, you can also use the else statement in a while loop. Now let me show you how to do it. I'll say I equal to 1, then I'll write while I is less than let's say 5. I'll say print I, then I'm going to increment the value to I plus equal to 1. Now here you can use the else statement and say print I is not less than 5. Let's run it. You can see here we ran our loop until I value was less than 5. So we printed 1, 2, 3 and 4. When I value became 5, we printed I value is not less than 5. Cool. Now moving ahead, so you can use inbuilt functions inside a while loop. Let me show you how to use the pop function and remove the elements in a list using a while loop. So I'll declare a list of numbers, let's say 1, 2, 3, 4 and we have 5. So these are the 5 elements that are present inside list A. I'll say while A, so I'm iterating over all the elements in my list. I'm going to say print A dot, I'll use the pop function. So what pop does is it is going to remove the elements from the end of a list. Then I'll say else print there are no elements left in the list. Alright, let's run it and see the result. You can see here we are removing the elements one by one from the end of the list. So first we popped out 5, then 4, 3, 2 and 1, and after that we had no more elements left in the list, so we printed there are no elements left in the list. Okay. Now the next program, we will take numbers as input from the user and calculate the average as long as the user enters a positive number. So I'll give a comment, average of positive numbers. Cool. Okay. So I'll start my program. I'll declare a variable called num, which has a value 0. I'll declare a variable called count, which also has a value 0. Then I have sum, which has a value of 0. I'll write while my number is greater than equal to 0. So this condition is for accepting only positive numbers. I'll say num equal to, I'm going to take the positive numbers from the user. So I'll pass an input function. I'll say enter any positive number. Then I'm going to say if my number is greater than 0, I'll say count equal to count plus 1. Let's make this greater than equal to 0. Then I'll say sum equal to sum plus my number. So here I am keeping track of the numbers that we have entered, and here we are calculating this sum, that is the cumulative sum. Then I'll say AVG, which is to find the average. I'll say sum divided by my variable, that is count. Then I'm going to print total. I'll say total sum of numbers, give a colon followed by a space, give a comma, I'll say sum, then I'll say average, give a colon followed by a space, and I'll pass in the variable AVG. Alright, so here I have my program ready, where we are using a while loop and an if statement to take numbers as input from the user and calculate the average as long as the user enters a positive number. So let me run it. Okay, it says enter a positive number. I'll say, let's say 5. Again it's asking for a positive number. I'll say 7. Let's say 10. And this time I'm going to enter a negative number, so I'll say minus 6. If I run it, you can see here the total sum of numbers 5 plus 7 plus 10 is 22, and the average is 22 divided by 3, which is 7.33. Alright, let me give a space here for more readability. We are going to try it again. I'll say 40, 50, 30 and let's say 100. This time I'll enter a negative number, let's say minus 90. Okay, so you can see here I have entered 4 positive numbers, 40, 50, 30 and 100. So the sum of numbers is 220 and the average is 40 plus 50 plus 30 plus 100, which is 220 divided by 4, which is 55. Cool. Now moving on to the last demo in this while loop with Python tutorial. So here we are going to guess a number. So the user is going to give a number between a certain range, and based on a random input generated from the program, we are going to guess the random number. Alright, so for that I'm going to start by importing my library called random. I'm going to say n equal to random dot randint, which is a function to generate random integers. I want to generate between 1 and 100. Let's go ahead and print that number n. Then I'll use a variable called guess, which is going to be a user input. So I'll say input, which is my function, and I'll give the message enter an integer between 1 to, let's say, 100. Okay. Then I'll start my while loop saying while n not equal to my variable, that is guess. I'll say if my guessed number is less than n, I'll print the message as your guess is, let's say, low. Then again I'll say guess equal to, I'll take the user input. I'll just copy this message and we'll print it here. Okay. Now I'll say elif if my guess is more than my random integer, will print, I'll just copy this, we are going to print your guess is, let's say, high. Then we are again going to ask the user to guess a number between 1 to 100, and after that I'll say else will print you guessed it correctly. Then we'll break out of the loop, and finally I'll just print it. Okay, so what we are doing in this game is, before that let me just give a comment as guessing game in Python. So first of all, we are generating a random integer using the library called random. So the integer will lie between 1 and 100. I am going to print that integer. After that I am taking a user input. So I'm asking the user to enter an integer between 1 to 100, and I'm checking if my random integer is not equal to my user input, that is guess, and if that guess is less than my random integer, I am going to print your guess is low. Then I'm again asking the user to input an integer between 1 to 100. Then I'm saying if the guessed value is more than the generated random integer, will print your guess is high. Then after that I'm again asking the user to input an integer, and in case the random integer matches with the guessed number, will print you guessed it correctly. Alright, let's try this out. Okay, so here you can see, so my program generated a random integer 48 that lies between 1 and 100. So our loop will only stop executing when we enter our number as 48. Otherwise it will keep on running and asking you to enter an integer. Let's say I enter 50. You see here, your guessed value, that is 50, is more than the random integer 48. So we have the message, your guess is high. Let's say I'll say 30. This time my guess is low, you can see it here. Let's say I'll take my number as 300. You see here, this time my guess is high, which is more than 48. But if I say my user input to be 48 and if I hit enter, there you go. We have our message printed. You guessed it correctly. Alright.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
What is a nested loop? Python programming language allows you to use one loop inside another loop. This is known as a nested loop. It is present inside the body of the outer loop. The inner or outer loop can be a for loop or a while loop. The outer for loop can contain a while loop, or an outer while loop can contain a for loop inside it. In Python nested loops, the outer loop can have more than one inner loop. There is no limitation on the chaining of loops. Now you can see on your screens the basic syntax of writing a nested loop in Python. You have the outer loop, followed by the inner loop and the statements inside the inner loop. And finally, you have the statements of the outer loop. The last three lines consist of the body of the outer loop. Now talking about the various ways of writing nested loops in Python. So with Python you can write a for loop inside another for loop, or you can have a while loop declared inside another while loop. You can see it here. So using Python you can use both for loops and while loops together. The outer loop can be a for loop and the inner loop can be a while loop. You can also write nested loops having a while loop outside and for loop inside. So now that you have learnt about the basics of nested loops, let's look at an example of printing patterns. So in the code here, we have used two for loops to get our right angle triangle containing asterisks or stars. So we have declared row equal to 7, which means we need 7 rows to be printed. You can count it here. These are 7 rows. Hence, we have defined it as row equal to 7. Now the outer for loop ensures we have a total of 7 rows. So we have defined a range from 1 to row plus 1, that is 8. Now the inner loop is the total number of columns in each row. So for each iteration of the outer loop, the columns count gets incremented by 1. So for the first iteration of the outer loop, the column count is 1. In the next iteration, it is 2, and so on. The inner loop iteration is equal to the count of the columns, and for each iteration in an inner loop we print a star. So for the first iteration, when I value is 0, it will first print a blank. When I value becomes 1, then your j range becomes 1, 1 plus 1, which is 2. So it will print 1 star here followed by a space. When I value becomes 2, your j range becomes 1, 3, so it will print 2 stars. Then again, when I value becomes 3, your range becomes 1, 4, so it will print 3 stars, so on and so forth. Now let's see when you should use a nested loop in Python. So nested loops are mostly used to work with multi-dimensional data structures, such as printing two-dimensional arrays, iterating a list that contains a nested list, etc. You can use Python nested loops to print different star or number patterns as well. Now let's head to our Jupyter Notebook to do some practical hands-on demonstrations to understand nested loops in Python better. Okay, you can see here I am on my Jupyter Notebook. First of all, I'll rename my notebook as nested loops in Python demo. Click on rename. Alright, now let's see our first example. So here we are going to print the items in a list one by one, but each letter in an item should be separated by the @ sign, which is basically the @ symbol that you use in your email IDs. Alright, and for the first demo we'll be using nested for loop. So let's start. I'll create a list which will have the names of the fruits. Let's say we have mango. I'll give a comma. Let's say I have apple, grapes, and let's say we have banana. Alright. Now I'll create my outer loop. So I'll say for fruit. Now this variable can be any valid Python variable. This is basically known as an iterator or an iterator variable. So I'll say for fruit in my list, which is list underscore fruits that I have declared in my first line. I'll give a colon and then declare my inner loop. I'll say for I in my variable or the iterator that I had declared in the previous line, which is fruit. I'll say print I, and then I'll use the end parameter that will have the @ sign, and then I'll print a blank. So this is my first nested loop that I have created. So I want to iterate through all the items present in my list underscore fruits variable, and for each item in the list I want to make sure that each letter in an item should be separated with the @ sign. So let me go ahead and print it so that you can see the result. There you go. So here you can see we have printed the different items that were present in my list, which was list underscore fruits, and for each item the letters in the item have been separated by the @ sign, you can see here. Alright, if you want you can change this symbol to, let's say, star. If I print it, you can see the difference in the result. Now we'll see our second example where we are going to print the values of items in two lists together. So let me create a list called color that will have the different colors such as red, we have green, and let's say blue. And the next list I'm going to create will have three items. The first item is apple, then we have veggies, and then we have shirt. Now to print the values of the items in these two lists together, I'm going to use two for loops again. So I'll say for my iterator variable, let's say x, in my first list, which is color. So I have declared my outer loop, and now I'll say for another iterator variable, let's say y, in my second list items, I'm going to print x comma y, and after that we'll print a space. So first of all, my outer for loop will iterate through the items that are present inside color list, and for each color we are going to iterate through the values that are present inside items list. Now let me go ahead and print it. You can see it here. First we are printing red apple, red veggies, and red shirt. Then we have green apple, green veggies, and green shirt. If I scroll down, you can see blue apple, blue veggies, and blue shirt. Okay. Now coming to our third example, here we are going to print a right angled triangle with 10 rows. We have seen a similar example in the slides where there were 7 rows. Now we are going to print a right angled triangle with 10 rows. I'll give a comment. Let's say print right triangle. Okay, so I'll start my for loop. I'll say for any iterative variable, let's say I, in range. I'll pass my range as 11, so it will go from 0 to 10. Then I'll say for j in range I, so this will take the number of columns. I'll say print within double quotes. I'll give my star because I want to print a star pattern for the triangle, and I'll end with a space. Then I'll say print blank, so there won't be any space between the different rows. Now let's print the result. There you go. So here you can see we have a right angle triangle of 10 rows. You can count the number of rows, and also we have the number of columns as 10. So when I value is 1, your J range also becomes 1, so we print 1 star. Then when I value is 2, we are going to print 2 stars. When I value is 3, we are going to print 3 stars, and we are using the end parameter as a space. Okay. Now let's go ahead and print a right angle triangle using a nested while loop. So unlike the for loop, the while loop doesn't have a precompiled iterable sequence. The while loop keeps executing the code until the expression evaluates to true. So I'll start with the variable I equal to 11 because I want to print 10 rows that will contain my star pattern. Now I'll declare my first while loop. I'll say while I is greater than 0. So my loop will continue until I is greater than 0. I'll say j equal to 11. Then I'll use my inner while loop. I'll say while j is greater than I will print star, and I'll use my end parameter as space again. Then we are going to decrement j by 1. I'll come out of the inner while loop and I'll say I equal to I minus 1. So we are also decrementing the first variable I by 1, and now I'll say print. Okay, so let me run this. You can see it here. We have the same pattern printed. Earlier we saw this using 2 for loops, and now we have created the same pattern using 2 while loops. Alright, now moving to our next example where we'll see how to append 2 lists. So first of all, I'm going to declare list 1 and list 2, and we are going to append the elements of both the list into an empty list called result. So I'll give a comment append 2 lists. Okay, so first I'll declare my list 1. Now these are list of numbers. Let's say I have 10, 25 and 30 as my elements in the first list, and then I'll declare my second list which will have, let's say, 60, 15 and 50. Okay, now I'll declare an empty list called result, and after that I'm going to start my outer for loop. I'll say for I in my list 1, then I'll say for j in list 2, I'll say result, which is my empty list that I have declared. Then I'm going to use the append function that is inbuilt in Python. I'll say I plus j. So this will make sure we'll append the values from both the list into my empty list, which is result. Then I'll say print result. Okay, let's run it. There you go. So what we are doing here is I'm adding each element in list 1 with all the elements in list 2. If you see here, 10 plus 60 is 70, then we have 10 plus 15, which is 25, 10 plus 50 is 60. Similarly, 25 plus 60 is 85, 25 plus 15 is 40, then 25 plus 50 is 75, and similarly for 30 plus 60, 30 plus 15, and 30 plus 50. Great. Now, moving to our next example, we are going to see how you can multiply the values in two lists. So I'll give a comment saying multiplying two lists. I'll declare my first list, which is list 1 with 2, 4 and let's say 6. Then I'll have my list 2 with the same elements 2, 4 and 6. Start my outer for loop for I in list 1. Then I'll say for j in list 2, I'm going to show you another feature that you can use while implementing nested lists, that is to use continue or break. So I'll say if I equal to j, then I'll continue. After that, we are going to print the value of I followed by the asterisk, then the value of j. I'll give a comma, then within single quotes I'll say equal to, then I'll give the operation I multiplied by j. So this is how you can multiply the elements in two lists. So I've declared my list 1, my list 2, then I'm using two for loops, and whenever my I value is equal to j, we'll skip that step and move on to the next iteration. Let me run it and show you the result. So if you notice here, I haven't multiplied 2 and 2. The reason being, I have used this if condition. Whenever I was equal to j, we continued with the next iteration. Similarly, there is no output for 4 multiplied by 4 or 6 multiplied by 6. But for the remaining, we have our result. 2 multiplied by 4 is 8. 2 multiplied by 6 is 12. Similarly, 4 multiplied by 2 is 8. 4 multiplied by 6 is 24. 6 multiplied by 2 is 12. And 6 multiplied by 4 is 24. So continue and break are two statements that you can use inside nested loops in Python. Okay. Now we are going to write another nested loop using a while loop and a for loop to check whether a number is a perfect number or not. So basically in this program we are going to print the perfect numbers between 1 and 100. Now a perfect number is a positive integer that is equal to the sum of its proper divisors. So the smallest perfect number is 6, which is the sum of 1, 2 and 3. So these are the perfect divisors of or proper divisors of 6, 1, 2 and 3. If you add them, the value is 6. Another example is 28. The proper divisors of 28 are 1, then you have 2, 4, 7 and 14. If you add them, the value is 28. So here we will iterate the first 100 numbers using a while loop. So for each iteration of the outer while loop, the inner for loop executes from 1 up to the current outer number to check if the current number is a perfect number or not. Okay, so I'll give a comment saying perfect number. Cool. So I'll first declare a variable called a, which will have a value of 1. Then I'll say while my a is less than equal to 100, then I'll declare another variable called y underscore sum, which will have the value of 0. After that, I'll pass in my inner loop, which is the for loop. I'll say for I in range 1 comma a, I'll say if a mod I is equal to 0, then we'll say y underscore sum equal to y underscore sum plus I. Then I'm going to say if my y underscore sum value is equal to my a value, then it's a perfect number. So I'm going to use a print statement saying print perfect number, give a colon, then I'll give a comma and print my variable a, and finally we are going to increment the value of a to 1. Now let's run it. You can see it here. Between 1 and 100 we have two perfect numbers, as I mentioned earlier, 6 and 28. Okay. Now coming to the final example in our demo on nested loops in Python, here we are going to print each element in the list 5 times. So I'll first declare my list, let's say fruits, which has apple, then we have orange, and let's say we have kiwi. So I'll say for an iterator fruit in fruits, I'll declare a variable called count and initialize it to 0. Then I'm going to use a while loop saying while count is less than 6, since I want to print the items in the list 5 times. Then I'll say print fruit, and I'll use my end parameter as a space. Then we are going to increment count by 1, and finally I'll print it. Let's run it. You can see it here. I printed each element in my list fruits 5 times. You can see it here. Okay, so I'm on my Jupyter Notebook. First of all, let's rename our notebook to looping techniques. Okay, I'll just increase the size. Alright. Okay, so let's see how you can arrange the values in a list using for loops with Python sorted function. So I'll create a variable called num, and I'll assign a list. Let's say it has values 2, 5, 10, 4. I'm taking just random values. Let's say 36, 50 and 49. So this is my list. Now I want to arrange the items in this list in either ascending or descending order. So for that I can use a for loop. I'll say for I, which is my iterator variable, in, and after this I'm going to use the Python sorted function, and inside the function I'll pass in my variable, which is num. Then I'll give a colon and say print I. So let's hit shift enter to run it. Okay, you can see here, so Python by default has sorted the elements in the list in ascending order. So we have 2, 4, 5, then 10, 36, 49, 50 and 50. Now let's learn how you can sort the values in a list using a for loop in descending order. So I'll just copy my above cell of code. We'll paste it here. It will help save us some time. So I'll say for I in sorted, I've given my variable num, After this, I'm going to pass in another parameter called reverse equal to, I'll say true. Now reverse equal to true will make sure Python will sort the list in descending order. If I run it, you can see the difference. We have sorted the elements in the list num in descending order now. So we have 50, 50, 49, 36, 10, 5, 4 and 2. Okay, so this is one of the techniques that you can use to sort the elements in a list using a for loop. Now similarly, you can also sort string elements alphabetically in a list in ascending or descending order. So for that, I'll create a variable called players. Let me just scroll down. Then I'll create a list which will have the names of football players. Let's say we have Messi. Then let's say we have Ronaldo. Then we have Salah. And then we have, let's say, Harry. Okay. I'm going to say for I in my function sorted, I'll say players, I'll give a comma, and again use reverse equal to true. So this is going to sort the items in my list players in descending order of the alphabets. Then I'll give a colon and say print I. Let me run it. You can see here the names of the different football players have been sorted in descending order of alphabets. So we have S appearing first, then R, M and H. So Salah, Ronaldo, Messi and Harry. Alright, now let's move ahead. Now we are going to create a dictionary of key value pairs and sort it. So I'll create a dictionary called D, which will have a few key value pairs. So my first key is F and the value is, let's say, 1. Then my second key, let's say, is B and the value is 4. I'll give a comma. My next key is A and the value is, let's say, 3. After that, my next key is E and the value is, let's say, 9. And finally we have our last key, which is C, and the value is 2. Now to sort this dictionary, I'll say for I in sorted, I'm going to use the items method. I'll say sorted d.items and then we'll print I. Let me run it and show you the result. You can see it here. Our dictionary has been sorted in ascending order of the dictionary keys. So we have A, B, then C. There is no D here. After that we have E and then F. Cool. Now you can also sort the keys and values separately. Let me just copy this and I'll show you. I'll paste it here, and instead of d.items, I'll just say d.keys. If I run it, you can see here we have sorted only the keys in my dictionary. Now to sort the values, instead of items, you can just write values, and here you can see we have sorted the values in the dictionary D in ascending order again. So we have 1, 2, 3, 4 and 9. Alright. Now we will understand how to use the reverse function in loops to reverse the items in a list. So I'll again create my list called players, which will have Messi. Let's say again the next player is Ronaldo, and then we have Salah, and then we have Harry. Okay. Now to reverse the elements in this list called players, I'll say for I in, then I'll use the reversed function and pass in my list called players, give a colon and then say print I. Let's run it. Here you can see we have reversed the elements in my list called players. So we have Harry first, then Salah, Ronaldo and Messi in the end. Cool. Now moving ahead, we'll see how to use the filter function in a loop and filter specific elements in a list based on some conditions. Now to give the condition, we'll be using an anonymous function in Python that is often called as the lambda function. To do this, I'm going to create a list called animals. I'll give my square brackets, and inside these square brackets I'm going to pass in the elements in the form of a dictionary. So to pass in a dictionary, we need to have key value pairs. So my first key is name. Let's say my animal is dogs. I'll give a comma. Then my next key is the age. Let's say dog's age is 11. So this is my first list element which has been passed in the form of a dictionary. I'll create another curly bracket and we'll have the same keys. This time let's say my animal is lion. Let's make it dog instead of dogs. Okay. I'll give a comma and then say age. Let's say the age of the lion is 30. I'll give a comma. We'll go to the next line and this time we are going to have another animal. I'll say elephant. Give a comma. Let's say the age is 63. I'll give a comma. And then we'll have our final element in the list. Let's say the name of the animal is leopard. Give a comma. Then we'll have the age of the leopard. Let's say the age is 18. So we have our list ready. Now using a for loop, we'll filter the elements in the list giving a specific condition. Let me show you. So I'll write for animals in. I'm going to use the filter function, and inside the filter function I'll give an anonymous function called lambda. I'll say lambda I colon I of age if it is divisible by 2. So I'll say age divided by 2 equal to 0. Give a comma. Then we will print that animal. I'll give a colon. I'll say print animals. So what I'm doing here is I'm using the filter function and passing my condition, that is, if the age of the animal is divisible by 2, then print the animal, or just print the list. Rest we don't need. Alright, now let me run it. It says there is an invalid syntax. Let me debug it. Okay, there is a spelling mistake here in lambda. This should be MBDA. Okay, now we'll run it. There you go. So here in the list that we had created, only the age of lion and leopard were divisible by 2. So 30 and 18 were divisible by 2. So Python printed us only those two elements in the list. The rest it ignored. 11 and 63 are not divisible by 2, so we did not get dog and elephant. Cool. So this is another interesting looping technique where you can use filter as well as an anonymous lambda function. Alright. Now in the next example, we'll see how to remove items in a list using a while loop. So far we have been using only for loops. Now we are going to see a few examples using while loop. Okay. I'm going to create a variable called country. So this variable will hold a list of elements of the different country names. I'll say India. Let's say my second country is Canada, and let's say my third country I have is Brazil. My fourth country I have is Japan, and then we have, let's say, Israel. Okay. Now I'll use a while loop. So I'll say while my list, that is country, then to remove the elements in the list I'm going to use the pop function. So I'll say print country dot, I'll say pop, and I'll pass -1 as the parameter so that it removes the elements from the end of the list. If I run it, you can see here we have Israel, Japan, Brazil, Canada, and India. Now you can just print country. You can see here, since we have removed all the elements from my list country, there is no element left here, so it gives us an empty list. Cool. Now let me show you how you can use while loops in just one line. So for that, I'll create a variable called num, and I'll assign a value of 10. I'll say while num is greater than 0, I'll say num equal to num -1. I'll give a semicolon this time, and then I'll say print num. Let's run it. You can see it here. We have printed 9, 8, 7, 6 up to 0. So in the first iteration, my num value was 10. So 10 greater than 0 was true. So we decreased the value of num by 1. So num became 9 and we printed 9. In the second iteration, num, which was 9, was greater than 0. Then we decreased or reduced num by 1 again. So it became 8. Then we printed 8. And the loop continued till we reached 0. Cool. Now had this condition been num equal to num plus 1 or num plus equal to 1, the loop would have run for infinite number of times. Alright. Now I'll show you an example how to run an infinite loop. So I'll say while true, I'll create a variable called num. Now this num would be a user input, a user integer input actually. I'll pass in the message as enter an integer, give a colon followed by a space, and then we'll say print the product of, I'll give a comma, say num, I'll give another comma, I'll say is. Now we'll pass in our multiplication. I want to multiply any user given number by 5. So I'll say 5 multiplied by num. Okay, let's run it. And see here, enter an integer. If I say, let's say 3, so 3 multiplied by 5 is 15, the product of 3. Here I can change the message as multiplied by 5. You can say is. Okay, now let's run it. Okay, so let's say I enter my integer as 3. I have the message the product of 3 multiplied by 5 is 15. Let's enter another value 10. The product is 50. Let's say I have 20. The product is 100. Let's say I am taking 35 multiplied by 5 is 175. So this loop will continue until and unless you don't interrupt it. So I'm going to interrupt my kernel. to stop executing this loop. Okay, now we are going to explore the enumerate function in Python, but before that let me tell you what enumerate function is. So the enumerate method or the function in Python allows us to number list indices of the items as they are coming out of the array. Python will automatically put this indices into a tuple. Let me show you how it works. So I'll directly start with my for loop. I'll say for I in, I'll use the enumerate keyword, and within brackets I'll pass in my elements in the form of list. I'll say the, let's say, then we have brown. The next word I have is for, let's say, then we have jumped. This is basically a sentence broken down into different words, and those words we have put as elements in the list. The next word I have is the, give a comma, I'll say lazy. Then we have dog, give a comma, and finally we'll have our full stop or the period. Okay, then I'll give a colon and I'll say print I. Now let me run it. You can see here using the enumerate function we have given the indices to the different items in my list. So it starts from 0 and goes till 8. So there are total 9 elements in my list. Okay. Now you can see here the result has been printed in the form of a tuple or tuple. I'll just copy the above code and paste it here. Now I'm going to replace I with key and value, and print also I'll say key comma value. Let me show you the result. You can see here this time it is no more a tuple, and here we have the indices and then we have the items. So basically these indices have now become the keys and the items are the values. Okay. Now you can print the different elements in the form of a sentence. Let me show you how to do it. I'll just paste it here, and instead of key I'll say value, and I'll use the end parameter in the print statement. I'll say end equal to, I'll give a space. Let's run it. You can see here, okay, this should be brown fox and not for. Let's run it again. So we have the sentence, the brown fox jumped over the lazy dog. Okay. So similarly you can iterate through the letters in a word or a string and print the letters along with the indices. I'll declare a variable called company, and this will have a value, let's say Simplilearn. I'll say for I comma j in, I'll use the enumerate function. Within brackets I'll say company, give a colon, then I'll say print I comma j. Let's see the result. There you go. So here we have indices assigned to the different letters in my word Simplilearn. Okay. Now moving ahead. So by default the index position starts at 0 as I told you. Now you can also mention the starting index position using the start parameter. So what I'll do is I'll copy my above code, I'll paste it here. Now we are going to make some changes. I'll say for I in enumerate company, and then I'm going to give my start parameter. Let's say I want to start the index position at 10. Now if I print it, Okay, let's say print I. There you go. Here you can see my first letter starts at index 10, then we have 11, M at 12, P at 13, and finally we have the last letter, which is N in Simplilearn, is at the 20th index. Cool. Okay, so now let's explore the zip function in Python and how you can use it to loop it through two arrays at once. So the zip function returns a zip object, which is an iterator of tuples where the first item in each past iterator is paired together, and then the second item in each past iterator is paired together, and so on and so forth. So if the past iterators have different lengths, the iterator with the least items decides the length of the new iterator. Let me show you the first example that will help you understand how the zip function works. So I have a list called first, and I have names of few football players. We have Lionel, then we have Cristiano, give a comma, and let's say we have Mohammed. I'll declare another list called last, which will have values like Messi, then we have Ronaldo, basically the surnames of Lionel, Cristiano and Mohammed, then we have Salah. I'll write my for loop. I'll say for I in my zip function or the method. I'll pass in first comma last, which are my list names. I'll say print I. Let me run it. You can see here, using the zip function, we have iterated through both the lists. So we have Lionel Messi, Cristiano Ronaldo, and then Mohamed Salah. Alright. Now you can combine the elements of three lists as well. So I'll just paste the code here and we'll create another list called num, and this is going to be a list of numbers, let's say 7 and 8. Okay, now here I'll say for I in zip first, last and num print I. If I run it, you see the result here. It has zipped only the first three items in the list first, last and num. So we have three items printed. Okay. Now coming to the final section of this demo on looping techniques in Python, we'll explore about zip underscore longest. So Python's iterator tool or iter tool is a module that provides various functions that work on iterators to produce complex iterators. So iterators in Python is an object that can iterate through sequence data types such as list, tuple, string and so on. So the zip underscore longest iterator falls under terminating iterators. It prints the values of the iterables alternatively in sequence. If one of the iterables is printed fully, the remaining values are filled with the values assigned in the fill value parameter. So to use this function called zip underscore longest, we need to import zip longest from the iter tools module. So I'll say from iter tools import zip underscore longest. Okay, then I'll create my first list. I'll say, let me go to the top and copy the elements because we are going to use these same elements again. I'll paste it here. Okay, and let's say I'll give a comma, and we are going to, and I'm again going to use the three elements. Okay, now I'll create another list called last, and we are going to copy the items from the top, paste it here, and now I'll say for, let me just scroll down, I in zip underscore longest, within brackets I'll say first comma last. We're going to print I. Let me run it and show you the result. This should be zip underscore longest. Okay, you can see the result here. For the first 3 items, it has printed Lionel Messi, Cristiano Ronaldo and Mohamed Salah, which you can see here. But for the last 3 items in the first list, it has given us none, none and none because there were no values. Now to overcome this problem, you can use a parameter called fill value. Let me just copy this and I'll paste it here. And the only change that I'm going to do here is I'm going to say, I'll give a comma, I'll use the parameter called fill value equal to, I'll say NA. If I run it, you can see here for the last 3, now we have whatever we have defined within fill value parameter. You can change this to, let's say, not defined. There you go. Alright, so these were some of the interesting examples that we implemented using looping techniques in Python. This is going to be a completely hands-on demo video and we'll be using the Jupyter Notebook to work on the examples. So let's head over to our Jupyter Notebook and begin. Okay, so I'm on my Jupyter Notebook. First of all, let's rename our notebook to looping techniques. Okay, I'll just increase the size. Alright. Okay, so let's see how you can arrange the values in a list using for loops with Python sorted function. So I'll create a variable called num and I'll assign a list. Let's say it has values 2, 5, 10, 4. I'm taking just random values. Let's say 36, 50 and 49. So this is my list. Now I want to arrange the items in this list in either ascending or descending order. So for that I can use a for loop. I'll say for I, which is my iterator variable, in, and after this I'm going to use the Python sorted function, and inside the function I'll pass in my variable which is num. Then I'll give a colon and say print I. So let's hit shift enter to run it. Okay, you can see here, so Python by default has sorted the elements in the list in ascending order. So we have 2, 4, 5, then 10, 36, 49, 50 and 50. Now let's learn how you can sort the values in a list using a for loop in descending order. So I'll just copy my above cell of code. We'll paste it here. It will help save us some time. So I'll say for I in sorted, I've given my variable num. After this, I'm going to pass in another parameter called reverse equal to, I'll say true. Now reverse equal to true will make sure Python will sort the list in descending order. If I run it, you can see the difference. We have sorted the elements in the list num in descending order now. So we have 50, 50, 49, 36, 10, 5, 4 and 2. Okay, so this is one of the techniques that you can use to sort the elements in a list using a for loop. Now similarly, you can also sort string elements alphabetically in a list in ascending or descending order. So for that, I'll create a variable called players. Let me just scroll down. Then I'll create a list which will have the names of football players. Let's say we have Messi. Then let's say we have Ronaldo. Then we have Salah. And then we have, let's say, Harry. Okay. I'm going to say for I in my function sorted, I'll say players, I'll give a comma, and again use reverse equal to true. So this is going to sort the items in my list players in descending order of the alphabets. Then I'll give a colon and say print I. Let me run it. You can see here the names of the different football players have been sorted in descending order of alphabets. So we have S appearing first, then R, M and H. So Salah, Ronaldo, Messi and Harry. Alright, now let's move ahead. Now we are going to create a dictionary of key value pairs and sort it. So I'll create a dictionary called D, which will have a few key value pairs. So my first key is F and the value is, let's say, 1. Then my second key, let's say, is B and the value is 4. I'll give a comma. My next key is A and the value is, let's say, 3. After that, my next key is E and the value is, let's say, 9. And finally we have our last key, which is C, and the value is 2. Now to sort this dictionary, I'll say for I in sorted, I'm going to use the items method. I'll say sorted d.items and then we'll print I. Let me run it and show you the result. You can see it here. Our dictionary has been sorted in ascending order of the dictionary keys. So we have A, B, then C. There is no D here. After that we have E and then F. Cool. Now you can also sort the keys and values separately. Let me just copy this and I'll show you. I'll paste it here, and instead of d.items, I'll just say d.keys. If I run it, you can see here we have sorted only the keys in my dictionary. Now to sort the values, instead of items, you can just write values, and here you can see we have sorted the values in the dictionary D in ascending order again. So we have 1, 2, 3, 4 and 9. Alright. Now we will understand how to use the reverse function in loops to reverse the items in a list. So I'll again create my list called players, which will have Messi. Let's say again the next player is Ronaldo, and then we have Salah, and then we have Harry. Okay. Now to reverse the elements in this list called players, I'll say for I in, then I'll use the reversed function and pass in my list called players, give a colon and then say print I. Let's run it. Here you can see we have reversed the elements in my list called players. So we have Harry first, then Salah, Ronaldo and Messi in the end. Cool. Now moving ahead, we'll see how to use the filter function in loop and filter specific elements in a list based on some conditions. Now to give the condition, we'll be using an anonymous function in Python that is often called as the lambda function. To do this, I'm going to create a list called animals. I'll give my square brackets, and inside these square brackets I'm going to pass in the elements in the form of a dictionary. So to pass in a dictionary, we need to have key value pairs. So my first key is name. Let's say my animal is dogs. I'll give a comma. Then my next key is the age. Let's say dog's age is 11. So this is my first list element which has been passed in the form of a dictionary. I'll create another curly bracket and we'll have the same keys. This time let's say my animal is lion. Let's make it dog instead of dogs. Okay, give a comma and then say age. Let's say the age of the lion is 30. I'll give a comma. We'll go to the next line and this time we are going to have another animal. I'll say elephant. Give a comma. Let's say the age is 63. I'll give a comma. And then we'll have our final element in the list. Let's say the name of the animal is leopard. Give a comma. Then we'll have the age of the leopard. Let's say the age is 18. So we have our list ready. Now using a for loop, we'll filter the elements in the list giving a specific condition. Let me show you. So I'll write for animals in. I'm going to use the filter function, and inside the filter function I'll give an anonymous function called lambda. I'll say lambda I colon I of age. If it is divisible by 2, so I'll say age divided by 2 equal to 0. Give a comma, then we will print that animal. I'll give a colon. I'll say print animals. So what I'm doing here is I'm using the filter function and passing my condition, that is, if the age of the animal is divisible by 2, then print the animal, or just print the list. Rest we don't need. Alright, now let me run it. It says there is an invalid syntax. Let me debug it. Okay, there is a spelling mistake here in lambda. This should be MBDA. Okay, now we'll run it. There you go. So here in the list that we had created, only the age of lion and leopard were divisible by 2. So 30 and 18 were divisible by 2. So Python printed us only those two elements in the list. The rest it ignored. 11 and 63 are not divisible by 2, so we did not get dog and elephant. Cool. So this is another interesting looping technique where you can use filter as well as an anonymous lambda function. Alright. Now in the next example, we'll see how to remove items in a list using a while loop. So far we have been using only for loops. Now we are going to see a few examples using while loop. Okay. I'm going to create a variable called country. So this variable will hold a list of elements of the different country names. I'll say India. Let's say my second country is Canada, and let's say my third country I have is Brazil. My fourth country I have is Japan, and then we have, let's say, Israel. Okay. Now I'll use a while loop. So I'll say while my list, that is country, then to remove the elements in the list I'm going to use the pop function. So I'll say print country dot, I'll say pop, and I'll pass -1 as the parameter so that it removes the elements from the end of the list. If I run it, you can see here we have Israel, Japan, Brazil, Canada and India. Now you can just print country. You can see here since we have removed all the elements from my list country, there is no element left here, so it gives us an empty list. Cool. Now let me show you how you can use while loops in just one line. So for that, I'll create a variable called num and I'll assign a value of 10. I'll say while num is greater than 0, I'll say num equal to num minus 1. I'll give a semicolon this time, and then I'll say print num. Let's run it. You can see it here. We have printed 9, 8, 7, 6 up to 0. So in the first iteration, my num value was 10. So 10 greater than 0 was true. So we decreased the value of num by 1. So num became 9 and we printed 9. In the second iteration, num, which was 9, was greater than 0. Then we decreased or reduced num by 1 again. So it became 8. Then we printed it and the loop continued till we reached 0. Cool. Now had this condition been num equal to num plus 1 or num plus equal to 1, the loop would have run for infinite number of times. Alright. Now I'll show you an example how to run an infinite loop. So I'll say while true, I'll create a variable called num. Now this num would be a user input, a user integer input actually. I'll pass in the message as enter an integer, give a colon followed by a space, and then we'll say print the product of, I'll give a comma, say num, I'll give another comma, I'll say is. Now we'll pass in our multiplication. I want to multiply any user given number by 5. So I'll say 5 multiplied by num. Okay, let's run it. And see here, enter an integer. If I say, let's say 3, so 3 multiplied by 5 is 15, the product of 3. Here I can change the message as multiplied by 5. You can say is. Okay, now let's run it. Okay, so let's say I enter my integer as 3. I have the message, the product of 3 multiplied by 5 is 15. Let's enter another value, 10. The product is 50. Let's say I have 20. The product is 100. Let's say I am taking 35 multiplied by 5 is 175. So this loop will continue until and unless you don't interrupt it. So I'm going to interrupt my kernel to stop executing this loop. Okay, now we are going to explore the enumerate function in Python. But before that, let me tell you what enumerate function is. So the enumerate method or the function in Python allows us to number list indices of the items as they are coming out of the array. Python will automatically put this indices into a tuple. Let me show you how it works. So I'll directly start with my for loop. I'll say for I in, I'll use the enumerate keyword, and within brackets I'll pass in my elements in the form of list. I'll say the, let's say, then we have brown. The next word I have is for. Let's say, then we have jumped. This is basically a sentence broken down into different words, and those words we have put as elements in the list. The next word I have is the, give a comma, I'll say lazy. Then we have dog, give a comma, and finally we'll have our full stop or the period. Okay, then I'll give a colon and I'll say print I. Now let me run it. You can see here using the enumerate function we have given the indices to the different items in my list. So it starts from 0 and goes till 8. So there are total 9 elements in my list. Okay. Now you can see here the result has been printed in the form of a tuple or tuple. I'll just copy the above code and paste it here. Now I'm going to replace I with key and value, and print also I'll say key comma value. Let me show you the result. You can see here this time it is no more a tuple, and here we have the indices and then we have the items. So basically these indices have now become the keys and the items are the values. Okay. Now you can print the different elements in the form of a sentence. Let me show you how to do it. I'll just paste it here, and instead of key I'll say value, and I'll use the end parameter in the print statement. I'll say end equal to, I'll give a space. Let's run it. You can see here, okay, this should be brown fox and not for. Let's run it again. So we have the sentence, the brown fox jumped over the lazy dog. Okay. So similarly you can iterate through the letters in a word or a string and print the letters along with the indices. I'll declare a variable called company, and this will have a value, let's say Simplilearn. I'll say for I comma j in, I'll use the enumerate function. Within brackets I'll say company, give a colon, then I'll say print I comma j. Let's see the result. There you go. So here we have indices assigned to the different letters in my word Simplilearn. Okay. Now moving ahead. So by default the index position starts at 0, as I told you. Now you can also mention the starting index position using the start parameter. So what I'll do is I'll copy my above code, I'll paste it here. Now we are going to make some changes. I'll say for I in enumerate company, and then I'm going to give my start parameter. Let's say I want to start the index position at 10. Now if I print it, okay, let's say print I. There you go. Here you can see my first letter starts at index 10, then we have 11, M at 12, P at 13, and finally we have the last letter, which is N in Simplilearn, is at the 20th index. Cool. Okay. So now let's explore the zip function in Python and how you can use it to loop it through two arrays at once. So the zip function returns a zip object, which is an iterator of tuples where the first item in each past iterator is paired together, and then the second item in each past iterator is paired together, and so on and so forth. So if the past iterators have different lengths, the iterator with the least items decides the length of the new iterator. Let me show you the first example that will help you understand how the zip function works. So I have a list called first, and I have a names of few football players. We have Lionel, then we have Cristiano, give a comma, and let's say we have Mohammed. I'll declare another list called last, which will have values like Messi. Then we have Ronaldo, basically the surnames of Lionel, Cristiano and Mohammed. Then we have Salah. I'll write my for loop. I'll say for I in my zip function or the method. I'll pass in first comma last, which are my list names. I'll say print I. Let me run it. You can see here, using the zip function, we have iterated through both the lists. So we have Lionel Messi, Cristiano Ronaldo and then Mohamed Salah. Alright. Now you can combine the elements of 3 lists as well. So I'll just paste the code here and we'll create another list called num, and this is going to be a list of numbers. Let's say 7 and 8. Okay. Now here I'll say for I in zip first, last and num print I. If I run it, you see the result here. It has zipped only the first 3 items in the list first, last and num. So we have 3 items printed. Okay. Now coming to the final section of this demo on looping techniques in Python, we'll explore about zip underscore longest. So Python's iterator tool or iter tool is a module that provides various functions that work on iterators to produce complex iterators. So iterators in Python is an object that can iterate through sequence data types such as list, tuple, string and so on. So the zip underscore longest iterator falls under terminating iterators. It prints the values of the iterables alternatively in sequence. If one of the iterables is printed fully, the remaining values are filled with the values assigned in the fill value parameter. So to use this function called zip underscore longest, we need to import zip longest from the iter tools module. So I'll say from iter tools import zip underscore longest. Okay. Then I'll create my first list. I'll say, let me go to the top and copy the elements because we are going to use these same elements again. I'll paste it here. Okay. And let's say I'll give a comma and we are going to, and I'm again going to use the 3 elements. Okay. Now I'll create another list called last and we're going to copy the items from the top, paste it here, and now I'll say for, let me just scroll down, I in zip underscore longest, within brackets I'll say first comma last. We're going to print I. Let me run it and show you the result. This should be zip underscore longest. Okay, you can see the result here. For the first 3 items, it has printed Lionel Messi, Cristiano Ronaldo and Mohamed Salah, which you can see here. But for the last 3 items in the first list, it has given us none, none and none because there were no values. Now to overcome this problem, you can use a parameter called fill value. Let me just copy this and I'll paste it here. And the only change that I'm going to do here is I'm going to say, I'll give a comma, I'll use the parameter called fill value equal to, I'll say NA. If I run it, you can see here For the last three, now we have whatever we have defined within field value parameter. You can change this to, let's say, not defined. There you go. Alright, so these were some of the interesting examples that we implemented using looping techniques in Python. We're going to learn what is a control statement and then understand the different types of control statements in Python. So we have continuous statement, break statement, and pass statement. We're going to understand these in detail with hands-on demonstrations in Python on the Jupyter Notebook. So what is a control statement? Python programming language provides loop control statements that can be used to change the flow of execution and execute a statement or group of statements multiple times. In certain circumstances, when some particular conditions occur, we may want to exit from a loop or skip some statements of the loop before continuing further in the loop. So to achieve this, we need the help of control statements in Python. Now Python provides three types of control statements. First is continue, then we have break, and then we have pass. So let's look at them one by one in detail. So the continue statement skips the execution of the remaining statements in the loop and proceeds with the next iteration in the loop. That is, it forces the loop for the next iteration, ignoring the subsequent instructions. Now on the right you can see the flow chart of continue statement in Python. So on the top we have the test expression. Now if the test expression evaluates to false, we just exit out of the loop. But if the test expression is true, then we head to our continue statement. Now if this is yes or true, we again check the test expression. If it is false or no, then we execute the statements after the continue statement. Now we'll understand how the continue statement works with the help of examples in our demo session. So let's see the next statement that we have, which is the break statement. Now in Python, the break statement is used to terminate the loop. Whenever the Python interpreter or the compiler comes across the break statement, it jumps out of the loop. So it skips the remaining code without further testing the test expression of that loop. Now here on the right you can see the flow chart, how the break statement works in Python. On the top we have the test expression. Now if the test expression evaluates to false, we exit the loop. But if it is true, then we execute the break statement. If it is yes, then we just exit the loop. But if it is no, then we execute the remaining statements after the break statement. Now moving to the final control statement that we have in Python, which is the pass statement. So the pass statement in Python is used as a placeholder for future implementation of functions, loops, etc. When the pass statement is executed, nothing happens actually, but you avoid getting an error when an empty code is not allowed. It is also known as a null statement. Now let's directly jump to our Jupyter Notebook, where we'll explore break, continue, and pass statements in Python in detail. Okay, so here I am on my Jupyter Notebook. Let me first go ahead and rename my notebook to control statements in Python. I'll click on rename. Okay, now let's see how the continue statement works in Python. For that, I'm going to print all the letters except the letter I in the string Simplilearn. So I'll give a comment as continue statement. Okay, so I'll first write my for loop. I'll say for letters in my string, that is Simplilearn, give a colon, and then I'll say if letters is equal to let's say I, then I'm going to use the continue statement. After that, I'm going to say print letter, you give a colon, give a comma, and then we are going to print the individual letters in the string that is Simplilearn. So here letters is actually the iterator variable. It could be any valid Python variable. Finally, I'm going to say print end of execution. So here what I am doing is I want to print all the letters except the letter I in my string Simplilearn. So whenever the I occurs in my string Simplilearn, we'll use the continue keyword and then move on to the next letter in the string Simplilearn. If I hit shift enter, you can see the result. There you go. Here you can see we have S and the next word was I, so we skipped that iteration and then we continued with the next iteration. So we have M, P, L, and again here we had another I present in the string, so we skipped this iteration as well and moved on with the next. So L, E, A, R and N. Finally we have printed end of execution. So this is how the continue statement works. You can use it in a for loop or you can use it in a while loop as well. Now let's see another example where we are going to display only odd numbers present in a list of numbers. So I'll say for num, which is my iterator variable, I'll say for num in my list which has a few numbers, let's say 10, 7, I have 17, let's say 42, 33, 19 and let's say 60. Okay, so for num in my list, which is this one, I'll say if num mod 2 is equal to 0. So if the remainder is 0, I'll say continue. And then we are going to print num. So what we are doing here is for each number or each item in my list which has a list of numbers, I'm going to check if that number is divisible by 2 or not. If it is divisible by 2, we are going to skip that iteration and we are going to move ahead with the next number. So let's run it. Okay, here you can see we have printed or displayed all the odd numbers that were present in my list, which is this one. So this was another simple example of using a continue statement in Python. Now let's move on to the next control statement, which is break. Again, we are going to look at a few examples here. Alright. Now the first example we are going to see is how to break the execution when the number 5 comes up in the tuple. So for that we are going to use a while loop now. So first of all, let me declare a tuple which has, let's say 1, 2, 3, 4, 5, 6, 7 and 8. So numbers from 1 till 8. I'm going to say count equal to 0 and then I'm going to use a while loop. I'll say while my count is less than 9. Then I'm going to write my print statement, print my tuple which is num, and using square brackets I'll say count. Now we're going to increment count by 1, so I'll say count equal to count plus 1. Next we will check if the value of count is equal to 5. I'll give a colon and then we are going to break out of the loop. Finally we'll print end of execution. Okay, so this code will help break the execution when the number 5 comes up in the tuple which is num. So let's run it. Okay, so here you can see as soon as the number 5 occurred in the tuple, we broke out of the loop and the break statement terminated the execution of the loop. So you can see here we did not print 6, 7 and 8, and finally we printed our last statement which was present after the break statement, that is end of execution. Okay, So I hope this helped you understand how the break statement works in Python. We're also going to see another example now. So this is using a for loop. So we are going to break and terminate the execution when the letter P occurs in the string Simplilearn. So earlier we had seen one example, which was our first example, where we saw how to use continuous statement for the same string Simplilearn. This time we are going to use the break statement to terminate the execution when the letter P occurs in the string Simplilearn. So I'll start with a for loop. I'll say for letters in my string, which is Simplilearn. I'll give a colon, and then I'll say print my message, that is letter, give another colon, I'll give a comma, and I'll put my iterator variable, which is letters. Then I'll say if letters equal to P, I'll give a colon, and then I want to break out of the loop. Now let me just print it. You can see here, as soon as the letter P occurred in the iteration, we came out of the loop. So the break statement executed the above lines of code, and the moment it saw the letter P, it just terminated the loop, and hence you can see we did not print the remaining letters in the string Simplilearn. Okay. Now moving to our final section of the demo, where we'll see how to use pass statements in Python. So the first example we are going to see under pass statement is to check if the number is odd. So if the number is odd, we are going to pass it, else we are going to print only the even numbers. Okay. So for that I'm going to use a for loop, but before that let me just give a comment. I'll say pass statement. Okay. So in the first example, we'll check if the number is odd, then we are going to pass it and only print the even numbers. So for that I'm going to use a for loop. I'll say for number in range, let's say I'm taking the range between 10 and 25, give a colon. I'll say if number mod 2, if it is not equal to 0, give a colon, then we are going to pass it. So this means if the number is odd, then just pass it, else I'll say print the number is, we'll give a colon, a comma, and then I'll pass in my iterator variable, which is number. Now let's run it. Okay, you can see here in the range 10 and 25 we have excluded all the odd numbers because we used the pass statement. So it passed printing all the odd numbers and it just printed whatever was there in the else part, that is the even numbers. So we have 10, 12, 14, then we have 20, 22 and 24. So these are all the even numbers that lie between 10 and 25. Alright, now coming to the final demo. So here I'm going to write a user defined function to print any number other than 10. So again we are going to use a pass statement for this. So let me write my user defined function. I'll use the def keyword and my function name, let's say print underscore num. Then I'll pass in my parameter, let's say number. I'll say if number is 10, then I'll use the pass statement. Otherwise I'll say else print the number is, I'll give a comma, and then I'll say number which is there in my parameter. Now let's run it. Now we are going to call the function using the function name, which is print num. If I say print num 20, it will print my number saying the number is 20. Let's copy this. I'll paste it here. Let's say I'll say 25,000. It's going to print 25,000. But if I say print num 10, you can see it here that Python has just passed it, because we had given in our condition if number is 10 then just pass it. So there was no output for 10. Alright, so that brings us to the end of this demo session on control statements in Python. So we looked at how the continue statement works, then we saw how the break statement works. We looked at two examples. One was with while loops and the other one was with for loop. And finally we saw two examples on pass statements. One was using for and if else, and the other one was using a user defined function, and inside that we used the if else condition. Conditional statements in Python perform specific operations and take actions depending on whether a specific Boolean constant evaluates to true or false. Conditional statements are handled by blocks of if statements in Python. Now, conditional statements are also known as decision-making statements. So Python provides different types of conditional statements that you can use to make decisions. We have the simple if statement, then we have if else statement, elif statement, the nested if statement, as well as nested if else statement. We will learn them one by one with the help of their syntax and code examples. So this is how the syntax of if statement looks like. So you pass in the if condition and then we have a set of statements inside the if condition. So on the right side you can see the flow diagram, how the if statement gets evaluated. So first we have the test expression, that is the if condition. Now if this expression evaluates to true, then we go inside the body of the if statement. So this is basically the body of the if statement that contains a list of statements or blocks of statements. Now if the test expression evaluates to false, we execute the statements that are present after the if condition. Alright, now let me take you to my Jupyter Notebook where we'll understand if statement with an example. Okay, so here I am on my Jupyter Notebook. I'll just rename this to conditional statements. I'll see it as demo and we'll rename it. Okay, I'll just expand the screen size. Alright, okay, so first of all let's write a simple if statement. I have given a comment here. Suppose we have a variable called grade and the value of grade is 80. Then I'll write my if statement as if grade is greater than equal to 50, then I'll give a colon, then I'll write a print statement, print passed in the exam. Now this is how you write a simple if statement. So you have the if keyword followed by the condition. So here my condition is I'm checking whether the grade is greater than equal to 50. Now here I have already defined my grade to 80. So this if statement or the if condition will check whether 80 is greater than equal to 50. Now this is true. Then my print statement gets executed. Let me run it and show you the result. There you go. Here you can see we have our printed message as passed in the exam because 80 is greater than equal to 50. Now what if I change this to, let's say, 30? If I run this, there is no output here. The reason being 30 is greater than equal to 50 is false. So my print statement did not execute. Okay. Now if you want, you can also print another statement outside the if condition. I'll give the message as execute statement after if. Now one thing to remember, that this print statement is outside the if condition. So if I run it, only my last print statement gets executed, which is outside the if condition. Okay, now let's write another simple if statement. Now this time we are not going to define the grade value or predefine the grade value. Here we are going to take the grade value as an input, that is a user input. So I'll write grade equal to, now the way to take a user input is by using the input function. So first of all, we need to convert our entry into an integer. So I'll write int function, and inside that I'll pass in my input function. Then I'll give my message as enter the number. Alright, so this statement will take the number from the user. Now I'll write my if statement if grade is greater than equal to 50, then it won't give a space here. Let's delete the space. Then I'll write print you have passed in the exam. Okay, let's run it. You see here my program is asking for the user input. It says enter the number. I'll give my number as, let's say, 60. If I hit enter, that gives me the result passed in the exam. Now let's run it again. This time I'm going to give as, let's say, 35. If I run it, there is no output here. The reason being our grade 35 is not greater than equal to 50, so our print statement did not execute. Alright, okay, now let me give a space here. We'll run it again, and this time we'll pass our grade as, let's say, 75. Let me run it. You can see here it gives me the message passed in the exam. Now moving to our next statement, we have the if-else statement. So this is how the syntax of if-else statement looks like. So first you have the if condition followed by a colon. If this condition evaluates to true, then we execute the list of statements that are present inside this if condition. Else, we have the else block here. If this condition returns false, then we execute the list of else statements. So here is the flow of how the if-else statement executes the different statements. So first we check the test expression. If that evaluates to true, then we have the body of if, and if it is false, then we have the body of else, and later if there are any statements that are present outside the if-else block, we'll execute those statements. Now let's head over to our Jupyter Notebook and we'll see how the if-else statement works by example. Okay, so here I'll show you another example of using two if statements. So I'll define my grade as 40. I'll write if grade is greater than equal to 50, then we'll print, let's say, pass. Then I'll write another if statement. I'll say if grade is less than 50, then we'll print fail. Now here I'm using two if statements. Let me run it. You see here I have my result as fail. The reason being our grade 40 is less than 50 and hence it has printed fail. Now instead of using two if statements, you can use the if-else statement. So in this case, we'll have our if statement checked for if grade is greater than or equal to 50. If this is true, then we'll print whatever is there inside the if statement. But in case this evaluates to false, we have another else block that we are going to write. Let me show you how to write the if else statement. So I'll give a comment as if else. Okay. I'll say grade equal to 40. Then we'll check if grade is greater than or equal to 50. Print pass. Then instead of using the if statement again, I'll write else followed by a colon, and then I'll write print fail. Make sure this fail is inside double quotations. If I run it, it gives me the result fail. The reason being 40 is not less than, repeat, 40 is not greater than or equal to 50, so hence it has printed fail. Now instead of taking the value as 40, we can have the user give the input. So we'll use the input function. I'll say enter the grade. Let's run it again. You see here my program is asking for the user input. Let's say I'll give 80. We'll run it. It says pass because 80 is greater than or equal to 50. Let me run it again. This time let's say I'll pass my grade as 45. We'll run it. It gives us fail. Alright. Now moving to our next conditional statement, we have the elif statement. Now this is how the syntax of elif statement looks like. So here first we have the if condition. Now if the if condition evaluates to true, we have the body of if. That is basically a set of statements. Now if the first test expression or the if condition evaluates to false, then our elif condition gets executed. Now if our elif condition is true, then we have the body of elif. So this is the elif statement body. Finally, if the elif condition also evaluates to false, then we have the block of else statements. You can see here we have body of else, and later if there are any statements outside this if, elif and else block, then those statements get executed. Now we'll see this with the help of examples. Okay, so here on my cell I'll give my comment as elif statement. Okay, suppose I have a variable called score and this take the value as integer from the user. So I'm using the input function. I'll say enter the score. I'll give a space. Then I'll write my if condition. I'll say if score is, let's say, greater than or equal to 90, give a colon, then we'll print our message as passed the exam with, let's say, A grade. I'll just copy this statement because we are going to print similar statement below as well. And now I'll have my elif condition. I'll write elif. Elif is actually else if score is greater than equal to, let's say, 75. I'll give a colon. We'll print passed the exam with B grade. Then I'll again have my elif statement. I'll write if score is greater than or equal to, let's say, 60. We'll print pass the exam with C grade. Next, let's write another elif condition. I'll write elif if score is greater than, this should be greater than equal to, okay, is greater than equal to, let's say 40, then we'll print pass the exam with D grade, and finally we'll have the else condition. I'll write print, let me just scroll down, failed in the exam. Okay, so this is how you write a elif conditional statement. So first I'm taking the user input of the score, then I'm checking if score is greater than equal to 90. I'm displaying my message as pass the exam with A grade. Then I have a list of elif statements to check for different scores. If all these evaluates to false, I am having my else statement printed. Let's run it. Okay, so we'll try out different scores. Let's say someone scored 95. If I run it, so that candidate has passed the exam with E grade, because if you see the condition, my score 95 is greater than equal to 90, and hence we have passed the exam with A grade as the message. We'll run it again. Let's say I have 80. If I run it, it says pass the exam with B grade. The reason being 80 is greater than equal to 75, and hence we have this message printed. Let's run it again. Suppose someone scored, let's say 25. If I run it, okay, it throws me an error. It says name score not defined. Okay, so this should be score actually. Here there was a spelling mistake. I'll run it. I'll pass my score as 25. It gives me failed in the exam. The reason being my score 25 is less than equal to 40, and hence we have failed in the exam. Cool. Now you can also use a for loop and then have a list of if else block or if else statements. Let me show you how to do it. Suppose I write for x in, I'll use the range function. I'll go till 10, which means from 0 to 9. Then I'm checking if my x is less than equal to 3. I'll print x is less than or equal to 3. Okay, now we have the elif statement. If elif x greater than 5, I'll print x is greater than 5. Then we have the else condition. We'll print, let me just scroll down. I'll print x must be 4 or 5. Okay, so here I have used a for loop and I am checking for each iteration from 0 to 9, and then we have a set of if, elif and else statements. Let's run it. There you go. You can see the output here. So first in my range I have 0, so it will check if 0 is less than equal to 3, which is true, so it has printed 0 is less than or equal to 3. So it will go till 3, and then when 4 comes, it will check if 4 is greater than 5. Now this is also false, so it will skip executing the elif statement, and it will print whatever is there in the else block, which is 4 must be 4 or 5. So you can see the message here, 4 must be 4 and 5. Similarly for 5 also the same message will be printed, the reason being 5 is not greater than 5. And then for the rest of the numbers from 6 to 9, we have 6 is greater than 5, 7 is greater than 5, 8 is greater than 5, and 9 is greater than 5. Alright. Now moving ahead. Next we have the nested if statement. So here is the syntax of nested if. So you have the if condition, and inside the if condition you have another if condition, and hence it becomes the nested if condition statement. And inside this condition you have the list of statements or the blocks of statements. So here is how the flowchart or the flow diagram looks like. So first we are evaluating the expression 1, which is this condition. If it is true, we are going inside and checking the second condition. If that is also true, then we are running the body of if, which is this part of the syntax. And later, if there are any statements that are present outside the if condition, we are executing those. So in case the first test expression evaluates to false, we are coming outside and directly printing whatever is there outside the if condition. Let's see this with the help of an example. Okay, so I'll give my comment here as nested if. Cool. So first of all, I'll declare a variable called num. Now this num will have a user input value. So I'll write input, enter the number, then I'll have my first if condition. I'll say if number or num is less than 250, I'll give a colon, then we'll use the print statement num is smaller than 250. I'll write my second if statement and we'll check if num is less than 180, and we'll print num is smaller than 180 as well. Finally, I'll have my else statement as print number is greater than 180. Alright, let's run this, and first we'll check with the number 100. Okay, there you go. So here I'm checking whether 100 is less than 250, which is true. So we have printed 100 is smaller than 250. Again we are checking if 100 is less than 180, which is true again. So we are printing 100 is smaller than 180 as well. There's a spelling mistake. Okay, now let's see for, let's say, 150. Again we have 150 is smaller than 250, 150 also smaller than 180. Let's run it. This time let's say we'll pass 300. Okay, you can see our result here. 300 is less than 250 is false, so we'll skip printing this. Again we'll check whether 300 is less than 180, which is false again, so we'll skip printing this statement as well. We'll only have our else block printed, which is 300 is greater than 180. Okay, now coming to the final section where we'll see about nested if else. So here you can see we have the syntax for nested if else statement. So we have an outer if condition, and inside that we have another if condition. Then we have the list of statements or the body of the if condition. If this is false, then we execute the else part, and after that we also have an outer else statement. So this is how the flow diagram looks like. We'll check for the test expression 1. If that is true, then we'll go inside and see the test expression 2, and if that is true, we'll execute the body of if statement, which is this part of the syntax. Then if these are false, then we'll see the body of else 1. If the second expression is false, then we go to the body of else 2. And after that, if there are any more statements, we'll execute them as well. Alright, we'll see an example here. So I'll give my comment as nested if else. Okay, so I'll declare a variable a which will take a user input of type integer. I'll say enter the number. I'll write if a is less than 50. So this is my first if condition. If this is true, this should be less than 50. Okay, so if my first if statement is true, then we'll check for the second if statement, which is, let's say, if a modulus 3 equal to 0, which means if the remainder of the division is 0, then we say print a is divisible by 3 and is less than 50. Okay, then we have our else statement as else print my number a is not divisible by 3 but is less than 50. Finally, I'll have my last else statement where I'll print my number a is greater than 50. Okay, so this is how you write a nested if else statement. So I'm taking my number as a user input. First I'm checking if that number is less than 50. If that is true, I'm again checking if that number is divisible by 3. If it is divisible, I'm printing my message as the number e is divisible by 3 and is less than 50. If this is false, I'm saying the number e is not divisible by 3 but it is less than 50, else I'm saying the number is greater than 50. Let's run this and we'll try out different examples. Let's say I'll say my number is 12. My message is 12 is divisible by 3 and is less than 50, which is this part of the code. So my number 12 is less than 50. This is true. Then I'm again checking whether 12 is divisible by 3. It evaluates to true and hence we have this result printed. Okay, let's say this time I'll say 30. So I have my message 30 is divisible by 3 and is less than 50. Let's run it again and this time let's say we'll say 72. So here I have my message 72 is greater than 50. The reason being 72 less than 50 is false. Hence this part of the code is not executed. It will directly come to the else part which says 72 is greater than 50. Okay. So that brings us to the end of this demo session on conditional statements in Python. So first we learned how to write simple if statement. You saw how to take inputs from the user. We also learned how to write if else statement. Then you learned about elif statement. You also saw how to use a for loop, and inside that you can use your if statement, your elif, your else. Later on we saw how to write nested if statements, and finally we learned how to write nested if else statements. Cool.
Now let's see the agenda for today. First, we will learn about the list in Python, its characteristics, and explore it in Jupyter Notebook. Then we will learn about tuples in Python, its characteristics, and we will also explore tuples in Jupyter Notebook. After that, we will have a look at dictionaries in Python, its characteristics, and we'll head to Jupyter Notebook to understand the dictionaries. So let's start with lists in Python. Imagine you have different values. You have numbers, you have strings. Now, if you want to group them together, you can do this job in Python with the help of lists. Or you have worked with arrays in any other language like C++ or Java. This is the similar stuff in here, which is list. A list can be defined as a collection of objects, values, or items of different types, and these collections are enclosed within the square brackets and are separated by commas. Let's understand this with the help of an example. We will create a list and name it as list1 and insert the elements in square brackets and separate them with the help of commas. List1 equal to square brackets 1, comma, Adam, comma, 107, comma, USA. And in lists, we have our first element at 0th index, and we have 1 at 0 index, Adam at 1 index, 107 at 2nd index, USA at 3rd index. And talking about the reverse index, it starts with -1 index value. We have USA at -1 index value, 107 at -2 index value, Adam at -3 index value, and 1 at -4 index value. We will explore the list with various examples in Jupyter Notebook in a while. Till then, let's look at the characteristics of lists. First, the lists are ordered. When we say that lists are ordered, it means that the items have a defined order, and that order will not change. If you add new items to a list, the new items will be placed at the end of the list. Second, elements of the list can be accessed by index values. Third, lists can store various types of elements, for example numbers, strings, or lists itself. Fourth, lists are mutable. The list is changeable, meaning that we can change, add, and remove items in a list after it has been created. Lists allow duplicate elements. Since lists are indexed, lists can have items with the same value. Let's have a look at some methods of lists in Python. The first one is append. It adds an element at the end of the list. For syntax, we can write list1 dot append, and in round brackets we have to write the element which we want to append. The next is insert. It adds an element at the specified position. Its syntax is name of the list dot insert, and in round brackets we'll write the index at which we want to insert the element and comma, and after that the element which we want to insert. Third is extend. It adds the element of a list to the end of the current list. Its syntax is list1 dot extend, and in round brackets we will add the element like list2 which we want to extend in the list. The next is index. It returns the index of the first element with the specified value. And its syntax is list1 dot index and the element which we want to fetch the index. The next is remove. It removes the item with the specified value. Its syntax is list1 dot remove, and in round brackets we write the element which we want to remove from the list. The next is sort. This method is used to sort the list. Its syntax is list1 dot sort. The next is reverse. It reverses the order of the list. Its syntax is list1 dot reverse. Let's move to Jupyter Notebook to explore these methods. Let's start with creating a list. We'll name the list as list1, and we'll create equal to, and we'll start with square brackets, and we'll write our first element, that would be apple, comma, space, next element orange, comma, space, the next element banana, comma, space, the next element kiwi. Now we will get this list printed. For that we will write the syntax print, and in round brackets we will write the list name, that would be list1, and run the command. You can see here that the list is printed. Now let's create a different list with some different elements. List2 equal to, and in square brackets we will write apple. Now we will insert a list in a list. For that we will write a list in square brackets 8, 4, 6, and comma, the next element, that will write orange, the next element banana. Now we'll print this list. To print this, we'll write print, round brackets we'll write list2 and run the command. Here we will get the list 2 printed. We can access any element in the list. So for that we'll write the syntax print. We want to access the second element, that will be the third element from the list 1. For that we'll write the syntax print list 1 and in square brackets we'll write the index 2 and run the command. We'll get the third element from the list 1, that is banana. Now we will access an element from the list 2. For that we'll write the command print list2 and in square bracket we will write 1 and in square bracket we'll write 2 and run the command. What we get is 6. So to access an element from a list that is already inserted in a list, we have to write this syntax. So this syntax tells us that we will first access the first index element, that is 846 the list, and in that we will access the second index value, that would be 0, 1 and 2, that is 6. So this is the syntax to access an element in a list that is already inserted in a list. Now we will see a reverse index order. For that we will write the command print list1 and in square brackets we will write the index -1 and we'll run this command and we get kiwi as output. Now we'll see slicing in Python. We can access a range of items in a list by using the slicing operator. Now we will see an example to see the slicing operator work in Python. For that we will write the syntax print list1 and in square brackets we'll write 1 slicing operator 3 and run the command. What we see is orange and banana as an output from the list 1. When you write 1:3, that is 1 slicing operator 3, it gives you the elements at index 1, 2 and not 3. So we get the output as orange, banana. Now we will see another example for the slicing operator. We'll write print list1 and in square brackets we'll write 3 and slicing operator. Run the command. Here we can get only kiwi. When we write a single number before slicing operator, it would print the value at that index value and all the other elements that are present in the list. But in this list we have only kiwi as the last element, so it would print third index value and not more than that. Now we'll see append function. For that we'll write the syntax list1 dot append and in round brackets we'll write the element which we want to insert at the last of the list. We'll write guava and run it, and now we will print the list to see the result. Here we can see that guava is added at the last of the list. Now we'll see extend function. For that we'll write the index list1 dot extend and in round brackets we will write in square brackets the particular elements we want to insert in the list. So we will write watermelon and the next element we want to insert would be muskmelon. That would be in inverted commas. And we also want this list to be printed, so we'll write print list1 and execute this command. Here we can get watermelon and muskmelon added just after the list, just at the last elements of the list. Now if you want to delete a particular element from the list, you can delete it with the syntax del space the list name you want to delete the element, and in square brackets you will write the index for the element you want to delete. We have written the 5th index value, so we'll run this command and we'll get the list printed. we can see that the 5th index value, that is watermelon, is not there in list 1. It's been deleted. Now you can also do this with another method, that is remove. For that we will write list1 dot remove, and in round brackets we will write the particular element we want to remove. We will write that is kiwi, and we also want the list to be printed, so we'll write print in round brackets list1 and run this command. We get that the kiwi is being removed from the list 1. Now there is another method, that is pop. We'll write that command print in round brackets. We'll write list1 dot pop, and we'll write the index value what we want to remove from the list, that is 1. And we also want the list to be printed, so for that we'll write the command print list1, and we'll run this command. Okay, we have not written the name of the list correctly, so now list1. Now so at the 1 index, that was orange, that has been removed from the list, and now this is the new list. Now we can see another method, that is clear, that removes all the elements from the list. So this we will apply on the list2 dot clear method, and we'll also write another command, that would be print list2, and execute this command. We can see that the list 2 is empty now. All the elements from the list 2 have been removed. Now we'll see another method, that is reverse. For that we'll write the command list1 dot reverse and round brackets, and we also want the list1 to be printed. For that we'll write the command print list1 and execute this command. Here we can see that the list1 is being reversed: muskmelon, guava, banana, apple. Now if you want a particular index element to be accessed, you can have the syntax. For that you can write that print list1 dot index, and in round brackets you just need to write the element for what you want to get the index, and just run this command. You will get the index of the element guava, that is 1. We have another method in list, that is count. So count is used to give the number of times the particular element is present in the list. So for that we'll write the syntax print, and in round brackets we'll write the list name list1 dot count, and in round brackets we'll write the particular element for which we want to get the number of times that has been present in the list. We'll write muskmelon and run this command. It would give us the value 1 because it's been present in the list for only a single time. Now let's move to the tuples. So tuple is almost same as list. We can have different types of values in tuples. The difference in list is we can change value because list is mutable and tuple is immutable. That means you cannot change the value. A tuple can be defined as a collection of objects, values, or items of different types, and these collections are enclosed within the circle brackets and separated by commas. Let's understand this with the help of an example. We will create a tuple and name it as tup1 and insert the elements in round brackets and separate them with the help of commas. So tup1 equal to round brackets, the first element is 1, comma, and the second element is Adam, third element is 107, and the fourth element is USA. Now in tuples we have our first element at 0th index, and we have 1 at 0 index, and Adam at 1 index, and 107 at 2nd index, and USA at 3rd index. And for the reverse index, it starts with -1 index value. We have USA at -1 value, 107 at -2 index value, and Adam at -3 index value, and 1 at -4 index value. We will explore the tuples with various examples in Jupyter Notebook. But till then, let's look at the characteristics of tuple. So the first is the tuples are ordered. When we say that tuples are ordered, it means that the items have a defined order and that order will not change. Elements of the tuples can be accessed by index. Tuple items are indexed. The first item has index 0. The second index has 1. Third, tuples can store various types of elements, that is, strings, arrays, and many other elements. The next is tuples are immutable. Tuples are unchangeable, meaning that we cannot change, add, or remove items after the tuple has been created. Next is tuples allow duplicate elements. Since tuples are indexed, they can have items with the same value. Let's have a look at some methods of tuples in Python. First, that is index. We can use the index operator to access an item in a tuple where the index starts from 0. Its syntax is the name of the tuple dot index, and in round brackets we'll write the element for which we want to access the index. The second is slicing. We can access a range of items in a tuple by using the slicing operator. For that, we'll write the syntax tup1 and the range for which we want to slice the tuple. The third is concatenation. Here we will add two tuples, that is, we just have to write the name of the tuples to add them, and we'll place the plus operator just between them. The next is repetition. We can have the same item multiple times in a tuple. For that, we will just have to write the syntax, the name of the tuple, and the multiplication operator into the times we want that value to be present in the tuple. The next is count. It returns the number of items a specified value occurs in a tuple. So for that, we have the syntax tup1.count, and in round brackets we will just write the element for which we want to count the number of times that specified value has been occurred. We also have another method, that is index. It searches the tuple for a specified value and returns the position of that where it was found. Now let's move to Jupyter Notebook to explore these methods. So let's start. First we will comment, that would be tuples, and we'll move to the next column, and first we'll create a tuple. For that we'll write the command tup1, that would be the name of the tuple, and in round brackets we'll insert the elements, that would be apple, comma, orange, comma, banana, comma, kiwi. Now we will print this tuple. We'll just have to write print, and in round brackets the name of the tuple, and run the command. We'll get the tuple printed. Now if you just want to insert a single element in a tuple, for that we will write the command tup2 equal to, in round brackets you will write a single element, that would be apple, and run that command. The tuple is being created, but this tuple is not being considered as tuple in Python. It's been considered as string. So let's check the type of this tuple. For that we will write print type, and in round brackets we'll write the name of the tuple we want to check. We'll run this command. Here we can see that it is showing a string. So a single element is been shown as string in Python. If you want that it should be tuple, for that you just have to insert a single comma in the tuple, and now run this command. You will get this type as tuple. Now if you want to access any element in a tuple, for that you just have to write the command print tup1, and in square brackets the index value, that is 0, and here you quote the value apple, that is at 0th index value in tup1. Now we can also access the element in the reverse order. For that we'll write the command print tup1, and in square brackets we'll write the index value -1 and run the command. Here we can get the value kiwi from the reverse index order. Now we also have the slicing operator in tuples also. For that we'll write the command print tup1, in square brackets the index values where we'll run this command print tup1 index value 1 slicing operator 3. So it has printed orange and banana. So what does it means? It prints the index value 1 and 2 and not 3. We also have a repetition method in tuples. For that we just have to write a simple syntax like print in square brackets the element you want to repeat. We will write the element as repeat only, and comma to just consider as tuple, and just after the bracket we would have to write the multiply operator and the number of times the element should be repeated in the tuple. Now we'll run this command. You can see that the tuple has been created with the element repeat and the number of times is 3 that we have written just after the element. So the tuple has been created. Now we'll see the count method. For that we'll write the command print the name of the tuple dot count, and in round brackets we'll write the element for which we want to know the number of times it been present in the tuple, and we'll execute the command. It gives us 0 as our tup1 doesn't consist guava as an element, so it gives us the count as 0. Now we'll see another method that would be index. For that we'll write the command print tup1 dot index, and in round brackets we'll write the element for which we want to fetch the index of that element, banana, and we'll run this command. We will get the index of the element banana, that is 2, 0, 1, 2. So we get the index of the element banana. Now if we want to use the append method in tuples, we have to first create the tuple into the list. For that we'll write the command y equal to list, and in round brackets we'll write the name of the tuple which we want to convert in the list. Now we'll use the append method to the list, that is y dot append, and we'll insert an element that would be guava, and now we would just assign the y list to a variable tup1. We have now converted the y list to the tuple with this syntax, that is tuple y, and we have assigned it to the tup1 value. Now we will print this tuple and execute the command. Here we can see that we have used the append method in the tuple. First we have changed the tuple to the list by this command y equal to list tup1. Then we have used the append method y dot append and appended the element guava. Then we have changed the y list to the tuple, that is tup1 equal to tuple the name of the list, and then we have printed the tuple. We can also add 2 tuples by another method. For that we will write another tuple that would be tup3 equal to, we will insert an element that would be cherry, and now we want it to be added in tup1, so we'll write tup1 plus equal to tup3, and now we'll print the final tuple that would be tup1 and run the command. Here we can see that we have added 2 tuples, that is tuple1 and tuple3, which consists of cherry, and here we get the whole tuple as tuple1. Now to execute loops in tuples we'll write the command. For that we'll write the syntax for space a variable x in the name of the tuple colon, and then we will print the particular element one by one and we'll run this command. Here we can see that all the elements have been printed from the tuple. Now let's understand dictionaries in Python. In lists, you can fetch the elements with the help of index numbers. But if you want to specify a different type of index for it, example, if you have a list of 8 values and you want to fetch the 5th one, you will use the index. But if you have key for each element, then you can use the key to access that element. Example, phone book. If you want to fetch a number, you will use a name and you get a number. And officially, if we talk about dictionary, if you want to understand the meaning of a word, you go to that page and you look at the word and understand the meaning of it. So this type of concept where you have a key and corresponding to that you have a value, we can achieve this with the help of dictionaries. Python dictionary can be defined as a collection of objects, values or items of different types stored in key value pair format. These multiple key value pairs created are enclosed within the curly braces and each key is separated from its value by the colon. Let's understand this with the help of an example. Dict1 equal to curly braces, the first key is A and corresponding to that we have value and that is separated by colon. And after the key value pair that is separated by a comma. The next is B key and that has a corresponding value 2. After that we have inserted a comma to separate it from other values. Now we have a third key that is C and corresponding to that we have a value 3. Let's see some characteristics of dictionaries. The dictionaries are ordered from Python version 3.7. When we say that dictionaries are ordered, it means that the items have a defined order and that order will not change. Second, that is elements of the dictionaries cannot be accessed by index. Third, dictionaries can store various types of elements. Fourth, dictionaries are mutable. Dictionaries are changeable, meaning that we can change, add or remove items after the dictionary has been created. Fifth one is dictionaries doesn't allow duplicate elements. Dictionaries cannot have 2 items with the same key. Now let's see some methods in dictionaries. The first is clear method. It removes all the elements from the dictionary and its syntax is the name of the dictionary dot clear. The second is get. It returns the value of the specified key. The syntax is dict1 dot key and in square brackets we have to write the key name. The third is keys. It returns a list containing the dictionary's key. Its syntax is dict1 dot keys. The next is pop. It removes the element with the specified key. Its syntax is dict1 dot pop and in round brackets you would write the particular key name. And the next method is pop item. It removes the last inserted key value pair from the dictionary and its syntax is dict1 dot pop item. Let's move to the Jupyter Notebook and execute these methods. First we will add a comment that would be dictionaries and now we'll create a dictionary. For that we'll write the syntax name of the dictionary equal to curly braces. First we'll write the key value, then colon and the value corresponding to it. We'll write apple, then separate it by comma and then the second key value colon and the value corresponding to that key, that would be orange. When it would be separated by comma, then we'll assign another key value that would be 3 colon and the value corresponding to that would be banana comma. Next would the key value would be 4 colon and in inverted commas we'll write the value corresponding to it and we'll print this dictionary, print dict1 and execute this command. Here we can see that the dictionary is printed. With 1 key value we have the corresponding value apple, with 2 key value we have the corresponding value orange, with 3 key value we have the corresponding value banana and with 4 key value we have the corresponding value kiwi. Now to access a particular element, we can't do that in dictionary, but we can access a particular value with the help of key. We can do that in dictionary. For that we would write the syntax print the name of the dictionary and in square brackets we'll write the key value that would be 1, and run the command, we would get the value corresponding to the key value, that is apple, that is corresponding to the key value 1. Now we will see a get method in dictionary. For that we'll write the command print name of the dictionary dot get, and in round brackets we'll just write the key value and run this command. We'll get the corresponding value to the key value, that is apple. Now we will use another method that would be pop. For that we'll write the command print dict1 dot pop, and in round brackets we'll write the key value for the value we want the element to be removed from the dictionary. We'll execute this command and we get kiwi as the output. Now we print the dictionary, print dict1, we can see that the fourth key value and the value corresponding to that key value has been removed by the pop method. Now we can also print the length of the dictionary. For that we'll write the command print len, and in round brackets we'll write the name of the dictionary and just execute the command. We will get 3 as the output, as it has been considered 1 unit, 2nd unit and 3rd unit, so the length is 3. And we have another method that is sorted. For that we'll write the command print sorted and the name of the dictionary dict1, we'll execute this command. It would give us all the key values in a sorted manner when executed with this command. Now we can see another method, that is keys. For that we have to write the command print round brackets name of the dictionary dot keys round brackets, and we'll run this command and we'll get all the keys that are present in dictionary. There is another method, that is values. For that we'll write the command print dict1 dot values round brackets, and we'll execute this command. We'll get all the values that are present in the dictionary. Now we'll see another method, that is update, that is used to update the particular value corresponding to the key value, or update the dictionary with more values to be inserted in the dictionary. For that we'll write the command dict1 dot update. In round brackets first we'll write the curly braces, the key value, semicolon, and corresponding to that we'll write its value which we want to update, watermelon, and we'll also print the dictionary. We'll execute this command. We will get that the second value, that is watermelon, that's been updated. Previously it was orange and now it's watermelon, so it's been updated by this command. And we can also use this command to add more elements to the dictionary. For that we'll write the syntax dict1 dot update round brackets curly braces and the key value colon, and corresponding to that we'll write the value muskmelon, and we'll print the dictionary, and we'll execute this command. Sorry, we just omitted the name of the dictionary, dict1 dot update. Now we'll execute this command. Here we can see that the value has been added to the dictionary. Now we'll see another method, that is pop. For that we'll write the command dict1 dot pop, and in round brackets the key value for which we want the value to be removed from the dictionary, and we will print the dictionary and execute this command. Here we can see that the second key value has been removed from the dictionary, and we will see another method, that would be dict1 dot pop item, and then we will print the dictionary and execute the command. Here we can see that the pop item has removed the last element from the dictionary and we are left with only 2 elements in the dictionary. Now we will see some loops in the dictionary. For that we'll write the command for x in the name of the dictionary, that is dict1 colon, and then we'll write print dict1 and in square brackets the variable x, and we'll execute this command. So with this loop we can print all the values corresponding to the key values in the dictionary. Now to print both the key and values corresponding to it, we can run a loop. For that we'll write the command for x comma y in dict1 dot items colon print x comma y, and run this command. We can get the key and the values corresponding to it. Now if you want to copy the particular dictionary in another dictionary, you can write the command. First you will name the dictionary you want to create and copy the elements. We will name it as mydict equal to, now we'll write the command dict1 dot copy, and then we will print the new dictionary, that is mydict, and we'll run this command. Okay, we have not inserted the round bracket here. Now run this command. Here we can see that we have printed the mydict dictionary and it has the same values as dict1. Now we'll see another method to delete the whole dictionary. For that we'll write dict1 dot clear. It would remove all the values from the dictionary and will also print the dictionary after that. Run this command. Here we can see all the elements from the dictionary have been removed.
So what is list comprehension? In Python programming, list comprehension provides a shorter syntax when you want to create a new list based on the values of an existing list. So you can build a new list with a compact syntax based on the values of the existing list using Python programming. Now you can define a list comprehension inside the square brackets and execute each element using a for loop that will iterate over all the elements. Now below you can see the syntax of writing a list comprehension. I have my variable declared as new list that will store the list comprehension. So using square brackets I have mentioned expression, and I'm using the for loop which is going to iterate over all the elements in my old list, and after that I have my if condition. Now let's look at the advantages of using list comprehension. So it helps to accomplish your task with fewer lines of code. Now it is more time efficient compared to running multiple loops for the same task, and you can use iterative statements that appear as formula. Now let's head over to our Jupyter Notebook where we'll learn list comprehension in detail. So I am on my Jupyter Notebook. So let's start with our first example. Suppose you want to find the squares of all the numbers that are present inside a list. Now let me show you the traditional way of solving this problem. So first of all, I'll declare a list called num, and within square brackets I'll have some numbers, let's say 1, 2, 3, 4, and now I'll create an empty list called sq that will hold the squares of my 4 numbers that I have put. So I'll say for n, which is my iterator variable, in my list num, I'll give a colon, and then I'm going to append the squares to my variable called sq. So I'll write sq dot append, and to get the squares I'll say n. I'll use the double asterisk operator to get the squares. I'll say double asterisk 2. Now I'll just say print sq. If I run this, I get the result, which is fair enough. So the squares of 1, 2, 3 and 4 are 1, 4, 9 and 16. Now the same task you can do using list comprehension in just 2 lines. First of all, I'll just declare my list again, say num, which will have the values 1, 2, 3, 4 and let's say 5. Now I'm going to write my list comprehension like this. I'll say sq equal to, I'll have my expression which is going to be n asterisk asterisk 2. Then I'll say for my iterator variable n in my list num. That's all. So this is how you can write a list comprehension method, and then let's print sq. Now if I run this, we'll get the same result. You can see the squares of 1, 2, 3, 4 and 5 are 1, 4, 9, 16 and 25. So this is a simple example how you can use list comprehension in Python. It is very short and you can write the same task in a very compact manner, as you can see here. Cool. Now moving ahead, let's say you wanted to print all the letters in the word Simplilearn. So for that, let me show you how to do it in a traditional way first. So I'll create a empty list called, let's say, n underscore letters. I'll just give square brackets. So this means your n underscore letters is now an empty list. So I'll say for my iterator variable letter in my word, that is Simplilearn, I'll give a colon, then I'll say n underscore letters dot append my iterator variable letter. Now let me print n underscore letters. If I run this, you see here we have printed all the individual letters that are present in the word Simplilearn. Now the same task you can do using list comprehension in just one line. So I'll create a variable called n underscore letters, and then I'll write my syntax as letter for letter in my word Simplilearn, and then I'll just say print n underscore letters. If I run this, there you go. You can use the list comprehension technique to implement the above task in just one line. Alright. Now moving ahead, we'll see how to use a for loop, and we are going to display the cars that are present in a list and have a letter S in it. So first of all, I'm going to declare a list called cars, and it will have the names of a few cars. Let's say we have Jaguar, then we have Land Rover. Next, let's say we have Tesla. After that, let's say we have Toyota, and then we have Tata. Cool. Now I'm going to create an empty list called new list. I'll just give square brackets. Now I'll say for my iterator variable x in my list cars, I'll say if we have the letter S in X, then I'll say new list dot append X. After that, I'm going to say print new list. So what these lines of code will do is, my for loop is going to iterate through each of the elements that are present inside the list cars, and it will check if any of the car brands have the letter S, it is going to print that car brand. If I run it, you can see here we have Tesla, which has a letter S in it. The rest of the car brands don't have the letter S, and hence we have got Tesla. Now the same task you can do using list comprehension. I'll just copy this line of code because we are going to use the same car brands and the same list name called cars. Now I'm going to write my list comprehension technique. I'll say new list equal to, I'll say x for x in cars if, I'm going to use the if condition now. I'll say if s in x. Now let's go ahead and print my new list. If I run this, there you go. You again see that we have Tesla printed. Now let me just change this s to small a or lowercase a. If I run it, you see here all the 5 brands of car have the letter small a. You can see Jaguar has it, Land Rover also we have small a, Tesla has small a, we have Toyota and Tata as well. Now what if I change the name of Tata to all uppercase? So I write TATA all in uppercase. Now if I run this, there you go. Since Python is case sensitive and here we are checking only for lowercase a, so we did not have Tata in our result since we converted into an uppercase. Alright, now moving ahead, I'm going to show you how you can filter only those values in a list of integers that are greater than 50. So I'll say new underscore list equal to, I'll say x for x in range. I'm using the range function, so I want to print the list of integers, the first 100 integers, and I'll use my condition if x is greater than 50. Now let me go ahead and print my new list, which is new underscore list. If I run this, there you go. So here you can see our range is from 0 to 100, which means from 0 till 99. You can see it here. But we are only trying to print only those integers that are greater than 50. So we have values from 51 till 99. Suppose I'll change this to, let's say, less than 45, or let's say less than 30. Now if I run this, you see here we have all the integers present between 0 till 30. Cool. Now moving ahead, let's see another example. I'm going to use the same list which we had declared before, that is the list of car brands. Now I'm going to print all the car brands if it is not Tesla, but if the car brand is Tesla, we are going to change this to, let's say, Audi. Now let me show you how to do it using list comprehension. I'll say new underscore cars equal to, I'll use the square brackets, I'll say x if x not equal to, so I'm going to use the exclamation mark, equal to Tesla, then we should print x, else, I'm going to use the else clause as well. I'll say else if the car brand is Tesla, then changes to Audi, and I'll say for x in cars. Now let me go ahead and print new cars. There you go. So since all these elements were not Tesla, so we printed the car brands as it is. So Jaguar, Land Rover, Toyota and Tata. Now since we encountered one Tesla here, so with the help of list comprehension, we changed Tesla to Audi. Cool. Now moving ahead. So using function, we'll print true for even numbers and false for odd numbers. Let me show you how to do it. So I'll create a empty list called numbers. So this is an empty list. Now I'll say for I in range, let's say I'll set the range to 0, 20. I'll give a colon. I'll say numbers dot append. I'm going to give my condition I percentage 2 should be equal to 0. So this means within the range 0 to 20, I'm checking for numbers that are divisible by 2. So I am seeing if the remainder is 0, then I'll say print numbers. Now let me run it. There you go. So there are total 20 numbers starting from 0 till 19. Now wherever the number is even, we are printing true, else we are printing false. So this number starts from the 0 place, so we have 0 as true, 1 is false, again 2 is true because 2 is an even number, 3 is an odd number, so we have false, 4 is an even number, we have true, so here 5 is an odd number, so we have false, so on and so forth, and the last 3. So 17 is an odd number, so we have false, 18 is an even number, we have true, and 19 again is an odd number, so we have false. Alright. Now moving ahead, we'll see another example. Let me create a variable called numbers. I'll say I percentage 2 equal to 0 for I in range 0, 21. Let's print numbers and see the result. So here you can see we have the same result, this time using the list comprehension technique. Now coming to the final example in this demo, this time I'm going to create a 4x4 matrix using the Numpy library in Python, and from the matrix we are going to find the maximum element present in each of the rows. So let me first import my Numpy library. I'll say import Numpy as np. I'm going to create a matrix that will have random integers, so I'm using the random module, and inside that we have the randint function. I'll say, let's say 10. So I want the numbers within 10, and I'll set the size to 4, 4. I'll say print a. Now if I run it, you see here we have our randomly generated 4x4 matrix where the elements lie within 0 to 10. Now from this randomly generated matrix I am going to find the maximum elements. So I'll say max element equal to, I'm going to use the list comprehension technique. So I'll say max of I for I in my matrix A. Let's print max element. If I run it, you see here the maximum element from each of the rows. So in the first row we have 8 as the maximum element, and then in the second row we have again 8 as the maximum element. In the third row we have 7 as the maximum element, and in the fourth row we have 8 again. Now if I run this again, my randomly generated matrix changes. Now if I run it, you can see 5, 5, 9, 6 are now the maximum elements. Cool. So we are going to look at what is a function in Python. Then we'll see the different types of Python functions. Then you will understand the various advantages of using Python functions, and finally we'll head out to our Jupyter Notebook to understand Python functions in detail with hands-on demonstrations. Okay, so what is a function in Python? So a function is a bunch of statements that are defined to perform specific operations. A function in Python helps to divide your program into smaller and modular chunks, thus allowing you to make extensive programs more organized and manageable. It also avoids repetition and makes the code reusable. So let's understand the types of Python functions. First we have built-in functions. So these are the functions that are built into Python. So by default, the inbuilt functions are available in Python. Then we have user-defined functions. So functions defined by users to carry out certain tasks are called user-defined functions. They don't have a fixed name. So here on this slide you can see the different built-in Python functions that are available. So you have power, length, next, max, absolute, we have print, range, slice, sorted, round, and there are many more. So these we will explore in our demo session. So wait for a while. Now let's understand about the user-defined functions. So these functions are defined by users to perform specific tasks, and these are the steps that you need to create a user-defined function. So first you need to create the function and then call the function. Now moving to the next slide. So here you can see the syntax of writing a user-defined function. So we use the def keyword to define the function, followed by the function name, and within brackets you have the parameters or the arguments of the function. Then you have the function block, and if you want to return a value from the function, you can use the return function followed by the expression. So here is an example where we are just printing hello Python using a user-defined function, and in this case my function name is called my underscore function. If I call my underscore function, it will return me hello Python. Cool. Okay, now let's understand the advantages of using Python functions. So with the help of functions, you can avoid rewriting the same logic or code again and again in a program. So in Python, you can call functions anywhere multiple times in a single program. You can also track an extensive Python program easily when it is divided into multiple functions. And the most crucial feature or the advantages of Python functions is that of its reusability. Cool. Now let's head over to our Jupyter Notebook and we'll explore the inbuilt and user-defined functions in detail. Okay, so I'm on my Jupyter Notebook. First I'll go ahead and rename my notebook as functions in Python. I'll click on rename. Okay. First of all, let me just increase the size. Okay. I'll give my comment as built-in functions. Okay. So we'll start by looking at the absolute function in Python. So absolute or ABS function returns the absolute value of a number. So I'll say, let's say a equal to, I'll use the absolute function which is represented as ABS in Python. Suppose I write ABS of, let's say 10.75, and if I print a, it gives me 10.75, which is fair enough. Let me just copy this code. I'll paste it here. I'll say b equal to ABS. This time I'm going to use the negative symbol or the negative sign. I'll say minus 10.75 and we'll print b. Let me run it. You can see here Python has automatically removed the negative sign and it has just given us 10.75. So this is how the absolute function works. So ABS returns the absolute value of a number, which is always positive. Now let's see another inbuilt function, very popular, which is called the length function or len. I just give a comment saying len. Above also let me just give a comment as ABS. Okay, so later we can have a track of whatever functions we have learned in the demo. So the length function returns the length of an object. It could be an iterable such as a list, it could be a tuple or even a dictionary. Let me show you how it works. I'll say list1 equal to, I'll create a list within square brackets. Let's say I have a few letters. Let's say IN, then I have D, I again, and A. So I have all the letters in my word India. Now if I say x equal to len of list1, then I'll print X. It gives me 5 because the length of all the characters in my list is 5. You can count here INDIA. So there are only 5 elements and hence it is returned as 5. Now we'll explore another function which is called as all. So the all function returns true if any item in an iterable object is true. So I'll say my underscore list equal to, let's say I have 0, 1 and 0. I'll say X equal to, then I'll use the all function, and inside the function I'll pass in my list, which is my underscore list, and will print X. Hold on for a second and can you please guess what this X will be? It gives us false. The reason being we have two false values, 0 and 0 here, and there is only one true value which is 1. Suppose I had 1, 1 and 1. If I run this, it would have given us true because all the elements in my list or the iterable are true. If any one of the elements is false, it will give us false. Okay. Now moving to our next function, which is called sum. So Python sum function is used to get the sum of numbers of an iterable. Let's say I have s equal to, I'm using the function sum, and inside the sum function I'm going to declare a list of numbers. Let's say we have 20, 35 and let's say 70. Let me create another list called s1. I'll say sum, and now let's say we'll pass in a tuple now. So I'm using another bracket. We have, let's say, 7, 5 and 9. Now if I write print s, and let's say I want to print s1, you can see here my sum function has returned the sum of all the numbers in the iterable. The first one was a list, and next we have a tuple. So 20 plus 35 plus 70 is 125, and then 7 plus 5 plus 9 is 21. So this is how the sum function works. Now moving ahead, we have the max function next, as well as the min function. So as the name suggests, the max function will return the maximum number of an iterable. So I'll create a variable called m1 and I'll use the max function. Let's say we have a few values, 7, 10, 3, 12, 61 and 40. Now let's go ahead and print m1. Now if I run it, it returns me the maximum number that is present inside my list of numbers or the tuple that I have passed in. Here you have the maximum number as 61. Now let's use the max function over a dictionary. So I'll create another variable called m2 and I'll say max, and inside the max function I'm going to pass in my values in the form of a dictionary. So I'm using curly brackets or braces. I'll say, let's say 7, 90, we have 3, let's say 150, 67 and 44. Now let me go ahead and print m2. If I run it, you can see it here, it has given us 50, which is the highest element in my dictionary. Okay. Now similarly you can use the min function. Let me just copy this and I'll paste it here. I'll say m3. Instead of max function we are going to use the min function. So the min function will return the minimum number in an iterable. Let's say I'll pass in m3 as a list this time, and if I say print m3, it gives me 3, which is the lowest number or the lowest value in my list. And similarly you can have the lowest value printed from a dictionary. I'll just change the variable to m4, and instead of max we'll use the min function, and here also I'll use the variable as m4. If I run it, you can see here we have printed the minimum value in my dictionary, which is 3. Okay. Now moving ahead, we'll explore another function called iter. So Python iter function returns an iterator for the given object. So the iter function creates an object which can be iterated one element at a time, and the next function returns the next item in an iterator. Let's use both iter and next function in our next example. So I'll create a list called myList, and I'll say equal to followed by using the iter function, and inside the iter function I'm going to pass in a list which will have letters of India. I have N, D, I, and then I have A. Now I'll create another variable called X, and then I'll pass in the next function, and inside the next function I'll pass in my list, and we'll go ahead and print X. So it will print the first element in my iterable, that is I here. Now if I copy this and I'll paste it here, if I run it again, you can see it here. The iter function returns the second iterable, which is N in my list INDIA. I'll paste it again. If I run it, we have the third item in the list, which is D. Okay. Now coming to using the power function in Python. So Python POW, or the power function, returns the power of the given numbers. Let's say x raised to the power 3. So I'll declare a variable x1 and say POW. Let's say I want the value of 3 raised to the power 3, and let's say I have another variable called x2. I'll use the POW function, and this time I want to know what is 2 raised to power 4. We'll go ahead and print x1 and x2, and as you guessed it, 3 raised to the power 3 or 3 cube is 27, and 2 raised to the power 4 is 16. Cool. Now coming to using the range function. So the Python range function returns a sequence of numbers starting from 0 and increments by 1. So this is by default and stops before the given number. So let me show you. If I say x equal to, I'll use the range function, and inside the range function I'll have my value as 6. Then I'll say for n, now here n is my iterator variable, I'll say for n in x, print n. Let's run it and we'll see the result. You can see here the range function has returned us the number starting from 0, and it has gradually incremented the iterator by 1. So we have from 0 till 5. Now I'll show you another example. I want to change the default starting value, that is 0. So I'll say if x equal to range, I'm going to start from 40 till 50 with a step size of 2. So you can pass it as the third argument, so it will skip one value and print the next value. So then I'll say for n in x, I'll give a colon, let's print n, and we'll see the result. You can see here it starts with 40 and has a step size of 2. So we have 40, 42, 44, 46 and 48. Cool. Now let's move ahead and we'll explore the round function in Python. So the round function rounds off a number to the given number of digits. Let's say I have x equal to, I'll use the round function, and then I'll have a decimal value, let's say 8.62475, and I want to round it to 2 decimal places. Let's print x. If I run it, you can see here my Python has returned a rounded up value to 2 decimal places. So we have 8.62, and the rest it has just skipped. Now moving ahead, we'll explore the sorted function in Python. So the sorted function returns a sorted list of the specified iterable object. You can specify ascending or descending order. So I'll create a list called A, and we have the elements, let's say again India. So I have I, N, D, I, and I have A again. If I say X equal to sorted A, and if I print X, you can see it here, Python has sorted the elements in the list in ascending order of the letters. So we have A appearing first, then D, again I, and then finally we have N. Now suppose you wanted to print the letters in descending order, you can use another argument here. I'll give a comma and say reverse equal to true. So this line will ensure my list is sorted in descending order. You can see it here, it has just reversed the above result. So we have N appearing first, and I, D, and A. You can do the same for a list of numbers. Let's say we have 12, 50, 38, 76, let's say 27, 80, and 5. I'll say X equal to sorted A, and will print X. If I run it, you see it here, we have sorted the numbers in the list in ascending order now. If you want to sort it in descending order, just add reverse equal to true. There you go. Here my list has now been sorted in descending order of elements. Now we are going to look at the final built-in Python function, which is slice. So the slice function returns a portion of an iterable as an object of the slice class based on the specified range. Suppose I have a list called A. Okay, let's not define a list, we'll define a tuple. So this has the letters in the word Simplilearn. So I have S, I, M, P, L, I, again L, I have E, comma, I have A, then we have R, and finally I have N. So these are the letters which have been represented as a tuple. Simplilearn, then I'll use the slice function and I'll give my range as 5 and will print A of X. Let's run it. You see it here, the slice function has sliced the first 5 elements in my tuple. So we have S, I, M, P, and L. Cool. So we have explored all the important built-in Python functions. Now let's head over to using user-defined functions or learning user-defined functions in Python. I'll give a comment first, user-defined functions. Cool. So as we had learned in our slides, to define a user-defined function, we will use the def keyword and a function name. This should be a valid Python name. So I'm using func1 followed by parenthesis, and then we'll have a colon. And now we'll define the body of the function. I'll say print hello world. This is the same example that we had seen in our slide. Now I'm going to call the function using the function name, which is func1. If I run it, you can see it here, I have my message printed hello world. So this is a very simple user-defined function and it does not carry any arguments or parameters. Now let me show you another user-defined function. I'll say def hello. Again, we are not giving any parameter to this function or arguments to this function. I'll say name equal to str. This time we are going to take the input from the user, so I'm using the input function, I'll say enter your country name, I'll give a colon and a space, and then we'll say print. I'll print the message hello followed by a space, give a plus sign, then we are going to convert our name to string. So this is my function. Let me run it. Now I'll call hello. It is asking me for entering country name. I'll say Japan. If I hit enter, it says hello, then my country name, which is Japan. So hello Japan. Let me run it again. This time I'll say USA. I'll hit enter. You can see here my message is hello USA. Cool. Now moving ahead to our next example, where we'll see using functions with different parameters. So we'll start with a very simple example. I'll say DEF. I want to convert feet to centimeter. I'll say my function name as ft_2_cm. So I'll pass in a value for feet, and that feet will be converted to centimeters. And this time inside parenthesis I'm going to pass in my parameter as ft. I'll use the formula for centimeter. I'll say my variable centimeter equal to feet multiplied by 30.48. So 1 feet is actually 30.48 centimeters. So centimeter becomes feet into 30.48. Then we are going to use the return keyword, and I'm going to return the output, which is centimeter. Let's run it. Now to call the function, I'll use my function name, which is ft_2_cm. This is my function name. And then I'm going to pass in a value for feet. Let's say I want to convert 6 feet into centimeters. If I run it, there you go. You can see it here. 6 feet is actually 182.88 centimeters. Let's say 5.8. If I run it, it is 176.784 centimeters. So here you saw how to pass in arguments to a user-defined function. Now again, you can pass in multiple arguments. Let's say I'm going to find the sum of two values. For that I'll create a function called def. My function name is add. I'm going to add two values x and y. So I'm passing in two parameters x, y. I'll create a variable called sum that will store the value of x plus y. And then let's print sum. Okay, let me just scroll down. I'll hit shift enter to run it. Okay, we have created my function, that is add. Now let's add 40 and 50. You have to pass in two arguments because we have declared x and y in the function, so it needs at least two arguments. If I run it, you have the sum of 40 and 50, which is 90. Let's say I have minus 20 and 30. If I run it, you have the result minus 20 plus 30 is 10. Alright. Now similarly, you can also multiply two numbers. Let me just copy this. I'll paste it here, and instead of add, I'll give my user-defined function name as multiply. I'll say product equal to x asterisk y, and I'll print product. Let's run it. I'll call my function using the function name multiply. Let's say 4 multiplied by 6. So the result is 24. Cool. Now moving ahead, We'll explore another example. Let's say I want to print the absolute value of a number. So I'm creating a function called def. My function name is absolute, and I'll pass in one parameter which is x. I'm going to use a if-else statement. I'll say if x is greater than or equal to 0, I'll give a colon. Then I'll say return x, else give a colon, I'll say return minus x. I'll run it. Now if I print absolute of, let's say, 56, the result is as expected. Since 56 is greater than 0, we have just returned 56. Let me just copy this. I'll paste it here. Let's say absolute of minus 56 is again 56 because we are returning minus x, so minus of minus 56 becomes plus 56. Now if you wanted to return minus 56, you need to make some modifications. I'll put another minus and keep this within brackets. Let me run the function again. And now if I print absolute of minus 56, you have the result as minus 56. Okay. Now let's see another example how to find the factorial of a number using a user-defined function. So we'll define our function as def. I'll use the function name as factorial. I'm going to pass in a parameter called x. I'll say if x is equal to 0, then we'll just return x or return 1. I'll say else, give a colon, return, I'll say x asterisk or multiplied by, I'll use the function name factorial, I'll say x minus 1. Now let's run it. I'll call my function factorial. Let's say I want to find the factorial of 5, the result is 120. Let's say the factorial of 10, the result is 36,28,800. Cool. Now let's see how you can pass in default arguments to your function or default parameters. Okay, suppose I have a function defined called welcome. Here I'm going to pass my argument as name, and in the argument itself I'll pass in the value, a default value, let's say Paul, give a colon, and I'll print hello. This would be within quotes and the name. Cool. Let me just run it. Now I'm going to call the function welcome. This time I'm not giving any value to my function. If I run it, it has automatically taken the default argument, which was Paul, so my message becomes hello Paul. Now let's say I'll pass in a value welcome, and within quotes I'll say Racy. Now the message becomes hello Racy. So if you pass in a value to your function welcome explicitly, it will take that value instead of the default argument. Cool. Now you can also have multiple arguments in your function, as we saw above for the addition and multiplication functions. I'll create a function called message, and we'll have the arguments as name1, name2 and name3. Give a colon, I'll say print a message that is hello. I'll give a space, give a comma, we have name1, give a comma, and then I'll say comma please tell, give another comma, I'll have my name2, give a comma followed by the message that, then I have name3, this should be a comma instead of a period, then I'll say is waiting. Make sure this is within quotations again. Just give a exclamation mark. Okay, so I have my message. Let's run it. Now I'll call my function message. We need 3 arguments now, so I'll pass in 3 names. Let's say my first name is Gilly, my second name is Rachel, and my third name is, let's say, Shaw. I'll run it, and you can see here we have my message printed, hello, followed by name 1, which is Gilly. So hello Gilly, please tell name 2, which is Rachel. So please tell Rachel that name 3, which is Shaw, that Shaw is waiting. Cool. Now we'll understand about scope of variables in a function. Now your scope could be a global scope or a local scope. Let's define a function called func3. Now inside the function I'm going to create a variable called z, which has a value of 7. Now I'll just print z and I'll call in my function 3. If I run it, you have the value printed of z, that is 7. Now if I want to access my variable, that is z, outside the function, if I run this, it throws me an error because this variable z was defined locally, that is inside the function, and you cannot access z outside the function. Now to overcome this issue, let me just copy this. We are going to declare z as a global variable. So I'll have z outside the function. I'll say z equal to 7, and then I have my function defined. I'll just change the name of the function to function 4, and then we'll print z, and I'll call the function 4. If I run it, you can see it here. I have the value of z printed, that is 7. Now if I want to access z outside the function, then also it's fine because we have defined z outside the function, that is z is now a global variable, so its scope is throughout the function. Now another thing to note here is you can't change the value from inside a local scope. So if I say z equal to 7, and then I'll define my function func, let's say 5, I'll give a colon, and I'll say, let's say I want to alter the value of z to, let's say, z plus 7. I'll print z, and let me now call func5. If I run this, it throws me an error. As I said, it says local variable z referenced before assignment. So you can't change its value from inside a local scope. For that, you're going to explicitly define the variable z as global. Let me show you how to do it. I've just copied this code. I'll paste it here. I'll say z equal to 7. I'll define my function, let's say func6. Here I'm going to say global z. So I've explicitly defined my z as a global variable. Now if I call the function 6, you can see here we have altered the value of z from 7 to z plus 1, that is 7 plus 1, which is 8. Okay. Now asterisks, args in function definitions in Python are used to pass a variable number of arguments to a function. Suppose you don't know the exact number of arguments you need, so you can use the argument with an asterisk symbol. Let me show you how to do it. I'll say def welcome, and here I'm going to pass in asterisk followed by the name of my argument, which is names. I'll say print. I'll print my message as hello, comma. Then I'm going to say names, the first name, which is with index value of 0, comma, followed by a space. Then I have name 1. I'll give a comma followed by a space, and then we'll have names 2. This should be names. Okay, let me run this. Now I'll call my function welcome. Now you can see here I have passed in my argument, that is names, 3 times. So let's call 3 names. Let's say we have Steve, then we have Bill, and then we have, let's say, Yash. Now if I run this, there you go. We have a message printed, hello Steve, Bill, Yash. Okay. Now coming to the final section of our demo. Here we are going to find out the area of a circle and a sphere. So we are going to define 2 functions, one for circle and another for sphere. So first of all, let me define the value of pi, which is 3.14. I'll start with def. I'll give my function name as circle area, and inside that I'll pass in my argument, that is radius. I'll give a colon, and we are going to return the area of a circle, which is pi r square. So I'll have radius, again an asterisk symbol, and then radius. So this becomes pi into radius, which is pi r square. Okay, now let's define another function called def. I'll say sphere area. I'll have my argument as radius. I'll give a colon and say return 4 pi r square, which is the area of a sphere. So I'll have 4 multiplied by pi multiplied by radius multiplied by radius. So this becomes 4 pi r square. Now we are going to define the main function. So I'll say define main, where we'll just have our print statement. So I'll say print circle area with radius 15. I'll give a comma and say circle area, which is my function name, and we'll pass in the value of the radius, which is 15. I'll just copy this message and we'll print it here. I'll say sphere area with radius 15 is, I'll just change this to sphere, and let's say we'll have radius for 10 instead of 15. Okay. Finally, I'm going to call my main function. So I'll just say main. Now let's run it. Okay, there is one error here. This is an indentation problem. Now we'll run it again. There you go. So the circle area with radius 15 is 3.14, which is the pi value multiplied by radius into radius, that is 15 into 15. So the value is 706.5. And similarly, the sphere area with radius 10 is 4 into 3.14 into 10 into 10, that is 1256. Alright. So what is a lambda function? A lambda function is one of the simplest ways to define a function in Python. A lambda function is an anonymous function defined without a name and does not have the def keyword. It can accept any number of arguments but can only have one expression. So the function is always defined using the lambda keyword, which you can see it here. So here we have the syntax for lambda function. We use the lambda keyword followed by the arguments, and then we have a colon. After that we have the expression that we want to evaluate. Cool. Now moving ahead, let's look at an example of using lambda function in Python. Now if you were to add two numbers in Python using a function, you would ideally use the def keyword followed by the function name and then pass in the arguments. You can see the arguments here, a and b. Then use the return statement to get the value of the addition. So we have return a plus b. And finally, you will call the add function and pass the argument values to get the result. Now this operation can be done using the lambda function as shown here. So we have defined a variable called add, which is equal to, and then we have used the lambda function followed by the two parameters or arguments. So here a and b are the arguments, and then I have my expression a plus b. See, all this you can do it in one line. And then to call the function you use print followed by the variable which is add, and then you have the arguments 3, 8. So the addition of 3 plus 8 would be 11. Now you can see that instead of using the def keyword, we have used the lambda keyword, and there is no parenthesis required. Anything after the lambda keyword is treated as a parameter or argument. So we use a colon to separate parameters and the expression. In our case, the expression is a plus b. Now moving ahead, we'll look at the pros and cons of lambda functions. So lambda functions are suitable for simple logical operations. So when we want one expression in return, we can use the lambda function. Now lambda function is used as a parameter to different functions such as map, filter, reduce. We will see all this in our demo session. Now coming to the cons of using a lambda function. So lambda functions can only evaluate one expression, as I told you earlier. You cannot write a docstring to explain all the inputs, operations and outputs as you would do in a normal user-defined function that uses the def keyword. And finally, lambda functions are generally not preferred when you have to declare a function with multiple lines of code. Now let's head over to our Jupyter Notebook where we will learn about lambda functions and how to use it in different ways. So I'm on my Jupyter Notebook. Let me just go ahead and will rename the notebook as lambda functions in Python. Okay, I'll just click on rename. Cool. First of all, I'll write a general user-defined function using the def keyword. Let's say I want to add two numbers. So this example we have already seen in our slide. So the way to do is I'll use the def keyword followed by the function name, and then I'm giving my arguments or the parameters. After that, let's say I want to store the addition of a plus b in a variable called result. So I'll say result equal to a plus b, and then I want to return my output, that is result. So I'll say return result. So this is how you will normally create a function in Python. If I run it, and then I'm going to call my function using the function name, that is add, and then I'll pass in my parameters a and b. Let's say my a is 3 and b is 4. If I run this, I will get the result 7, which is fair enough. Now if I want to do the same operation using a lambda function, I would do something like this. Let's say I'll create a variable called add, and then I'm going to use the lambda function followed by the arguments a comma b. Then I'll give a colon and say a plus b. After that, I'll just say add and then pass in my parameters 3, 4. If I run it, you have the same result, that is 7. Now let's see another example using lambda functions to add a number. This time I'm going to pass in only one argument. So I'll say add equal to lambda, my argument is x, I'll say x colon x plus, let's say I want to add x with 100. I'll say print add, let's say I want to add 50 with 100. If I run it, I have the result 150. Alright. Now in Python, there is no need to assign a lambda to a variable. You can directly call it. Let me show you how to do it. I'll say lambda a comma b, which are my arguments. Again, this time I'm going to use a multiplication operator, since I want to do a product of A and B, and after that, using another parenthesis, you can directly pass in the arguments. So there is no need to explicitly assign a lambda to a variable. So if I want to find the product of, let's say, 15, 30, if I run it, I have the result 40. Let's change the arguments. Let's say I want to find the product of 5, 7. The answer is 35. So this is known as an immediately invoked function expression, or IIFE, which is often pronounced as IFE. Now you can also use keyword arguments using lambda functions. Let me show you what I mean. I'll create my lambda function and assign it to a variable called product. I'll say lambda. Let's say my arguments are x, y, and z. After that, I'll give a colon and say x multiplied by y multiplied by z. Next, I'll say print my variable, that is product, and here I'm going to use keyword arguments. So I'll say, let's say z equal to 5, x equal to 10, and y equal to 4. You can see here this need not be in an order as you have defined the arguments. If I run this, I have the result, the product of 5 multiplied by 10 multiplied by 4 is 200. Now you can also use default arguments. Suppose I say add equal to, I'll use the lambda function and say x, comma, y I am assigning a default value of, let's say, 15, and z, let's say I'll assign a default value of 24. Then I'll give my colon followed by the expression, that is x plus y plus z. Now I'll say print add. Now here I'm going to only pass in my value for x, since I've already given a default value for argument y and z. So my function only needs one argument, that is x. So let's say I want x to be 20. If I run this, you see the result here. So 20 plus 15 plus 24 is 59. Now you can also use the asterisk args parameter, or args. So this allows you to define as many arguments as you want. So I'll say addition equal to lambda, then I'll say asterisk args. So this will allow us to pass in as many arguments as you want, and I want to find the sum of args. So I'm using the inbuilt sum function in Python. Now I'll say print my variable name, that is addition, and let's say I want to find the sum for 4 values or 4 arguments, let's say 20, 2, 40, and let's say 50. If I run it, so the value is 112. So 20 plus 2 plus 40 plus 50 is 112. Cool. Now lambda functions are also used with higher order functions, which take one or more functions as arguments or return one or more functions. Let me show you. So I'll define a variable called higher underscore ord underscore fun, which stands for function, and ord stands for order. So I'll declare my lambda function. Suppose the parameters are x, and then I have a function, and then followed by a colon, I have my expression as x plus function of x. Now I'll say higher underscore ord underscore fun, and I'll pass in my 2 arguments. Let's say my x is 20, and for this function I'll have a lambda function defined. I'll say lambda x colon x multiplied by x. Now let me just run this and I'll show you the result. Okay, so what it did was it added my value of x, that is 20, with function of x or fun of x. What is fun of x? Fun of x is x multiplied by x. So 20 multiplied by 20 is 400. So this becomes 400 plus x, which is 400 plus 20, hence the result is 420. So this is known as a higher order function. Now let me show you another example. Let's say I want to display odd or even by taking the value of x. I'll say lambda x colon. Here I am going to pass in my expression. If x mod 2, give a space here, I'll say and odd or even. Now I'll give my argument value, let's say 30. The result is even because 30 is divisible by 2. I'll just change this to, let's say, 15. If I run it, the answer is odd because 15 is not divisible by 2. Let's say I have 150, the answer is even. Now moving ahead, so let's write a lambda function that checks if a string is a substring of the given string. So I'll create a variable called sub_string. Now I'll assign this variable with a lambda function. I'll say lambda, my argument, let's say string. I'll give the colon and pass in my expression string in. Let's say my string has this message, welcome to Python functions tutorial. Okay, so we are going to check if a string, let's say in, to, welcome, Python, Java, anything, whether it's present inside this string which is welcome to Python functions tutorial. Now let me go to the next line. I'm going to print sub_string, and let's say I want to check for my string, let's say Java. If I run it, it gives me false because the word Java is not present inside my string welcome to Python functions tutorial. Suppose I write Python. Now one thing to note here is the P is small and here the P is in capital letter. If I run it, it again gives me false because Python is case sensitive. Now if I make this as capital P, it will result in true. Let's say I want to say, instead of tutorial, let's say I have training. If I run it, it tells me false because this word training is not there in the string welcome to Python functions tutorial. I'll change this to tutorial. You see here I have my result as true. Alright. Now let's see how to use lambda functions using filter function. So we are going to filter a list of numbers using a specific condition. So I'll create a list called num. Let's say it has values 40, 10, 40, then we have 56, 27, let's say 33, 15 and 70. So this is my list. Now I am going to use my lambda function along with the filter function. So I'll pass in my variable as greater. I'll say list, then I'm going to pass in the filter function, and inside the filter function I'll use the lambda function, and I'll have my argument as num, and my expression, let's say I want to filter only those values which are greater than 30. So I'll say num greater than 30. This is my expression or the condition that we want to check. I'll give a comma and I'll have my next argument as num, and let's go ahead and print the variable greater. If I run this, there you go. You can see here we have all the values from the list, or the numbers from the list, that are greater than 30. So we have 40, 56, 33 and 70. So 10, 27 and 15 are less than 30, and hence those three values were not printed. Now let's say you want to filter a list of numbers that are divisible by 4. So I'll create another list called list1, and let's say I'll have the same values in the list, so I'll just copy it and I'll paste it here, and I'll create my variable, let's say divide. I'll say divide equal to list1. I'll use the filter function followed by the lambda function. I'll say x colon, then I'll have my expression x mod 4 should be equal to 0. I'll give a comma and pass in my next argument as my list1. Now I'm going to say print divide. Okay, I'll remove the bracket here. There is no need of a bracket here. Cool. And we'll delete here as well. Now let's run it. Okay, there is one error here. This should be list1. Let's run it again. Okay, there is some error. Let's debug it. Okay, so this should be the function list. Cool. There you go. So here you can see we have two numbers, 40 and 56, that are divisible by 4. The remaining numbers are not divisible by 4 and hence were not printed. Alright. Now let's go ahead and explore how you can use the map function along with the lambda function. So the map function accepts two arguments, a function and a list. It takes that function and applies it to every element of the list and returns the modified list. So we'll create a list called list2. I'll say equal to, and again we are going to have the same values in the list as above. So I'll just copy those values or the numbers and I'll paste it here. Okay, now let's say I want to find the value of a number multiplied by 2. So I'll say, let's say the variable name is double the num or double the number. I'm going to use the list function followed by the map function this time, and then we'll have our lambda function. I'll pass in my argument as x colon followed by the expression, so x multiplied by 2. I'll give a comma and then we'll have the list, that is list2. There's a spelling mistake here. This should be list2. Alright. Now I'm going to say print double underscore the underscore num. Make sure there is no space in the variable name. Now if I run it, you can see here we have multiplied every number in the list by 2. So 10 multiplied by 2 is 20, 40 multiplied by 2 is 80, similarly 30 multiplied by 2 is 66, 15 multiplied by 2 is 30, and again we have 70 multiplied by 2 is 140. So this is how you can use map function with lambda functions. Now suppose you want to find the power of a number. Let's say I want to find the power of a number raised to 3. So I'll create a list called list3. Let's say I have values 2, 5, 10, 6, 4, and then let's say we have 12. I'll say cube. So I want to find the value of a number raised to the power 3. So for that I'm going to use the map function followed by the lambda function. I'll pass in my argument x, and then here I am going to use the inbuilt power function in Python. So POW, my argument x, and this x I want to raise it to the power of 3, and then I'll have my next argument, which is list underscore 3 or list 3. Okay, now let's print the list. So I'll say list of cube. I'll run it. You can see here, so 2 raised to the power 3 or 2 cube is 8, 5 cube is 125, 10 cube is 1000, 6 cube is 216, 4 cube is 64, and 12 cube is 1728. Now coming to the final section of the demo, where we'll see how to use the reduce function in Python along with the lambda function, and then we'll use a lambda function within a user-defined function. So first let's look at how to use reduce in Python. So reduce applies a rolling calculation to all items in a list. You can use it to calculate the total sum or to multiply all the numbers together. So reduce function is a part of functools module. So to use the reduce function, you need to import the functools module first. So I'll say from functools import my function, that is reduce, and then I'll say, let's say I have my list 4 this time. I'll create a list. I'm going to take the same values as above, and I'll pass in within a list. And now I want to find the sum of all the numbers that are present inside this list called list 4. So I'll do that using my reduce function followed by the lambda function. So I'll say x comma, and I'll give my expression as y colon x plus y, give a comma, and pass in my last argument, which is my list itself, which is list 4. Alright, and then I'll say print sum. Let's run it. There you go. So 2 plus 5 plus 10 plus 6 plus 4 plus 12 is 39. So this is how you can use the reduce function in Python. Suppose you wanted to find the product of all the numbers present inside the list, so you can just use the asterisk instead of the addition operator. Now if I run this, you have the product of all the numbers that were present inside the list, that is list 4. We have 28,800. Now let me show you the final demo, that is using a lambda function in a user-defined function. So first of all, I'll create a user-defined function to calculate the value of a quadratic equation. So for some of you who don't know the formula of quadratic equation, it is ax square plus bx plus c. So we are going to use that formula in our function and find the value using lambda function. So I'll create a user-defined function called quadratic, and it will have 3 arguments, a comma b comma c. I'll say return, and here in the return expression I'm going to pass in my lambda function. I'll say lambda x, which is my argument. I'll say x colon, and then I'll have my equation, which is a x square. So I'm saying a multiplied by x raised to the power 2. So I'm using double asterisk plus b multiplied by x. So this becomes ax square plus bx plus I have my constant, that is c. Now just go to the next line. I'm going to create a variable, let's say f. I'll have my user-defined function name quadratic. I'll pass in the values for a, b and c. Let's say a is 2, b is 3, and c is, let's say, 5. And I'll call a of 1. The value of x is 1, the value of a is 2, the value of B is 3 and the value of C is 5. Now let's run it and see the result. So ax square plus bx plus c for a equal to 2, b equal to 3 and c equal to 5, the result is 10. Now let's change it to, let's say I want the value of x as 2. If I run it, you have the equation evaluated and the result is 19. Alright.
So let me first just give you a brief of what are the syntax for these functions, what are the signatures, what are the input parameters required, and then we will jump into the Jupyter Notebook and run some examples. So what is a map function? The map function takes another function as an input, and the second input is a sequence of iterables. It could be a list, it could be a set, it could be an array or anything you want. And it returns the output after executing the function which you have passed as a parameter on each of the element of that iterable. So the function could add the values, could multiply, could divide, or any mathematical operation you want to do, or even you can perform certain string operations, which we will take a look in the examples. But the idea is that you want to apply the function on each and every iterable item individually. So the map function helps you achieve that. Also in our examples, we will take a look that you don't need to explicitly define a function. You can also use lambda functions, which are inline functions. So you don't need to increase the line of code. You can reduce the lines of code by just writing the function in line, and that way it will make it more simple. The next function which we are going to talk about is the filter function. Now, what is the purpose? The purpose of the filter function is to reduce the size of the iterables based on the condition which you will pass to the filter function. So syntactically, it is very similar to map function, but the only difference is that you need to pass a function which carries a condition. For example, you have a set of iterables 1, 2, 3, 4, 5, 6, 7, 8, 9, and you want the function to return values which are greater than 5. So your filter function should have a condition which says that the iterables greater than 5 should only be returned by this function. So that's why you have to make sure that a filter function always have a condition which is either true or false. So based on whatever condition matches as true, the filter function will only return those values as an output. So we will take a look. And the same concept applies. Either you can make a explicit function or you can apply lambda function inline. The third function which we are going to talk about is the reduce function. The only difference between reduce function and the other functions which we talked about, the map and filter, is that reduce function always returns a single value. So it combines all the values in the iterable, your list, your array, your set, and returns a single value. So you can apply the mathematical functions, like for example, you want to add all the values in your iterable, or you want to multiply. So it will multiply sequentially and give you the output. And the same concept applies over here. You can have lambda functions or explicit functions. Also, with one thing which you need to remember is that you need to use function tools module to import the reduce function. So we will take a look at that while we will be running certain examples. Okay, so here we are. So we will start by running our examples. So first we will start with map. So let's start by defining a very simple function which adds two values, right, and returns you the added value, right? So in the next step, we will define a list of iterables. So here we have taken an iterable list of 4 items, 4, 6, 8, 9 numbers. Now in this step we will apply the map function. Now please notice that we are sending two parameters to this map function. One is the function name, which is add, and the list, which is numbers. Okay, now I'll print the out, but it's an object, so right, it's not in a readable format, so I need to convert the out object back to a list. And now I'll be able to print. And here is my expected output. So I had four numbers in my list, which is 4, 6, 8, 9, and the map function has added the numbers to itself: 4 plus 4, 6 plus 6, 8 plus 8, 9 plus 9, and so that's how you're getting the output as expected. Now let's take a look at another example. We're going to redefine our list, and we are going to use now a lambda function instead of an explicit function, which is going to multiply the numbers in my list with themselves, and we are going to print my out object, convert it back to a list, and then I'll print my converted list object. And here you go. This is my output: 4 multiplied by 4, 6 multiplied by 6, 8 multiplied by 8, and 9 multiplied by 9. Okay, so here in this example we have seen about lambda function. Now we have been performing mathematical operation. As I mentioned earlier, we can also perform certain string operations. So let's take an example. What I'm doing in this example is I'm creating a map, and I'm just converting all my lowercase strings to uppercase, and I'm just printing my list now after conversion. So such kind of string operations are also possible. Let's take another example where we are going to print the length of each of the string which is there in my list, and I'm using lambda function. And here it is. So now you can see the list, the length of each and every string variable in my list: 3, 5, 6, and 7. Okay, so now these were the examples of map object, map function. Now we will talk about filter. So let's start with a simple example. So as I mentioned, the filter function should always have a condition. So let's create a function which has a condition saying if a is greater than 5, then return a. It means that you need to only return numbers which are greater than 5 in my list. So now I'm going to call this in my filter function. So if you see the syntax here, please notice filter, you pass the fill and the list, and then you print the out object after converting into the list, and only the numbers which are greater than 5 are printed. Now let's take a look at a lambda function example rather than an explicit function. The same example, but now instead I am using a lambda function, and I'm going to print it. Output should be the same. Okay, so the only change is in the syntax of the function definition. Here we have explicit function, and here we have a lambda function. Output is the same. Now let's take an example of a string operation, string filter. What kind of string filtering we can do? So I have an example over here. So what I'm going to do is I'm going to have a list of string arrays which is going to return me only those strings which have E in them, occurrence of E. Okay. So I've created a function veggies with E, and within this list of veggies, peas, garlic, ginger, beetroot, carrot, I will only get those string variable values which have E in it. Okay, so I've got the result, peas, ginger and beetroot, right? And garlic and carrot have been discarded. Now let's run this similar example with lambda function, where I'm saying that, okay, give me those vegetables which have R in it. So I'm just gonna run this and print my map. Okay, and here is my expected output: garlic, ginger, beetroot and carrot. So what have we noticed is that similar to map filter function, of course, the only difference is the function should have a condition which should return a true or false, and based on that, the iterable list get filters out. Now let's talk about reduce. Now, as I mentioned, the first important thing is that we import the reduce function from function tools, okay, and then we apply a lambda function. So we're going to start off with just taking an example of lambda. So here is my list of 4 elements: 10, 35, 50 and 20, and I'm adding the numbers in this list. Okay, so the map function is not gonna, the reduce function is not going to add the numbers to itself, but to the subsequent number in the list, right? So what is the expected output, right? The expected output is 10 plus 35 45 plus 50 95 plus 20 115. So what the reduce function has done is it has added the numbers in the list amongst themselves, right, in the orderly fashion. Now let's take another example. Instead of addition, we'll do a multiplication. Okay, so here what we have done is we have multiplied 9 by into 7 into 23 into 4, and we've got this answer. So this is another way of doing it. Now instead of lambda function, I'm just going to show you a simple adding the numbers. I define a function where you add the first and second number, and then you pass the function name to reduce. So custom sum and the list, similar to what we had done for map and filter, and now you can print the result. Now one thing to notice is that this result is a single number. You don't need to convert it back to a list, so you don't need to do that transformation. You just simply print the result, and here it is: 68. 3 plus 4 plus 6 plus 9 plus 34 plus 12.
So what is a class in Python? A class is a virtual entity or a blueprint for creating objects. A class in Python provides a means of bundling data and functionality together. You can think of a class as a school. So here school becomes your class. A school has attributes about the students, classrooms, labs, playgrounds, etc. Hence the school can be called a class, and classrooms, labs, desks, playground, assembly are the attributes or objects of a class. A class comes into existence when it is instantiated or initiated. We can create as many objects as possible in a class. Now in Python, a class is created using the keyword called class, followed by the class name. The first string inside the class is called docstring and has a brief description of the class. Below you can see the syntax of creating a class in Python. We have the class keyword followed by the class name. This should be a valid Python name, and then you have a colon. Below that you have the statements that should be present inside the class. Now let's look at an example of a class in Python. So Here you can see we have created a class called student, and we have two variables, the student ID and the name of the student. And after that we have created a function using the def keyword. So this is a user defined function, and the name of the function is called display. And inside the display function we are giving a parameter called self. So here the self parameter refers to the current class object and accesses the class variables. We can use anything instead of self, but it must be the first parameter of any function which belongs to the class. Now moving ahead, so let's look at what is an object in Python. So an object is also called an instance of a class, and the process of creating this object is called instantiation. Now you need to create an object of the class if you want to use the class attributes in another class or method. Now the procedure to create an object is similar to a function call. So below you can see we have created a object called stu, and we have called the class student using parentheses. So this is how you create a class, and after that we are displaying the message to be printed by calling the class name followed by the function which is present inside the class. So this example will create a new object instance named stu. We can access the attributes of the objects using the object name prefix. Now moving ahead, let's understand the initialization or init method in a Python class. The init method is similar to constructors in C++ and Java. All classes in Python have an init function. It is always executed when the class is being initiated. You can use the init function to assign values to object properties or other operations that are necessary to do when the object has been created. So the init function is called automatically every time the class is being used to create a new object. So here you can see we have used the init method. We have defined using the def keyword. Then we have parameters self, name and age. So we are calling the class using this object called s1, and then we have passed in the values for name and age, that is delay, and his age is 27 years, and after that we are printing the age and the name as well. Alright, now let's get started with our demo on classes and objects in Python on the Jupyter Notebook. So I am on my Jupyter Notebook. Let me first go ahead and rename my notebook to classes and objects in Python. Alright, I'll click on rename. First of all, let me show you how to create a simple class. So I'm creating a new class using the class keyword. So this is the keyword class, and followed by the keyword I have my class name called new class. One thing to note here is the class name should always be a valid Python name. I'll give a colon, and in the next line I'll just say x equal to 50. So this x is a variable which is present inside my class called new class. Now if I run it, I have my new class created. Now if you want to display the value of x, you can just say new class dot x. Now if I run this, you can see here I have my value printed, which is 50. Now we'll see another simple example to create a class and to call that class using an object. So I'll say class, then I'll say new class, let's say 1, give a colon, and I'll create a variable called x equal to 100. So my x is a variable which is present inside new class 1 and holds a value 100. Now I'll give a comment, create object. So to create an object, I'll define a variable called r. Let's say r stands for result, and then I'll say new class 1. So I'm calling my class, and then I'll say print r, which is my new object, dot x. Let's run it. You see here I have my value printed of x, which is 100. So this is how you can create or initiate a class using an object. Now let's see how you can use the self parameter in a class. So I'll go ahead and create a class called student, give a colon, then I'll have some variables or the attributes of a student. Let's say the student ID is 10 and the name is Anderson. Now inside the class I'm going to create a user-defined function called display. So I have used my def keyword followed by the function name, that is display, and inside the display function I'll use self as my parameter, and then I'm going to say print self.id. I'll give a comma and I'm going to print my name. So I have written self.name. So I'll run this, and then we're going to create an object called s, and we'll call our class, that is student, and I'll say s.display. Now let's run it and see the result. You can see it here. We have called the class using this object called s, so it's displaying the ID, that is 10, and the name, that is Anderson. Cool. Now we are going to see an example where we'll pass a doc string. So in the slide we discussed that the first string inside the class is called a doc string and has a brief description of the class. So let me show you an example how to pass in a doc string. I'll create a class, again let's say called student, give a colon, and then we'll have our message, which is essentially a doc string. I'll say this is a student class. Then I'll create a variable called age. Let's say the student's age is 14, and then I'll create a user-defined function called welcome and have my self parameter. After that I'll say print my message, let's say hi, comma, welcome to section, let's say B, and then I'll come out of the class and we are going to print class name, that is student. I'll say student.age, and then I'll say print, I'll just scroll down, student dot, then I'm going to use the function name, that is welcome, and after that to print the docstring message I'm going to say my class name, that is student dot, I'm going to use underscore underscore doc underscore underscore. Now we have created a class called student that has a variable called age, so we are going to display the age of the student, and then we are going to display the doc string. So here we are not going to print the message which is present inside the function called welcome. Let's run it. You can see it here. We have the message printed. So first we are printing the age of the student, and then we have the docstring message, that is this is a student class. Alright, now let's move ahead. We are going to see how to use the init function in a class. So I'll say my comment init function. Alright, I'll scroll down. I'll create another class called student. This time we are going to use the init function. So I'm writing def space underscore underscore init underscore underscore. Then we'll have our self parameter. Let's say the next parameter is name, and then we have the date of birth of the student. I'll say self dot name equal to name. Then I'll say self dot dob or date of birth equal to my parameter, that is dob, and then I'll say my object, let's say s1. I'm going to call my class student, and it will have values of name and date of birth. Let's say the name of the student is Harry, and the date of birth, let's say it is 29th October 1992. Alright, and finally we are going to print s1.name, and then I'll say print s1.date of birth. Let's run it. You can see it here. We have the name and the date of birth of the student printed. Cool. Now you can also modify the objects that you have created. Suppose I want to change the name from Harry to Virat because my object was s1.name Harry. I want to change this to Virat. Let me show you how to do it. This is very simple. I'll just give a comment that is modify objects. The way to do is you just say the object name, that is s1, followed by the parameter, that is name, equal to, let's say, Virat. Now if I print s1.name, I'll have Virat instead of Harry. Okay. Now if you want to delete the object properties, let's say I want to delete one of the properties, let's say I want to delete name property of the student. To do that, I can use the del keyword followed by the object name, that is s1, and say s1.name. Now if I print s1.name, it will throw an error saying student object has no attribute name, because we are first deleting it and then we are trying to print it, and hence Python cannot recognize this attribute name. Now you can also delete objects, that is all the objects, using the del keyword. So this means we can delete both the objects that we created above, which is name and date of birth. So the way to do is I'll just say del s1. So it will delete all the objects, that is s1 in this case. I'll run this, and then let's say I want to print s1 dot date of birth. You see it here. Python says name s1 is not defined because we deleted it. Cool. Now coming to the final section of the demo, we're going to create a simple class with init method again. So this time my class name is, let's say, animal. Give a colon, and then I'll write my init method using the def keyword. I'll say self comma name, that is the name of the animal, as the parameter. I'll say self dot name equal to name, and then I'm going to create another function called def, which is essentially a welcome or a greet message, and that has a parameter that is self. I'm going to print the greet message or the greeting. I'll say hi, my name is, give a comma, and then say self dot name. Now I'm going to create my object a1 to initiate my class. So I'll say animal, which is the class name. Let's say the name of the animal is puppy. Then I'm going to say a1 dot greet. I'll use parenthesis. Let's run it. There you go. You see here we have a message printed, hi, my name is. Then using the self dot name argument or the parameter, we are passing in the value that is puppy. Alright, so that was a demo session on Python classes and objects. So we saw how to create a simple class in Python, and then we saw how to create objects to call a class, and then we saw how to use the self parameter. After that we saw how to print a message that is present in the doc string of a class, and then we checked a few examples on using the init method in a class. Then we learned how to modify objects and delete objects in a class, and finally we saw another example on init method. Alright,
We are going to talk about the concept of inheritance, the types of inheritance which are applicable. So the different kind of inheritance which we're going to talk about are single level inheritance, multi-level, hierarchical, and multiple inheritance. And we're going to support each concept with an example. Before we begin this session, I just want to highlight that inheritance is not a new concept in any of the programming languages. Just like in Python, this concept is applicable across multiple programming languages like Java, C++, etc. Now, what is inheritance? Inheritance provides the reusability of a code. It allows you to inherit what you have written in a particular class or a piece of code, and you don't need to rewrite it. You can inherit it. So that is the main purpose of inheritance. It is creating a new class that utilizes the properties and behavior of an existing class. So we will support this with an example. So if you take a look at the syntax, the sample syntax over here, you have a base class and you have certain attributes, functions associated with the base class. And then you have a derived class in which you extend, basically you inherit the base class and you inherit the properties of the base class. Now, the new class formed is called the derived class or the child class. You can call it anything, derived, child, or subclass. And the existing class whose properties are inherited is known as the base class, parent, or superclass. These are synonymous. So anywhere you hear that, okay, you're working on a child class or derived class, you can easily figure out that you're talking about a derived class. And whenever there is a reference to a parent or a superclass, it means we're talking about the base class, right? Now, with this concept, with this idea, let's move ahead and look at the different types of inheritance which are possible in Python. Now here we are trying to display pictographically, diagrammatically, the different kinds of inheritance, and this will make understanding more clear. Now let's talk about first single level inheritance. You have a class A and you have a class B. So basically only till class B, only single level child is inheriting the attributes, the properties of class A. So that is what we call as single level inheritance. Multi-level is you have multiple level of inheritance. In, for example, class B here inherits class A properties and class C inherits class B properties. So ultimately you can see that the properties get trickled down till class C, right? So that is the example of a multi-level, right? Next is hierarchical, in which two classes are inheriting from a single class. Class B is also inheriting from class A and class C is also inheriting from class A. So both class B and class C are kind of siblings to the parent class A, right? Multiple inheritance, it means that a child class is inheriting properties from two parent classes. So in this example, the class C is inherited the properties of class A also and class B also. So we will be looking at these examples when we will be running in Python. Now let's take this example with a real world object, right? Let's first try to give you a view of how we are going to, what we want to explain in the inheritance with real world objects, right? Now here we are taking an example of a black and white TV and a color TV. Now single level inheritance. In this type of inheritance, there is only one single derived class from a single base class, as I mentioned earlier. So for example, you can assume there is a class called black and white TV. And what are the attributes of a simple black and white TV? It has a regulator, it has a sound adjustment. Now there is a child class called color TV which inherits the basic attributes. Of course, a color TV also has a regulator, a sound adjustment, but additionally on top of it, it also provides new features like color picture and cable connection. So now what do you understand by this is that the child inherits the basic properties from the parent class, but it also adds on the new additional features. So the color TV does not need to rewrite or the functionality of a regulator and the sound adjustment, it has inherited it. Multi-level, very similar to single level, but now we are adding more features. So like in the previous example, color TV inherited the features of black and white TV. Now we move a step ahead. Now there is another classification, another advancement of Wi-Fi LED TV. So that has also inherited the features from color TV, right? So it's a multi-level inheritance. So just to reiterate, the black and white TV had channel regulator, dish antenna. The color TV added additional features of color picture quality and cable connection. And the Wi-Fi enabled TV added the new smart features to the TV, which it inherited from the color TV. Multiple inheritance. Now in multiple inheritance, the derived class is inherited from more than one base class, right? So now, for example, over here, you have a class called Android, which is an Android operating system based class. And one is the Wi-Fi LED class, which has the Wi-Fi features of like sound, picture, Wi-Fi enablement. And if you combine all these features and bring it into another child class, that class is the Smart TV class, which has the features of Android and the features of Wi-Fi LED TV. And then you call it as a Smart TV. It has all the Android applications, it has the Wi-Fi features and etc. So this is the example of multiple inheritance, getting the best of all the parents. Hierarchical, if more than one class is inherited from the base class, right? So now if we just tweak our prior example and just rephrase it, what we are saying is now from the black and white TV you can also make a color TV, you can also make a smart TV, or you can also make a Wi-Fi LED TV, right? So there is no restriction as such. So basically the color TV is also inheriting the features of a black and white TV. Smart TV is also inheriting the features of a black and white TV, and the Wi-Fi LED TV also is inheriting the features from black and white TV. So it's a very typical example of a hierarchical inheritance. So now let's quickly look at the examples. Okay, so let's start off with a very simple single level inheritance. Let's make a class and create a function called speak, and print something. Okay, now let's make another class. So what we did was we created a class called Homo sapiens, and now we are creating a class called man, which inherits the attributes of Homo sapiens, and we say create a function which is specific to man. So Homo sapiens has a function which called speak, and man has a function called talk. And let's print it. Now let's create an object of man. Now what does this signify? The man class is also inheriting whatever is there in Homo sapiens. So man can even talk and he can even speak, right? So what we are going to do is first we are going to execute the function speak. So the base class function got called speak, and it is printing Homo sapiens speaking. And also we can call the child function man talking. Okay, so if you see, this is the basic difference which we want to highlight, that just you have created the object only for the child class, not the parent. So now by making the object of the child class, you can invoke the parent class function as well as the child, because the child has inherited the parent features. Now let's take an example of multi-level. So we will continue from our previous example. We will create a class Homo sapiens, define an function speak, and print. Now we will make another class man. Now we are saying man can walk. So we are saying man walking. Now this is the third level. This is the multi-level. Man child, and we are saying that a man child can eat. So ultimately, the man child can speak, can walk, can eat. All three operations can be performed. So we are going to make an object of man child, and now Python will allow us invoke walk function, speak function, and eat function. So this is a typical example of multi-level hierarchy. Now moving to our next type of inheritance, which is the multiple inheritance, where the child is deriving attributes, properties from two parents. So we will now create a class called calculation1 in our example, and let's make a function sum, and it will return a calculation x plus y. Second, calculation 2, and let's create operation subtraction, and it will return x minus y. Okay. Now we will create the derived class, which is inheriting both calculation 1 and calculation 2, and let's create its own function called multiplication. Okay, so derived class now has a sum function, subtraction function, and multiplication. Okay, so let's create an object for derived, and now let's invoke the relevant functions. So sum 120, subtraction, it should say minus 40, and multiplication 1000. So if you see, it's different from multi-level, it's multiple. It means that the child class has inherited from two parents its relevant functions, right? And that's how we are able to call them in the derived class. Now let's take another type, hierarchical inheritance. Okay, so in hierarchical inheritance, let's go back to our example of, first we have the black and white TV, and we will create a function called antenna. Print channels are telecasted through antenna. Then we will create color TV, and we will define its own function called cable connection, plus it has inherited the function called antenna from black and white TV. Here it is. Okay, now we are going to create another class called as Wi-Fi LED TV, which is also inheriting from black and white. Now in this we are defining Bluetooth tethering function. Okay, and let's make another smart TV. Okay, and then we are gonna, you can watch Android applications on OTT platform, right? So this is the class of smart TV. Okay, so what we have done eventually over here is we have created a black and white TV. Color TV also inherits from black and white TV. Wi-Fi LED also inherits from black and white TV. Smart TV also inherits from black and white TV. Okay, now let's try to create the relevant objects. We will first create an object of color TV, then we will create Wi-Fi LED TV, and then we will create smart TV. Okay, now we will have the relevant functions available to invoke. So both all the children objects now will have an antenna function, A1, A2 and A3. All three are having the antenna function, so we can just try to print it. Okay, and then we can invoke the relevant child functions, A1 cable connection, Bluetooth tethering and Android applications. So if you see, this is an example of hierarchy. You have color, Wi-Fi, LED and smart TV all inheriting the black and white TV features and its own features. Okay, now along with this concept, let me just also introduce some relevant concepts which are applicable along with the inheritance concept, which will be helpful. I also want to show you the example of init function. Init function is a constructor in Python language and it is called by default whenever you instantiate an object. So let me give you an example over here. So here you have a class person and we are just defining the init function, the constructor. Okay, and we are just defining certain attributes, instantiating certain attributes in the person, first name and the last name. And another function which I am calling is the print name. And I'll print the name. It's a straightforward function. Okay, so what I'm doing is I am creating a child class now called as student, which is inherited the features, attributes of the person base class, and I'm also making a constructor for student, and from student I am invoking the constructor of the person class, right? So now if you see, I'm going to make an object of student and initialize it with the self, the first name and the last name, and eventually the parent class init function is being called, first name and the last name, and this function def print name, it will print James Anderson, right? As I have already initiated the parameters. Okay, so if you see now, what have I done? I have the attribute values in the parent class are getting printed by invoking the constructor of the child class. So what happened when you invoke student? By default, this init function got invoked. The parameters of James and Anderson got passed. Then from person, you invoke the constructor init. And here now, the first name and last name got initialized and then it got printed. So this is the basic feature of a init function. Now, like the way I have called person dot init over here, I can also make a call to super. There is a keyword called super keyword. So let's just take an example of super keyword. Okay, let me have my child class like the previous one, parent class, the person class, and I'll have to just make a change in my student class. In the init function, instead of parent dot init, I will call super dot init. This is the keyword super function, which will always invoke the parent class, gives you the handle to the parent class, and then you can invoke the relevant method, and the invocation methodology will be the same, and you can check the output. It's going to be the same, but it's that the syntax is different. There is another keyword which is available for you to invoke the parent. So you don't need to know the class of the parent. You can just make a call to the super. Now let's also take a look at another utility function called is subclass, right? So what we are going to do is we are going to create a function calculation1, calculation2. Okay, so we have created two classes, calculation1, calculation2, independent classes, no one inheriting each other. Now we are going to create a derived class. Now this is the example what we had done earlier, very similar to multiple inheritance. So we are just actually recreating a multiple inheritance example. Okay, so you have a derived class which has multiple inheritance from calculation1 and calculation2, summation, multiplication and divide. Relevant functions are there. Now we will check which class is a subclass of which one, right? So let's create an object of derived. Now what we want to print is that whether derived is a subclass of calculation2, and it should return true. And let's see, another is calculation1, a subclass of calculation2, it should return false, right? Because these two are independent classes. So is subclass is another function which is available in Python, which helps you decide, you can check whether which is a derived class and which is not a derived class. Next, let's take an example of another function called isInstance. Okay, we will take the same set of functions, create an object of derived, and check whether the object D is of which, is it of a instance of class derived or not. It's true. So instead of derived, if I make it as calculation2, for example, now if I say C equal to calculation1 and say C is instance of derived, it should say false. But if I say calculation1, it should say true. And if I say calculation2, should say false, because calculation class is an independent class D is a derived class from calculation 1 and calculation 2. So basically D is instance of both calculation 1, calculation 2. So it will always return true. We are going to talk about what is a Python iterator, what are iterables, right? What are the iterable objects, how an iterator works, and then we will also discuss about how to throw a stop iteration exception. Basically, when you reach the end of a list, then you can throw a stop iteration exception, and we will see that with an example. Now, what is a Python iterator? Python iterator is an object that can traverse through iterable objects in Python like lists, tuples, dictionaries, sets, and returns data one element at a time. So basically you can traverse through these lists one at a time, and then you can use it as per your custom requirement. But iterator as an object is available to you, is a tool available to you in order to traverse through each and every element. Now, they are implemented within for loops, comprehensions, generators in Python implicitly. They are not visible upfront, but they are hidden in plain sight. So basically, when you're using loops, when you're using generators, comprehensions, implicitly Python is actually converting them in the backend in an iterator object and giving you the results. Now, what are iterables on which you can iterate? Lists, tuples, dictionaries, sets, as I mentioned, are all iterables or iterable objects. Other than these, you can't perform any iteration. If you have not created an object of list, tuple, or dictionary or set, then of course your iterable will not be of any use. And these objects internally possess an iter method, iter method, which is used to get an iterator, a handle to an iterator, and then you can start looping it, or you can start accessing the elements of the iterator. Now, how iterator works? Python iterator implements internally these two methods which you are seeing on the screen, underscore underscore iter underscore underscore brackets and underscore underscore next underscore underscore brackets. Now these two methods are implicitly implemented by Python for any internal implicit iterator object. But if you have to write your own custom iterator, then you need to override these methods, and I'll show you in my examples in Jupyter Notebook. The iterator object is initialized using the iter method. So basically, whenever you have to create an iterator object, you need to initialize it with iter and then use next method in order to traverse through it. Now, stop iteration exception. So as I mentioned, when we reach the end of an iterable, right? Like suppose you have a list or a set which has a length of 4. When you have ended the fourth element and you're trying to access something beyond fourth element, which is fifth, then of course you can implicitly raise a stop iteration exception, or Python will throw it. So we will see that with an example, but you will get a stop iteration exception. Now, so to prevent, in order to handle it or manage it in your code, we use stop iteration statement to raise an error. You can raise your custom error. So you can catch this exception and then raise your custom error in the underscore underscore next method. So now let's support everything with our examples. Let's start with a very basic example of an iterator. Now let me create a list with just 4 numbers, and as I said, I'm going to initialize my iterator with iter method. So now I have created a list and now I am initializing it with iter. Okay. Now using next, I'm going to print my first element 4. Okay. So it means the iter internally has given me handle to the first element, and now as many times I move print next, I am moving to the next element. So now I'm also going to show you a different syntax. This is a syntax, but the output will be same. It's a different syntax to invoke underscore next. So its output is going to be same, but the syntax is only the difference over here. So you're going to get access to the next element and then my fourth element, which is 33. Now I have traversed through all my 4 elements. Now what will happen if I again do next? I am at the end of my list. So I'll get an exception of stop iteration, right? And this is thrown by Python. Now let's take another interesting example. If I want to perform iteration on strings. So I have created a variable and I have initialized it with geeks. And now I have created an iterator on top of this string variable. And I'm going to traverse it till the time I reach the end of my string. So let me iterate it, and I'm going to iterate till the time I get the stop iteration exception. So also I'm explaining here how to cleanly handle the exception, accept, and then break. If I get the exception, I'll break out of this program. And here you get the result. All the letters of my string geeks has been printed individually. And I think it's a very important example, interesting example, that how a string has been converted. Now, point to be noted over here is that Python has internally invoked underscore underscore iter and underscore underscore next methods, which it has implicitly implemented for string iterators. So you don't need to do anything. Now let's take another example to how to traverse through a list using for loop. So I'm going to leave for object in list and just print the list. This is without an iterator. I'm just printing my list. So I'm just trying to show the difference that if you use an iterator or you do not, but how you can access the elements in the list. Now let's take an example of how I can write my own custom iterator. Okay, so I'm creating a class where I'm overriding the init method, basically initialization of my class, where I'm going to initialize a variable max with 0. And then I am overriding, this is the most important point over here, I am overriding iter method. And then I am writing another overriding the underscore underscore next method, where I am adding 6 to my number and then incrementing my loop so that I can move further. So in this underscore next method, I am just moving beyond adding 6 and till the time I reach the max variable. So when I'll invoke my class, I'm passing 9. So it means that I should not go beyond 10. Basically, I should start my iteration from 6 and will not go beyond 10. 9 plus 1. So I should get numbers which are between 6 to 10 as per my expectation. Now before we diagnose the output, most important point is that how you have converted your class to an iterator over here. In order to make a class an iterator, it is mandatory you override iter and next methods, which you have done over here. So now let's print. Okay, so 6. So my number started with 0, initialized with 0, and I added 6 to it. So my first result is 6. And now if I keep printing, I will get one value incremented. 7, 8, 9, and 10, right? So this is the expected output, right? Now another example on the same lines, I'm going to print the first 20 numbers using my iterator. So I am going to override the iter method and underscore underscore next method, my numbers. Now in this underscore underscore next method, I'm just incrementing my number by 1, not by 6, and I'm going to stop at the limit 20. So like I showed in my previous example, I'm going to initialize first my class and then initialize my iterator, and just then gonna run a for loop on it. And here is the response output. I have printed the first 20 numbers because I have created this limit. So I'm initializing with 1 and going till the max 20 number. But the point is, it's not the output which is more important over here. The most important concept over here is that you have created your own iterator and leveraged it. We will talk about what is a generator in Python. We will talk about the advantages of using generators and the utility of the next function, which allows us to operate with generators and print the values within the generator. So we will see all these concepts with an example. Now, what is a generator in Python? Python generators lets you create your own iterative functions that return the traversal object with a sequence of values. So basically, when with iterators, you can only work on list, tuples, or sets, but with generators, you can convert your functions into iterative functions itself. And we will see that when we will be working on a Jupyter Notebook. Now, another important feature in a generator function is that a yield statement is used rather than a return statement. So basically, the return statement terminates a function entirely if you use it within the function and basically return from the statement, while the yield statement pauses the function there it is and holding all its states, all its variables, the values in the variables, and then continue thereafter on the successive calls. So basically, in a generator function, you use yield functions, and I will talk about the utility of this yield statement within the generator function, how it helps in generating pipeline. But just to hold a thought over here and understand the concept, the yield statement basically holds the processing of the function at that point. And if you make an invocation of that generator function again, it starts from there itself where you left it. As compared to return statement, return is a general exit. If you make an invocation of the return statement from a function, it will restart again from the beginning if you invoke it the next time, and that's the basic difference. So what are the advantages of using generators? It's very easy to implement. The code syntactically it's very simple. Within a few line of codes you are able to achieve the functions and able to implement the logic. You can generate infinite sequence. You don't need to provide the range values, the starting and ending. You can generate an infinite value, and I'll show you that with an example. And generators are very memory efficient. They are the most memory efficient ways of processing huge data sets. They process the data incrementally and do not allocate memory to all the results at the same time. They do that incrementally. They really come in handy when implementing data science pipelines for huge data sets in a resource constrained environment where you have constraint on the RAM and the other resources of the hardware. Now, another biggest advantage is pipelining with generators. Generator pipelines are a great way to break apart complex processing into smaller pieces when processing list of items. So basically you can break your complex code into smaller pieces and then invoke them as a generator recursively, and we will see that how. But basically, you are making the complex code look simple and making it invoke in a pipeline fashion. Now, the another most important function in order to deal and operate with the generator is the next function. The next function is used to retrieve elements from a generator object and then print it. So that's how you basically interact with your generate function. You cannot do that until unless you don't use next function. So now let's quickly jump to our examples which we are going to support for each of these concepts. Now let's start by basically creating our first generator function. I'm going to create a variable n and initialize it with 1, and I'm going to do a print. This is just for my logging and showing on the console that where we have reached, and then I'm going to say yield n. Okay, so now here we are not exiting the function, we are just saying that just this is the point. If you invoke the function again, the function will start from this point on. Now here you will increment, and again this is the second checkpoint in the code, and similarly this is the, we're gonna have a last checkpoint in the code. Now in order to create my generator, now this is the my generator initialization, my gen. Now if I use the next function and invoke my generator, now my generator has been executed till this point, right? N equal to 1. Now if I make a second invocation, now it has moved ahead and printed the second. So it is behaving like a loop. It is now behaving like a loop. It is behaving like an iterator. But I have not created any list. I have not created any tuple, but I am basically traversing through the variables, through the sequence of the variables within my generator. And if I again print it, this is my last, this is printed at the last. So all the checkpoints within my generator have been executed. Now the same example which I have over here, let me call it in a loop. Okay, so what I'm going to do is I'm going to remove these invocations and just replace it with a loop call, right? So this generator functions remain as is. Now instead of writing my next function 3 times, I am going to just invoke my generator in the for loop, and this will get invoked the number of times I have yield in my generator, and my output should be the these logs which I have created, and of course the variables. Yeah, so see now what has happened is now the output is all these 3 print commands have been executed, plus the variable values of n has been printed at each checkpoint 1, 2 and 3. So when I initialize my item variable during the for loop, this item consists of the variable values which are there in my generator. Now I'm going to show you example of if I use a return statement in my generator. So I'm going to create another generator and provide a value. Now during this, in middle of this generator, I'm just invoking return, and then I am printing my second checkpoint and then the last checkpoint. Now I'm going to initialize my generator. Now if I invoke my first element of the generator, I'll get it. There's no problem because I printed the first item, I got the value of my yield, and then I returned. But now if I invoke my second element in the generator, but before invoking second, I have already given the return statement, my generator will exit and I'll get the stop iteration error. Now this is a Python generated exception which is denoting that you cannot move beyond the first item because you have returned from the generator over here. So that's the difference. If you just remove this, comment this out, and then run it, you will get your second item. So it's not the code exits if you write return over here. So I hope you're able to understand the difference. Now let's take another example. Now here we are going to create a list, and how implicit list, like the legacy way we have been creating in Python, differentiates like the way we are creating a generator. So what I'm doing is I'm creating a list with random numbers, and then another list in which I'm just square rooting the numbers in that list. And similarly, I'm also creating a generator which I'm expecting the same output in the new list as the generator, but I'm going to show you different ways of traversing the generator as compared to a list. Now, if you see this list underscore, if I just make a print call to this list, it's going to straightforwardly square root the numbers and give me the output 4, 9, 64, and 100. But if I print the generator, I will not get the expected output, what I'm expecting. I will just get the generator object, which is not what I desire. So basically, you can't just print the generator like the list. You have to either use the next, or you have to use the for loop, which I had shown earlier, and print each and every item within the generator. Now, this is the output which I was expecting. I was expecting the line by line output of each and every element in my generator: 4, 9, 64, and 100. Okay. Now, this for loop is taking care that it is not exceeding the number of items, the length of the items in the generator. So this is automatically taken care by this syntax. But if you don't take care of it, then you will get an exception. Let me show you another example. If I create a list, and now I'm creating a generator which is square of all my elements. So now one by one, instead of the loop, I'm one by one printing the output. Second output, third element output, fourth element output. Okay, I have 4. Now if I try to again print, I'm exceeding the length of the list, I'm going to get an exception, stop iteration exception, because I'm exceeding the length, right? Either I use the for, or if I'm using individual print and next function, then I have to take care that, okay, how many elements are there in the list, and I cannot exceed beyond that, else the Python will raise an exception. Okay. Now I'll show another example of highlighting the difference between next and the for loop printing. I'm going to create a generator for 2 to the power n. So I'm initializing n with 0 and then just raising it 2 to the power n. Now here I'm initializing my generator and printing it. And I'm getting the expected output as 2 raised to the power 0, 1. Okay. Now another way of doing this job is I loop over this and I get the same output. So if you see, it's only, I do not have only one element. So either you use for loop or you print using next, the output is going to be same. Now, another important concept which I talked about, if you want to print infinite numbers, so, or you want to do some infinite calculations, I'm going to use print in all even numbers. So I'm gonna write a generator which is gonna print infinite number of even numbers. So I have created a generator, and now I'm going to invoke this. And mind you, I have to kill this job because it's going to keep running. It's going to keep running because it's constantly generating the numbers, even numbers. So I would have to stop this. But if you see, otherwise this is not possible. In any for loop, the basic for loop, you have to give a range, start and end of the length. But using a generator, you can do infinite looping. Right, because here I had to kill this job, I have to do a keyboard interrupt. Now I'm going to show you an example of how you can use generators for creating a pipeline. So I'm going to take example of Fibonacci series, create an example of Fibonacci, two variables initialized with 0 and 1. And now I'm going to write the logic of Fibonacci, adding the two numbers to itself subsequently. And I'm going to add yield. Now this is my generator. This is my one generator, and I'm going to create second generator of square. So I'm going to show you in Excel what logic I'm going to apply and what will be my expected output. So I am now squaring the numbers which I'll get out as an output of Fibonacci. Okay. Now I'm creating a pipeline like this. First, I'm going to generate Fibonacci series for the first 10 numbers. Then I'm going to find the square of each of the Fibonacci numbers and add it. So if you see this representation in Excel, I'm going to generate, these are the two variables which I've already initialized, X and Y. And from here on, these 10 are my first 10 Fibonacci numbers. I'm going to calculate the square of these numbers 1, 4, 9, 25 and till 55, the square of 3025, and then add these numbers and I should get the output of 4895. So if you see, one function generator, second generator, and the third calculation. Now this whole has been done in one single line of code. You have created two generators and just invoked them in a single line pipeline. So entire looping, and you don't have to write the looping operators, the for loop, and you don't have to worry about writing all that complex logic. It is all encapsulated within this. Now let me run, and I'm going to expect this output 4895, and here is my output, right? So in the hindsight, what Python has done is it has generated these Fibonacci numbers, found the square of these numbers, and then added it in single line. And now this is the convenience, simplicity, which I was talking about earlier. Now let's take another example of Fibonacci. I'm going to create a generator again, initializing A and B with 0, 1. And this time I'm taking an example of printing the Fibonacci in two different ways. Okay, I'm going to print the first 5 Fibonacci series number. The first way I'm going to do is I'm going to print the next function 5 times because I'm generating 5. So let me run this. These are the first 5 Fibonacci numbers 0, 1, 1, 2, and 3. And I'm also going to use a loop in order to print. So now in the loop, I'm invoking the 5 Fibonacci numbers and run it. So either you can make 5 individual calls, or you can use the for loop, but the output is the same and you're using a generator.
So what is string formatting in Python? Formatting a string is something you will do all the time when you're coding in Python. String formatting, also known as string interpolation, is the process of inserting a custom string or variable in predefined text. The string formatting methods format the given string into a more precise output in Python. So it is the process of infusing things in the string dynamically and presenting the string. Now let's look at the different types of string formatting in Python. First one we have is using the modulo operator. So Python uses C formatting style string formatting to create new formatted strings. Python does that with the help of the modulo or the percentage sign. This is the old way of formatting strings. This approach was more often used in Python 2. So let's head out to a Jupyter Notebook and see how this works. So this is my Jupyter Notebook that I'm going to use for our demo. So let's start with our first example, that is formatting a string using the modulo operator. First I'll create a variable called name. Let's see, the name is Sean, and I have another variable which has the age of Sean, let's say 32. Now I can create a variable called string equal to, I'll say hi, then use the modulo operator followed by s, and I'll give an exclamation mark, give a space, I'll say percentage name, and then let's print the string. If I run this, we have the output hi Sean. So what I did here was, we have defined the variables that we want to format into the strings. Then we have created the string with the placeholders for the variables. So this is a placeholder. Now the percentage s format specified here tells Python to substitute the value of the name. So hence we have hi Sean printed. Now let's see another example. This time I'll directly use a print statement. I'll say I like to, then I'll say percentage s or modulo s chocolate ice creams. I'll give a full stop, and then using my modulo operator I'll pass in my value, that is eat. So here percentage s will be replaced by the value eat. Now if I run this, you have the message here, I like to eat chocolate ice creams. Now you can also add multiple strings at a time, and you can use variables to insert objects in the string. Let's see one more example. I'll say string equal to, say percentage s is, I'll say percentage d years old. Then I'll give a percentage symbol and say name comma age, and let's print the string. If I run this, you see here above we had defined the variables name and age to be Sean and 32. So here percentage s is for name, so Sean is, percentage d is for age, so Sean is 32 years old. So in this example, percentage d format specifier tells Python where to substitute the value for age, and it is represented as a string. So percentage s is used to inject strings. Similarly, percentage d is used to inject integers. So here 32 is an integer, and you can also use percentage f for floating point values, and you can also use percentage b for binary format. Alright, now let's see another example. Let's say I have a variable called x which has a value dance. I'll say print Nancy can, I'll say percentage s and percentage s2. After this, we'll specify the parameters, let's say x and sing. If I run this, you have the output Nancy can. So here percentage s is for x, which means dance, so Nancy can dance, and percentage s is for the second parameter, which is sing. So my result becomes Nancy can dance and sing too. Now similarly, we can have another example using percentage f. Let's say I'll say print the value of e is. Now I'll specify my format, which is going to be, let's say percentage 5 dot 2f, close the quotation, and then I'll pass in my value for e. Let's say 24553 dot, I'm just taking random floating values, 718281. Now if I run this, you see the result. My value for e is 24553.72. Now let me tell you what 5.2f means. So here 5 would be the minimum number of digits to be present in the string. These might be padded with white spaces if the whole number doesn't have this many digits. And here 2f represents how many digits are to be displayed after the decimal point. So after the decimal point we wanted only 2 digits, so we have rounded it up and the value is 72. Alright, so coming to the next type of string formatting in Python, we have formatting with the format string method. So Python string dot format method was introduced in version 2.6. Now there are two ways to do it. One is using positional arguments and the other is using keyword arguments. So let's head over to our Jupyter Notebook and we'll explore a few examples on this. Before that, let me just give a few comments. So the first one we saw was using modulo operator. Now the second one is not an operator. This time we are going to use the format method. Cool.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So under format method, we'll use empty placeholder and replace them with a string value. So I'll write a print statement. Let's say my message is welcome to. Now I'm creating one placeholder which is empty, you can see here, and let's say after that I have tutorials. I'll give a full stop and then we are going to use the format method, and inside the format method we are going to pass in the value, let's say Simplilearn. So this Simplilearn value will be substituted in this empty placeholder. Let's run it. You can see the result. We have welcome to Simplilearn Python tutorial. So this empty placeholder was replaced with a string value, that is Simplilearn. Cool. Now moving to the next example. So we'll be using index or positional arguments inside the placeholder. Let me create a variable called s1 and I'll type in a message. Let's say my message is I'm using my first placeholder and I'm giving a position or an index. Now in Python you must be aware that the index starts from 0. So I've used curly braces and passed in 0. I'll create another placeholder and this time I'll put index as 1. Let's say my message continues like this with Simplilearn, and then we'll use the format method and we'll pass in the values for these two placeholders. This should be width. Let's say my value for the 0th index is learn and my value for the first index is upskill. I'll go ahead and print s1 and you can see the output. Let's learn and upskill with Simplilearn. So here the 0th and the first index were replaced by learn and upskill respectively. So this is how you can use index or positional arguments inside the placeholders. Now you can also add index numbers into the placeholders to reorder values. Now this will affect the order in which the method replaces the placeholders. Let me show you. So I'll create a print statement. So let me create my first empty placeholder and then I'll continue with my message. Let's say called. Then I'll have my second placeholder and I'll continue with my message to inform that. Then I'll have my third placeholder will be absent. Okay, now let's use the dot format method and we'll have the values for all the three placeholders. Let's say my first value is Luke, my second value is Dinah, and my third value is John. Now if I print, okay, there is some error here. Okay, there has to be another bracket here. Now if I run it, you can see the message here. So the first placeholder was for Luke. So Luke called Dinah, which is my second value, to inform that my third placeholder's value, that John, will be absent. Cool. Now you can add index numbers into the placeholders to reorder the values. Now let me show you how to do it. I'll just copy this message and I'll print it here. And here I can now pass in my index values. Let's say I'll add 2, 0 and 1. So here Luke is for 0, Dinah is for 1 and John is for the second index value. Now if I run it, now you can see the difference in my message. So here first 2 comes, which means John called the value at 0th index, which is Luke. So John called Luke to inform that Dinah will be absent. Alright. Now let's see one more example. This time we'll be using name or keyword arguments inside the placeholder. In the earlier examples we saw how to use positional arguments or index. This time we are going to use name or keyword arguments inside the placeholders. So I'll create another variable called s2 and I'll have my message, let's say v. In my first placeholder I'll have the keyword as a, then I'll have my keyword as b. My message will continue. I'll have my third placeholder as c with Simplilearn, and then we'll use the format method, and then I'm going to pass in my keyword arguments. So here we have to assign the value for a, b and c. So let's say the value of a is learn, for b let's say it is upskill, and for c let's say the value is grow. Now we need to print s2. If I run it, you see the message here. We have v learn, upskill and grow with Simplilearn. Let's say we'll replace v with let's, so the message is more appropriate. So now you can see let's learn, upskill and grow with Simplilearn. So this is how you can use keyword or name arguments inside placeholders in the format method. Cool. Now let's look at the third method. We have formatting with string literals called f-strings. So strings in Python are usually enclosed within double quotes or single quotes. To create f-strings, you only need to add an f before the opening quotes of our string. So this type of formatting is also called as a formatted string literal. Now when you use f-strings, you need to display variables. So for that you need to specify the names of the variables inside a set of curly braces, and at runtime all variable names will be replaced with their respective values. So let's go to our Jupyter Notebook and we'll see a few examples. Alright, now let me give a comment as f strings. Okay, so let's see our first example under f strings type. So I'll say tutorial equal to Python, then I'll have another variable called subject which has the value programming. Next we have place equal to Simplilearn, and then I'm going to use a print statement, and then I'll use my f keyword for f strings, and I'll say my message as let's learn. Then using curly braces I'll pass in my variable name that I have defined here. First is tutorial, then we have subject from, then I'll have the place. Let's give a full stop and we'll close the double quotes and let's run it. So here you can see we have our message, let's learn Python programming from Simplilearn. So here tutorial and subject were replaced by Python and programming because we have defined tutorial as Python and subject as programming, and place we have a Simplilearn, and hence my message is let's learn Python programming from Simplilearn. So this is how you can use f strings. So when using f strings to display variables, you only need to specify the names of the variables inside a set of curly braces. Now you can also evaluate expressions with Python f strings. Let's see a simple multiplication. I'll create a variable called n1 which has a value of 60. Let's say n2 has a value of 12, and I'll use my print statement. I'll give my f keyword for f strings. I'll say the product of, then I'll create my placeholders n1 and next placeholder is n2 is, and then using curly braces I'll do a multiplication operation, that is n1 multiplied by n2. I'll close my double quotes. Let's run it. So you can see here the product of 60 and 12 is 720. Let's say I'll make it 10 and 40. If I run it, the product is 400. Cool. Now you can also use f strings in conditional statements. So you can use conditionals in Python f strings. Let's see an example. I'll create a variable called num which will have a value, let's say 55. Then I'm going to use a print statement and use my f letter, and then I'll pass in my message is number even, give a question mark, then using curly braces I'll have my placeholder as true if num modulo 2 equal to 0, else display false. I close my double quotes. Now let's print it. You see here is number even, the output is false because 55 is not even. Let's say I'll make it 50, and if I run it, is number even, the value is true because 50 is divisible by 2 and hence it is even. Alright. Now coming to the final type of string formatting in Python, we have formatting with string template class. Now template strings are provided as a class within the string module of the Python library. It is imported as a module and the dot substitute method is used to replace the placeholders. Now the format uses placeholder names formed by the dollar symbol with valid Python identifiers. Let's go to our Jupyter Notebook and we'll see two examples on this. Alright, so this is the final section of our demo. Let me give my comment as template string. Okay, so first and foremost we need to import the template module. So I'll say from string import template. Now let me first run it. I'll create two variables. The first variable is a1 which has a value of Python. The next variable is a2. Let's say the value is Simplilearn. Then I'll create another variable called n which will have my template function, and inside the function we'll pass in our message. Let's say hello, welcome to. Now I'll use my dollar sign and say, let's say n1 programming. So this is my template that I'm creating. By, again I'll say dollar n2, give a full stop. Now I'll say print n dot, we are going to use the substitute method. So I'll say substitute n1 equal to a1. So here I'm going to replace n1 with the value of a1, and then I'll say replace n2 with a2. Alright, let's run it and we'll see the result. There you go. So here my output becomes hello, welcome to. Now N1 we have replaced with A1, so hello, welcome to Python programming by N2. Now N2 we have referred to A2, so it becomes Simplilearn. So hello, welcome to Python programming by Simplilearn. Now let's see our last demo. Again, this is on template strings. So I'll create a variable called stu_name, which essentially stands for student name. Let's say the name of the student is Johnson. Then I'll create a variable called s, and I'll use the template function or the method. I'll say hey, using the $, I'll say name, how are you? How are you? Followed by a question mark. I'll say s dot substitute. I want to substitute this $name with stu_name, which has Johnson. Now if I print it, you can see the message here, hey Johnson, how are you? Great. So that brings us to the end of our demo session on string formatting in Python. What is scope in Python? So scope in Python is the area or the region of a program where you can access variables, functions and objects declared. The scope defines the accessibility of the Python object. So the objects cannot be accessed from anywhere in the program. Variables are not visible to the entire code, so their visibility can be restricted. Now scope verifies which variable to be accessed. A variable declared inside a function belongs to the local scope of that function and can only be used inside that function. Now whenever you use a name such as a variable name or a function name, Python will search through different scope levels or namespaces to determine whether the name exists or not. So Python resolves names using the LEGB rule. The LEGB stands for local, enclosed, global and built-in scope. Now talking about local scope, the variables which are defined in the function are called local scope of the variable. So these variables are defined in the function's body. Now talking about enclosing scope, now this scope only exists for nested functions. If the local scope is an inner or nested function, then the enclosing scope is the scope of the outer or enclosing function. Coming to global scope, the variable which can be accessed from anywhere in the program is known as the global scope. Such variables can be read inside or outside the function. Now the global scope is often implemented when we want to use the same variable name in the rest of the program. Coming to the final rule, which is B, that is built-in scope. So if a variable is not defined in local, enclosed or global scope, then Python looks for it in the built-in scope. Now this scope contains names such as keywords, functions, exceptions and other attributes that are built into Python. Now if you define the same variable name inside and outside of a function, Python will treat them as separate variables. So two separate variables, one available in the global scope that is outside the function and the other available in the local scope that is inside the function. Now let's head over to our Jupyter Notebook and we'll try scopes in Python with hands-on demonstrations. Alright, so I'm on my Jupyter Notebook. Let's start with our examples. First we'll look at local scope in Python. For that, I'm going to create a function called fun, and inside the function I'll create a variable called s, which holds, let's say, an object called Simplilearn, and then I'm going to print the variable that is s. Now in this case I have defined my variable inside the function, so this becomes accessible only inside the function. Now if I call the function using the function name that is fun, and if we run it, you can see we have the message printed that is Simplilearn. Now we'll see another example. So suppose we'll try to access it outside the function, it will throw an error. So I'll just give a comment, try to access it outside the function. Alright, so again I'll create a function called, let's say, fun1. I'll give a colon, and here I'll say, let's say, s1 equal to Simplilearn, and now I'll give a comment here, print s1. Then I'll call my function fun1, and I'll try to print the variable s1 outside the function. So here s1 has a local scope since it is defined inside the function, but I'm trying to access the variable outside the function. Let's run it. You can see the error here, name s1 not defined. Now if I give a comment and run this, you see there is no message, and let me just remove this comment and print it. You can see we have the s1 variable message printed, that is Simplilearn. So this is how the local scope of a function works. Now let's see an example of enclosed scope, which is function inside another function. So I'll create a function, let's say func, and I'll use the variable this time s2 equal to Simplilearn, and then inside the func function I'll define another function, let's say infunc, which basically stands for inside function, and then here I'll say print s2, and we'll call the inner function, that is in func, and then I'll call the outer function. Let's run it and see the result. You can see here we have the message printed Simplilearn. I'll just edit this message, let's say welcome to Simplilearn. Now if I run this, you can see we have updated the message here. Now for the enclosed scope, you need to define an outer function enclosing the inner function like we did here, and you can also comment out the local variable of the inner function and refer to the variable using the non-local keyword. Let me show you an example around this. Suppose I have a global variable called msg. I'll say this is a global scope message. After that I'll create a function, so I'll define a function called outer, and I'll use the same variable name, that is msg, and my message would be this is an outer variable. After that I'm going to define another function called inner, and this will have the same variable, that is msg, and my message would be inner message variable. Now as I mentioned before, I need to comment out the local variable of the inner function, so I'll just comment this out, and then I'm going to say non-local, which is the keyword. So I'm referring to the variable using the non-local keyword. I'll say non-local variable name, that is msg, and now I'll print msg. We'll come out of the function and we'll call it inner. After that we'll call the outer function, and then I'm going to print. I'll just scroll this down and we'll say msg. So here what we are doing is, so this is an example of an enclosed scope, so where we have defined the outer function enclosing the inner function, and we have commented out the local variable of the inner function, and we are referring to the variable using the non-local keyword. Now let's run it. You see here I have my two print statements working here. The first one is, this is an outer variable, you can see here, and then I have print MSG, so this is a global scope message. Cool. Now we'll see an example of how the global scope works, though we have already seen an example above. So this was an example of a global scope. Now we'll see a few more examples around global scope again. Suppose I have a variable called s3 equal to, I'll say Simplilearn, and then I'll declare a function func1. I give a colon and then say print s3. Now I'll call the function func1 and will print it s3. If I run it, you can see here I have Simplilearn printed twice, so I have used the same variable name s3 inside the function. So this Simplilearn is for the local scope s3, that is this one, and outside the function we have printed s3 again, so Simplilearn twice. Alright, now let me show you another example about using the global scope. Create a variable msg1. Let's say my message is welcome to Simplilearn Python programming. I'll define the function func2. I'll give a colon and I'll use the same variable that I used or declared above, that is msg1. I'll say this is the inner msg1 variable. Then I'm going to print msg1. After that I'll call my function func2 and I'll print msg1. If I run this, you can see I have the two messages printed. First is, this is the inner msg1 variable, and the second print statement will print the global variable message, that is welcome to Simplilearn Python programming. Cool. Now you can also use the global keyword inside the function to convert a local scope into global scope. Now I'll just give a comment using global keyword. So I'll define my function func, let's say 3. I'll give a colon, and using the global keyword I'll say s, and I'll say s equal to Simplilearn. Now let me call func3 and will print s outside the function. Now one thing to remember here, my variable has been declared inside the function, but since before declaring the variable I have assigned the global keyword to s, so this now becomes a global scope variable, so you can access it outside the function as well. Now if I run it, you can see it here. I have my message printed Simplilearn. If I say hello, you can see it, hello printed. Cool. Now we'll see another example of using the global scope. Let's say I have a variable called a1, which is India, and then I'll create a function called my country, and I'll use the global keyword and say a1, and after that I'm going to say a1 equal to, I'll change the country to, let's say, France. Now let me call the function my country and will print a1, and you can notice the difference in the result. So here initially I had defined India as a global variable, and after that I'm assigning the same variable name with a global keyword, and hence it will take the updated value for A1, and you can see here the result is France. Now finally let's look at built-in scope in Python. This is the final example in the demo session about scopes and arguments in Python. Cool. So this example is a bit different from the previous few examples that we saw on local scope, enclosed scope and global scope. So here I'm going to import pi from the math module. So I'll say from math import pi. So this example includes global scope, enclosed scope, as well as local scope, and of course we have the built-in scope as well. Now what I'll do is, first I'll give a comment and create a variable called pi equal to, I'll say global pi variable. I'll say this is a global pi variable, and then what I'll do is I'll say df. Let's do one thing. First of all, we'll remove the comment, and now I'll create a outer function. I'll give a colon and say the variable pi, I'll say outer variable pi, and then I'll create a nested function with the name inner, and I'll say pi equal to inner pi variable. Now I'm going to say print pi, and after that I'll call the inner function, and next I'll also call the outer function. Now if I run this, you can see the result, inner pi variable being printed, which is this print statement. Now what I'll do is I'm going to comment out the global scope variable, and I'll also comment out the first outer function variable that I defined. I'll comment this out, and I'll also comment the inner function pi variable. Now if I run this, you see the result here. It prints the value of pi that was imported directly from the math module or the math library. So here pi is not defined in either local, enclosed or global scope. So the built-in scope is looked up, that is the pi value imported from the math module. So this is an example of built-in scope in Python that uses inbuilt functions, modules and objects that are available in Python. Alright.
Let's glance at the topics. Object-oriented programming in Python, some major principles of object-oriented programming, and then we will touch upon topics like class in Python, objects, methods, inheritance, the concepts of inheritance, the different type of inheritance, then the definition and examples of polymorphism, encapsulation and abstraction. So all these topics will be supported with examples and the relevant terminologies and definitions. Now, what is object-oriented programming? Python is an object-oriented language like any other programming language like Java, C++, and the object-oriented programming language concept is not new, and each and every mature programming language has these concepts imbibed in it. Now, the concept of object-oriented programming in Python focuses primarily on creating project objects and making reusable codes. So whenever we start programming at a large scale or for a big project, it is very important to identify the objects within that particular project which you want to define. Now, for example, in this presentation, what you are seeing is that we are covered with full of objects like car, dog, tiger, tree, or a balloon. So these are typical examples of objects which you encounter in day-to-day life. Now, what are the major principles of object-oriented programming? So these are the different kind of terminologies. Classes are there. There are objects. There are methods. Then on these classes and objects, you apply inheritance, polymorphism, encapsulation, and abstraction. Now, what is a class? Class is nothing but a collection of objects, or we can say a user-defined data type, right? So basically, it's a complex data type which has a collection of objects, and within the objects, you have primitive data types like int, string, float, etc. So a class also holds the methods, the functions which basically perform operations on these objects, right? And also it also holds on to the attributes of the objects. So let's see with an example, right? So if you have an employee class, then it would contain attributes and methods such as email ID, name, age, salary. These are the attributes. And on the methods like, perform task, give presentation, increase salary, etc., etc. These are will be the methods. Now let's talk about what are objects in Python. Now, object is known as instantiation of a class, right? An object is a group of interrelated variables and methods. So when a class is defined, only the description for the object is defined. Therefore, no memory or storage is allocated at that point. So for example, if you see in this, motorbike is a class, but the different objects of that class are different kind of bikes by different brands like BMW, Suzuki, Royal Enfield. So they all have inherited the attributes of the class motorbike, and then on top of it define certain variables, additional variables and methods on top of it to enhance the motorbike and make it look different or function differently. Now, what are methods in Python? Methods are functions defined inside the body of a class, right? So basically, methods are something which you perform on a attributes of a class, right? Method is a function that is associated with an object. So you create an object of a class, and on that object, then you can execute those functions. In Python, a method is not unique to class instances. Any object type can have methods. And the methods define the behavior of an object. So that's why a BMW motorbike will be different from Royal Enfield, because the behavior is different. The methods are different. So if you see the example over here, you have a class bike, and in that there is an init function which will get invoked when you initialize the object of class bike, and then you can set the brand name and the year of manufacturing for that particular object. Now, inheritance. What is inheritance? Inheritance is something which you derive from a parent. So inheritance is like creating a new class that uses all the properties and behavior of another class. Now the new class is called the derived class or the child class, and the existing class whose properties are inherited is known as a base class or parent class. it provides, and the basic functionality, the usage of inheritance is that reusability of code. So if anything is defined in the parent class, then you don't need to rewrite that particular code in the child, you can just inherit it. So as I mentioned, let's take a look at the different types of inheritance which are available. You have single level, in which only one child is inheriting the properties and the attributes from the parent. Then you have multi-level, in which first child has inherited from the class A, class B has inherited, and then you have another class C which is inheriting from class B. So this is an example of multi-level, and we will be supporting all these concepts with an example in our Python notebook. Then there is hierarchical. Then there are two different classes which are inheriting from a single class, and then multiple inheritance, that single class is inheriting from two different parents. So these are different set varieties of inheritance basis what is the demand, what is the business requirement, you can define. Now what is polymorphism? Polymorphism in Python, what does it means? Polymorphism consists of two words, poly and morphs. Poly means many and morph means shape. So basically it means many shapes. So it means using a familiar interface for multiple forms, right? So you can use a single name of the method and which can perform different behavior based on the object in which it is invoked. So in simple terms, we understand that a task can be performed in various ways. Let's support it with an example. Like you have a plus operator. Now the plus operator can be used for integer data types to perform arithmetic operations, whereas when you use plus operator to in string data types, it can be used for concatenation. So it's a very typical example, very good example in terms of how an same operator can behave differently basis what data types are being used. Now let's talk about encapsulation. Using OOPS in Python, we can restrict access to methods and variables. So basically in Python you can create something like as private variables, but of course you can't use a private keyword unlike Java. So in Python we use underscore or double underscore in order to define private attributes. So basically these attributes can be only used within the class and cannot be exposed outside a particular class. So we will see this with an example. Now, what is abstraction? Data abstraction and encapsulation are often used as synonyms. Abstraction is used to hide internal details and show only functionalities. For example, you know how to turn on or off a light using a switch, but you don't know what is happening behind the socket. Similarly, an abstract class cannot be instantiated, which means you cannot create objects for this class. You can only define the methods which have to be implemented by the classes which are inheriting the abstract class. So basically abstract class provide only the method signatures and rest the other functionalities, and the implementation has to be done by the child classes. So let's now move to the our Jupyter notebook and we will start performing certain examples. Now, as we are saying, like Python has objects. So let's create an object. We will create a class bikes over here. And within the class, we will define the init method. And in the init, we will instantiate two variables, brand name and year. Now we will create an object of bike, which we are calling as BMW, and another we will create an object called Ducati. So what we are doing in this two scenarios is that we are just instantiating the bike object with variable BMW and Ducati. We are instantiating. Now let's print the year and manufacturing year, the brand name and the year for BMW and for Ducati, and let's see. Right, so what we have done is we have created an object for bikes. One we are calling BMW and one we are calling Ducati, and how we are differentiating between these two bikes is basis the brand name and the year of manufacturing. Now let's take a look at the example of methods. I'm going to rewrite my init method, and now I am creating a function, a method of top speed and a function of type now I'm going to create an object of bike. Now this method, this object bike, can invoke methods top speed and type because they belong to the same class bikes. So initially when I created my object bikes, I'm instantiating it with BMW and the year, and then I am making a call to the method top speed, and then I'm making a call to the method type and printing. So basically I'm printing the output of the function top speed and output of the function BMW, form the object BMW which is of class bikes. Now let's take a look at an example of single level inheritance. Let's create a parent class called animal and create a method called sound, and let's create a child class cat which inherits animal, and let me just put a method over here. Here's the indentation. Okay, so now I have object parent class animal, child class cat which has inherited animal, and the parent class method is sound and the child class method is meow. So now I'll create an object called cat, and with this object I'll be able to invoke both child class method and the parent class method. And as you can see, the child class has inherited both parent and child class functions, methods. Now let's take a look at multi-level inheritance example. I'll start off with creating exactly the same parent class called animal. Then I'm already created another class. I'll create same child class cat, and now I'll create another class which will inherit cat class. So cat has inherited animal and cat child has inherited cat. Let's validate its syntax. And similarly now I'll create an object for cat child, and this cat child now can invoke the same methods which are in child, parent and the superparent. So this is an example of multi-level. This is an example of single level inheritance. Now let's take an example of polymorphism. We are going to create a class parrot and define the function fly and swim. Now we are going to create another class. Mind you, there is no inheritance here. We are just creating an independent class called penguin. And same methods now, the same name, fly and swim. Okay. Now let's make a function in which we will pass an object, and basis that what is the instance of the particular object bird, the corresponding method will get invoked. So let's see. In the method flying test, whatever instance of the bird object will be, the corresponding method will be called. So now let's create a object of parrot class, and then let's create a object of penguin class. Now in my flying test method, first I'll send a object of instance parrot, and then I'll send the object of instance penguin. So now basis the instance type, when this bird.fly method will be called, it will be called basis the instance. So in the first case, the parrot, it will call this method, and in case of penguin, it will call this method fly. So please note what is the output. The output is a parrot can fly, but a penguin cannot fly. And it has been decided by the Python at the runtime that which particular method to be invoked basis the instance. So it's a very important concept. Now let's take an example of encapsulation. I'll make a class cars, define its init method. Now within that init method, I have created a private variable with underscore underscore max price and given a value of 9 lakh. Now I am creating another function called sell, and in that I am printing the max price. And then I am creating another function in which I am modifying the private variable set max price. So I will pass any value in the set max price, and it will replace the max price which I have set during the initialization at this point. Now let's create an object of class cars. and see if I sell this, then the selling price is 9 lakh, what I had set at the time of initialization. Now what I'm trying to do is I'm trying to modify a private variable directly, c underscore underscore max price, and I want to check if I'm trying to create modify a private variable, will it still show me 9 lakh or 10 lakh value? And it's still showing me the 9 lakh value. It means that I can't directly approach or access the private variable. I can only modify it if I access it through a method which is set max price. In this, now I am setting the max price to 1000, and now if I print what is my max price, it will print as 1000. So this is the concept of encapsulation. You have a private variable which is accessible within only the methods of the class. You can't access it directly. Now let's take a look at hierarchical inheritance. I'll create a class employee and create an init method. Within that, you have three variables: name, age, and salary. So an employee has name, age, and salary. Now I'm going to create a child class called child employee 1, which is inherited from employee, and child employee 2, which is also inherited from employee. So what I'm going to do is I'm going to create a object per child class and print. So this is a typical example in which you have two child classes which have inherited from the single parent, hierarchical inheritance. Now let's take a look at our last concept, which is abstraction. So now I'll create a class car and define a method mileage, but I am not giving any definition to it. I'm just giving a signature mileage. The child classes which will inherit abstract class will be giving the definition. So I'm creating a class BMW, which has inherited the car ABC car, but given the definition now. Similarly, I am creating another class Jaguar, which has inherited the class car, but now it is giving a different definition. It's printing mileage 25 km/h, and another class Range Rover, and another class Renault. Okay, so 4 classes which have implemented the abstract class method mileage in a different way. Now I'll create an object of first BMW and invoke method mileage. So it has invoked the method mileage on BMW car and printed mileage is 30 kilometer. Similarly, I'll do for Renault. Jaguar and Range Rover. So if you see, the parent class, abstract parent class, has not implemented the method but just given the signature of the method, and all other classes have implemented it, and that's the concept of abstraction. So what's in it for us today? What we will understand what is operator overloading and how to overload the operators in Python. We will perform these activities in the Jupyter Notebook. Now, what is operator overloading? Python operators work for built-in classes in a predefined operational way. But the same operator behaves differently for objects of different classes. So you can make the operator work differently basis the requirement you have and the objects you have defined. So for example, the plus operator, which is the most commonly used operator, will perform arithmetic addition on two numbers, or it can merge two lists, or if performed on two strings, it concatenates the two strings. So it means the programming language automatically understands that in which context you are using the plus operator. This feature in Python that allows the same operator to have different meanings according to the context, according to the objects which are calling it, or according to the data types which are being used in that operator, it is called as operator overloading. So if you see in this example, 8 and 7 are the operands and the plus sign is the operator sign. So that is the whole goal of this whole exercise, that we will show you how you can change the meaning of the plus operator depending on the kind of objects or kind of operands you're using along with it. Now, how to overload the operators in Python? Consider we have two objects B1 and B2 of a class batsman. Now we must add these objects with a binary plus operator. So now the task in hand is that we use the plus operator to add objects, which is not possible until and unless we overload this operator. Otherwise, it will throw an error because the compiler does not know how to add two objects. It only knows how to add primitive data types like int, strings, etc. So basically, we will define a method for an operator that process is called operator overloading. So in the example which we will be showing you, we will be taking two objects of batsman 1 and batsman 2, and we will be using two scores per batsman, and then we will add them. So we'll discuss that in the examples we will show you. Now we can overload all the defined operators, so there is no limitation: addition, subtraction, multiplication, division, greater than, less than. So there are certain magic methods, or we can call it as the primitive methods or special functions, that are automatically invoked when an associated operator is being called. So basically, if you have to do the operator overloading, you basically have to override these methods in your Python program, and that's how you will be able to override or overload the primitive implementations of these functions written in the compiler of Python. So let's see here in our example, right? For example, when we use the plus operator, the magic method underscore underscore add underscore underscore is automatically invoked, in which the operation for the plus operator is defined. Now we are overloading it, and in the example you can see we are adding the first score of each batsman, right? So we have customized the addition function. We are adding the first score of the first batsman with the first score of the second batsman, and then we are printing the total. So in our case, we are adding and printing the first one 66 plus 23, or if you print b3.s2, you will see the sum total of 78 plus 59. So the thing to be noted is this function, add function, where you are adding self.s1 plus second.s1, and you are adding s self.s2 plus second.s2, and that is the whole customization what you have done in order to add two objects of batsman. Now let's take a look at some of the examples of operator overloading we have just discussed. So we will be executing some examples in our Jupyter Notebook. Now what I'm going to show you is about a class batsman which we discussed in the presentation, and I'm going to define the init function and initialize score 1 and score 2 of the batsman. Now I'm going to override the magic function add and add the score 1 and score 2 of the batsman separately. Now with this operator overloading, when I will pass object for addition, then only now my object will understand that it has to add score 1 of first batsman with the score 1 of second batsman, and score 2 of first batsman with the score 2 of the second batsman. So we'll see how. So what we are doing is, one in the add operator, we are adding the scores, encapsulating in a new object batsman, and then returning the object b3. Now let's create object b1, batsman 1 and batsman 2. Now I am adding two objects, batsman 1 and batsman 2. Now without operator overloading, if I would not have done operator overloading of add, then this would have failed because plus operator does not understand the object's batsman. But with overloading done, now I can independently print the score of the new batsman, the b3 object, sum of score 1 of batsman 1 and score 1 of batsman 2, which is 66 plus 23. Okay, so now let's take an example of a simple operator function. Like for example, I'm going to simply create a variable a with value 44 and variable b with 7 and print a plus b, and if I run this is the expected output. Python plus operator knows that a and b are primitive int variables, so it's able to add that. Now behind the scenes, when we printed a plus b, actually this is what happened. Primitive int variables add operator overloaded method got called, and a and b got passed, and 51 was calculated. So it's automatically done because this function is implicitly written in the Python language. Similarly, I can also do this thing. I can create a int variable and a float variable, and if I try to print it, I will get the expected output, which is 50.5, because the plus operator accepts the int and a float variable. It's implicitly written, so that is also allowed. Now let's take another example of string operators, string variables addition. Now, irrespective of my, I'm giving numerical values in the string, print a plus b in string is meant to do concatenation. So 446.5, it's a simple string concatenation what Python has